can see it.
Thanks. So what we'll do is let me present to the meeting. And I hope you have followed up this installation instructions. Just very quick update on the installation instructions is there are 2-3 ways I have mentioned it here. So let me just go through this anyway. So simplest way is Docker desktop. So install using Docker desktop, but some companies don't allow Docker desktop because Docker desktop has been made commercial. Docker is still free. Docker desktop has been made commercial for some companies with certain turnover or a certain number of employees or more. So if your company is falling under that category, then don't install Docker desktop. Incidentally, the company where I work in, they have told us not to use Docker desktop because of these restrictions. But there are some company, and you would have gotten an email if your company does not allow that. But if your company allows it, then and you are using company desktop, company's laptop, then feel free to install Docker desktop. That's the easiest one. Additionally, if you are using your personal laptop, then also you should install Docker desktop. This very less setup you need to do. There is another one, Docker CLI with Minikube. Will be using Docker machine and Docker CLI. That's what I will be using, but the commands are also same except the start command, which I will be starting Docker using Docker machine. If you're using Docker desktop, you don't have to worry about that. It'll automatically start it for you. But I will showcase this using Docker machine, how to start and everything, so that if you are using option 2, you can use that. Option 3, I will not be going through this. I have experimented it and documented it works. So if you want to use Podman with Minikube, you go ahead with that. Docker desktop has everything installed, Docker and Kubernetes. But if you are not using Docker desktop, you have to install Docker separately and Kubernetes engine, which is Minikube, separately. So that's option 2. And option 3 is instead of Docker CLI, you could use Podman. So the only difference between Podman and Docker is, you replace Docker command with Podman, everything works. Or you can alternately set an alias Podman as Docker. So you can run Docker command internally running Podman command. Everything else is same. So just follow these instructions, and hopefully most of you have already done it. So what I'm going to do now is we are going to cover the basics of Docker, and it's very simple. We'll not be going into details of Docker. The Docker itself is a huge things. So we'll covering only those aspects which we'll need for Kubernetes, and as you go along, you will be discovering many things yourself. So first of all, what is Docker? So all this Docker and Kubernetes is containerization. And right now, let's just focus on Docker. Once we cover Docker, then I will explain you how Docker and Kubernetes are related, or any container engine like Docker, how that is related to Kubernetes, how Kubernetes uses Docker image and things like this. I have a diagram for that. I will explain you. But for time being, let's focus only on the Docker. So Docker is an a container engine. So it's open platform for, and why do we need it? What and why? It's an open platform to developing, shipping, and running applications. So very brief summary of this is, our traditional model of development and deployment is that we write our code on the local laptop, and we do unit testing, and then we push the code into the GitHub. And after that, our Jenkins jobs, if it is the proper CI/CD setup, Jenkins jobs take it. Assume our local laptop is in our local development environment is Windows or Mac. Then the CI/CD job will take it and publish it to the QA environment, for example, or dev environment first, depending upon how your CI/CD flow is. Generally, it goes to dev environment. Your dev integration test cases get done, and after that, it goes to QA environment. QA integration test cases get run, and then it goes to canary and production. Now, one of the problems you would have seen is that people say it works on my laptop, but why it does not work in QA, or why it does not work in production? And the problem is that the main such problems come because the environments are different. Your laptop is your local dev environment could be Mac, but your QA environment could be CentOS. Your dev environment could be CentOS or Ubuntu or things like this. There's mismatch in the environment. The configurations, the setup are different, and that is what Docker tries to remove. You could have every development in your Dockerized environment, push it, then only the Docker image will keep getting created. Test it out, create a Docker image, test with Docker image, everything works fine. Then you push the Docker image, and that Docker image will be taken by the CI/CD process. And what that Docker image is, how does that solve, we'll go over this. But Docker images basically contains all the dependencies and your code together, so that there's no problem in the environments. Whatever you have tested in your dev or in your local, same will be tested in the queue, and same will get deployed in production. So those problems won't come. And that brings the second point. This way your delivery will be fast and consistent, because there will not be an environmental difference, and it will be responsive deployment and scaling. So scaling will go into the Kubernetes and see how to scale it up. Docker also has Docker Compose. See, with Docker you can set up, you can have only one instance of your application running, but you have orchestration engine like Kubernetes or Docker Compose. There is one more I'm forgetting. Docker Compose, we will not be using it, but it is also is an orchestration engine which can scale up your application. We'll be focusing more on the Kubernetes, but Docker Compose is an alternative. Some people do use Docker Compose as well. Running more workloads on the same environment. Docker Swarm, Anshul, Docker Swarm was another one. Running more workloads on the same hardware. I will show in the diagram. You can have one hardware where you can have multiple Docker containers running, so you can optimize your hardware as well. This is a diagram. This is how virtual machines used to work. I don't know how many of you know virtual machines. Earlier, there was virtual machines are very popular. You could they tried to follow the similar pattern, that you use virtual machines to deploy your applications and then take that along in different environments. But it's heavyweight. Virtual machines are heavy. So take this example: you have a physical machine, over that you have host MS. Then you have some virtual machine, hypervisor, which deals with virtual machine, creating the virtual machines and all those things. And then you have guest OS. And then over this guest OS, you have their own, each guest OS its own library. Then application is deployed over this. A VMware, so VirtualBox is one, on your local laptop. If you ever dealt with virtual machines, you would have installed a virtual machine using VirtualBox or VMware Player. It has free version also, VMware Player. So you would have used one of these, and you would have realized yourself that it's pretty heavy. If you ever use any of these, you have to open VirtualBox or VMware Player, start the machine. It will ask how much memory you want to give, minimum 8 GB to 12 GB, or that much memory you give to that. It's as good as a different operating system running on your machine. So one is your laptop or host operating system, and second is VM operating system running. And it used to be pretty heavy. That's, I'm talking about your local setup. But in production, this is how the environment would look like. You compare this with container. So in container, you have server and you have host OS, which is here also, and then you have Docker engine, and that's it. You don't have guest OS and many. These are the heavy, heavy things you don't need. And then you have your application deployed inside the containers. We will also deploy application inside the container, but this is how it works in production. And there are, you can share the main libraries, some binaries and everything you can share across. For example, this application, A needs the same, binary. Application B needs the same binary. So this can be shared. So that's why container is very lightweight. And if you ever use Docker, or I'm sure you must be using it, compared to VMs, the load on your system by Docker images is pretty less. Now, having said it, if you have so many Docker images running on your local laptop or any server, that will also slow it down. So it's not that it's a magic bullet, but compared to the VMs, it's pretty lightweight. Now, how Dockers work? So I will go through the theoretical part. Then I have a practical example of this. I will go through that. So let's say you are trying to create a, you start from scratch, correct? And when you start from scratch, you are writing a code, and that code you want to be published as part of a new image which you will create. And we will do that as part of these sessions. So first thing you do is, as part of your code base, you create a Docker file. Now Docker file, what is Docker file? It's a text file only. It's a text document containing all commands a user could call on the command line to assemble an image. Basically, all you will do is that what your image will have, what are the things in your, which your Docker image will have. You mention all of that in the Docker file, and we'll see example of that. There's a reference of this. You can see the reference of this. I've given some example. Once you have a Docker file, you write your code, you have Docker file, and now you want to create an image. That to create an image, you use Docker build command. And to use Docker build command, I have the instructions how to use that. Basically, Docker build command will read the instructions in the Docker file sequentially one after another, and it will create a Docker image. Now your Docker image is created. Now what you do of the Docker image, generally, if you are doing some experimentation or something, then you can keep the Docker image on your local environment itself. But generally in companies, they have their own Docker repository. All big companies will have their own Docker repository. JFrog is one tool, one of the many tools which companies use to host their Docker images. JFrog is used to host many other things also, like your Maven jars and all those things, but it can be used to host your Docker images as well. Some companies have subscriptions to hubdoc.docker.com, wherein you can pay some amount and you can have your private repository. They have a limit, like if you pay this much, then these many private repositories and these many users are licensed or things like this. So either way, or if you don't have anything on hub.docker.com, then I think they allow you up to I don't remember the exact number, but I think 4 or 5 private repository they allow, and after that it has to be public only. Public means anyone can access, and I'll show you how that all works. So and now we'll go over the Docker file. So how Docker file looks like, and I have an example of this. I will be explaining a few of the things, and then what Docker file we are using. We'll go over this, but I will not be able to cover each and everything of the each and every directory of Docker file. So I have given you a link which has every command of Docker file. You can go through that, and you can reference that if you forget something, or if you're trying to do something which I will not be covering. So you can always refer that. The first instruction in your Docker file is this hash syntax docker /dockerfile :1. So basically, it tells Docker which password to use. And if this at least when I wrote this was the latest one, and it's a comment. You can see it's a comment. It's just an instruction to your Docker engine. Now every Docker file will have a from command. And what this from command is, basically you are telling, you build this Docker file over this image. Now, what is this image? Some image would have already been created. For example, if you don't want anything, base images, if you want to work on CentOS or Ubuntu or things like this, or Alpine. Alpine is the Linux flavor, which is pretty lightweight. So you can say from CentOS. So it will take the CentOS RAI image. Where will it take it from? If you don't do anything, then it will try to directly connect to hub.docker.com, and will try to put the CentOS image from here. Whatever image name you have given, it will try to pull that image from there. If you have your own internal repository in the company, so generally, if you are working on your local environment, so and you want to test it out, so on your command line you say docker login and give your URL of the company repository, and then it will ask you the username and password on the command line. You can give that. In the CI/CD, the CI/CD setup is by default configured in companies to connect to their own repository, so that they can pull these images which is given from in this from command, and whatever image you will produce as part of your your code base, it will CI/CDs will be pushing into that custom repository itself. So from is the base image name, and it should be there in the repository. And I will open the hub.docker.com. I will show you a few of those, there. Work directory, it creates a working directory on your Docker image. And I will show you the example of that as well. And once you create work directory on the Docker image, it will use this directory for subsequent commands. So anything you do after this will be, the Docker will assume that it's as good as you have used cd/app. Here I'm giving /app, right? Work directory /app. So it's as good as cd/app, and every other command will be under this. For example, next command is copy from to. So it copies directly from your local system to the container. Now where will it copy? So let's say on your local system you are in folder, and in that folder you have a file abc. So you're copying abc to some folder, to some other folder. If you don't give, if you just give normal path, let's say copy abc, then let's say t1. So it will assume that there will be a folder called t1 under app, so it will copy it there. So here the path is, and I'll show you an example of this. So if you don't understand now, you will understand with the help of example. So path is relative to wherever Docker file is, right? So this path is relative from, and you can give dot dot slash or slash something slash something. So you can do all of that. Run, it runs a new command. It runs on the top of new layer of current image. So it has two, so run has two forms. The shell command. The command is running a shell, which by default is bin/sh-c on Linux. Or you can run using, you can pass an array of parameters. So generally in array of parameters, you pass an executable, whether it is .sh file or some executable file, and the parameter it takes. It does not invoke a command shell. Here you are invoking a command shell, separate command shell. It runs in, this command runs inside this, but here it does not invoke a command shell. It normal shell processing does not happen. So for example, if you are running, say, run echo home, it will not do variable substitution on home. It will just try to run as is. So I will see some example of that. I have used this run, in one of our, we have used this run, this flavor of run command in the Docker file, and you will see example of that. I'm running my application using this run command. So run is one command. Command is command to run when image is executed inside the container. So so there's a difference. So run on top of a new layer on the current image, and command is command to run when image is executed inside a container. And I think I have used one command example also. We'll see. Docker build is the command which we use to build a Docker image, and it will build a Docker image from the Docker file. And we optionally use tag parameter. Then but why do we need tag parameter? We want to be able to specify certain tag, certain version, for example, to the image we are building. If you don't pass a tag parameter, if you don't pass this, then it will, if you don't pass even tag itself, then it will be defaulted to latest. So now let me stop it here. We'll go to the example now, and this is the example I have. This is the example. By the way, I hope you have checked out the Spring Boot application on GitHub. It's mentioned in the setup guide, in the instructions thing. So we'll be using this application. So what we are going to do now is we'll go over this, and then I will we'll create a Docker image, and then we'll stop it there. So as we mentioned, the first syntax, first line is syntax Docker file :1, and I'm using this base image, adapt OpenJDK 16. So let's see what this image is about, right? Because I will be using normal Docker, not my company's repository. So this image should exist on the hub.docker.com. So let's try and see that. So if I go here, sorry, let me go here and say, let me close this hub.docker.com. And I search for this. So you see, this is an image. So I click on this. And if you want to use it outside your, you don't want to use in Docker file, you just want to install it to command line, you can always use this. But this is the image, and there are various builds of this. So you can click on, for example, the build, and it will show you how this image got built. This is a Docker file of this image itself, right? So we are using this image in our Docker file, but this image will also would have been created using some Docker file. And that Docker file of this image is here. So you can go through this. It has used Alpine, which is again the base image, one of the Linux flavor. And it has used all the instructions. Like I think it has installed Java and it's set up Java 16 is installed, and it has some Java home and everything. So for us, everything is ready-made. We don't have to do any of this, which it does, setting up Java and everything. We get it out of the box. And whatever new things we want to install over this, we can put that in the Docker file. So now, and this Docker file is in the, I have created that under tips_Java folder. This is the sample application we'll be using to deploy and everything. So what I do is, we discussed about the work directory. On the container, it will create a work directory called /app. Then it will create .mvn files, because it's Spring Boot, it will have .mvn folder. So I'm making it copy .mvn folder into .mvn. Now where this .mvn will go? This .mvn will go under this /app folder itself. So you will have /app/.mvn. Then I'm copying mvnw folder. So there's an mvnw folder also. This .mvn and mvnw folder I'm copying because Spring Boot needs it to start. And I will show you, this is how I use run command to start this. So I copied this mvnw folder also. This also goes under a /app folder, pom.xml, which is, if you worked on Maven, there's a pom.xml which which Maven needs. So that will also go and go under this /app. And whatever else we have, whatever else I have, dot, and then I copy that as well. I copy source, and this is this is the source file which I have. This is source folder, which contains all my Java code. You don't have to know Java, or you don't have to know Spring Boot. Just understand this is source folder gets copied under source. Source dot means the existing directory, which is /app, and under source folder it will get copied. There's a conf dir I have here. So this, and what is the purpose of this conf dir, I will explain in subsequent, when we reach Kubernetes. But right now, consider this is a folder, and I'm copying this folder into conf dir folder under app folder. There's a readme.md. I'm copying that also under the current folder, which is app folder. And only thing which I do is I echo, this is a command which I run. So if you see, there are multiple, run commands I have. You can have only one command here. If you have multiple commands, then only last command will be taken, but you can have multiple run commands. So I echo it, I want to see what is under, app folder, and it prints that. Now after app folder, now I'm changing my work directory to etc folder. And once I'm in etc folder, I'm making a directory here. I'm saying run make directory. So I'm creating a new subdirectory called conf dir. Why I need to do all of this? When we reach Kubernetes, there are certain things which I was trying, and you will see in the sessions when we reach Kubernetes session. Only for those I needed this conf directory under etc folder. It has not bearing on the Docker, on running the application itself. So you take this exercise as if you take these commands to learn what run command can do. So I created a directory called conf directory. And then I copy this conf directory on my current, which is this, into the etc conf directory, because here under etc I created this conf directory just now. Then I run one command and say echo, show me what is inside etc conf dir, and I run this. This is just experimentation. I just wanted to experiment and see what all the things I can do in the Docker file. Then I again run the echo command and I say cat this file. So there's even tips controller. If you go to source, you need to worry about only two files into this. One is tips controller and another is the application, and I will walk you over what controller does. You don't have to know Java, you don't have to know Spring Boot, because I have written it for you. Basically it exposes some REST endpoint, and I'll show you what it does. But to complete this, I just cat this Java file. There's no specific reason to do it. I just wanted to play around and see what all I can do. Then after this, I go back to the app folder again. Now what I do is I run this mvn dependency go offline. This is a Spring Boot specific command. Only thing you need to learn is, because I am using Spring Boot, I am using certain external dependencies, and those dependencies I have specified in pom.xml. So if you go to pom.xml here, So these are the dependency which I'm using. So what I do is I tell a Docker file that whatever dependency, this you can go to the documentation of the Spring Boot command. It has nothing to do with Docker as such. It's more of a Spring Boot command, but in short, what I'm trying to do is all the dependency which I have, I will be download that dependency, sort of club this together, because I'll be running this application in the offline mode, which means I will not be connecting to internet. These dependencies are getting downloaded from internet. So download it once, run this command, and then and then run this application in the offline mode. So this is a run command, and then after this is done, I run this command, and this is where I run. I say I run this application Spring Boot run, and once I run this Spring Boot run, because the dependencies have already been downloaded and made available to run in the offline mode, my Spring Boot application will run fine. So what we are going to do now is we are going to see the controller, because that's what we'll be using mostly. And I will be showing only one part to this. If you don't know Java, if you don't know Spring Boot, don't worry. Only thing which I do into this is I expose this, I expose some REST endpoints. So one of the REST point which I'm exposing is the get REST endpoint. And if you see, if you pass, focus on this path tips, if you say localhost, if you say host colon port and /tips, then I return something. So this is a JSON I return. So tips DB URL is default host I am passing. If you don't set it up anything, then this is a variable name which has default host value. So it's a tips colon default host colon first tip. That's all you get. And we'll see that right now also. How does that work? There are other methods also. I will cover those methods as we go along in the Kubernetes. I will be using these methods in the Kubernetes as well. But for timing, this is what we'll do. Now let me go back to the code, and I understand it might be too much for you, so don't get overwhelmed. I will just revise and summarize it towards the end. So before I do that, let me start my Docker thing on my local. So as I said, I have used Docker machine. So let me see the status of Docker machine. Again, I'm iterating. If you have used Docker desktop, you don't have to worry about it. In Docker desktop, you will get an icon here, Docker desktop icon. Click on that. It will say Docker running and Kubernetes running. If it is running, you don't have to do any of these things which I am doing, because Docker desktop will take care of you, take care of Docker and Kubernetes for you. What I'm going to do is I'm going to do Docker machine.start. So I'm starting the Docker. I will not be starting Kubernetes now. I'll be starting only the Docker machine here. And once it starts, it will give you certain couple of more commands to run, which I'll be running. And then after that, I'll be creating the Docker image using the Docker file, which I just showed you. So because this is Docker session, I will not be using Kubernetes, but when we reach the subsequent session in the second or third session, Minikube is the one which I will be using using as a Kubernetes engine. So it has started a Docker machine. And if I run this, it is telling me to run this command. So I run this command also. Once I run this command, it's telling me to run this command. It is telling me to run this command. So I will run this command as well. So now if I go here, if I go here now and I say Docker image ls, so you can see these are the images which I have on my local laptop. This is what we just saw. And this is what I built, and we'll build this again right now. But if you go to another terminal and you say Docker image ls, oh, I had already run this command. Okay, let me open another terminal. So if I open this terminal and I say Docker image ls, it won't run. It says this is a problem. So for this problem to go away, and Docker is already running, so only thing I need to do is I need to copy this command and run this here. Now I say Docker ls. Now I can see all the images. Now that's about the Docker setup and seeing the Docker image. I will go through a couple of more commands in sequence, and so I think this have gone through this. So you can clone this application from this. Send me your GitHub ID if you don't have access to this. It's a private repository. I'll give you the access. So we have gone through this, and you will see the same thing in the Docker file there, which I showed you. This is a Docker file. This is the Docker file, and you can have docker ignore file also. It helps Docker, ignore these directories when searching for file provided in. For example, when it's a copy everything from my current folder to the some folder in container. So if I have some folder inside Docker file, it will ignore, for example, target folder or something which I don't want to copy. So I can put that under Docker ignore file. What we are going to do now is, you have seen the Docker file. We are going to build this now. So this is the command I'm going to run: docker build -f tag, then the name of the image, and dot. I'm telling dot means current directory. This is the directory where my Docker file is, because Docker build needs Docker file to build it. So what I'm going to do is, now you see here, you can always see Docker images also, Docker image ls, both commands I'm fine. You see I created this 4 weeks ago. So now I'm going to do is, I'm going to go to my code, cd where my this where my this application is there. So I'm going to go there, _java. Now I'm going to run the docker build command. So docker build, then -f tag, then here java this name can be anything. I have given java -docker _skh, and then dot, where my Docker file is. I run this. Oh, I did not give 2 hyphens. So now it's building the Docker file. So it's using the cache, because I hadn't built it again. So it sees successfully tagged this file. Now if I go here and run this command again, it still says, let me see, there's no change, so it's not reflecting that. So I can always say docker build, and I say -no cache. So it will not use cache. So it will build everything from scratch again. So remember, in my Docker file, I have given cat commands and everything. So this is a cat command I wanted to see, because it's not from cache anymore. So it's printing it's getting this Java file here. So and it's building everything again, because remember, in the Docker file I have mentioned this MVN dependency go offline, so it will download all the dependencies. So this is what it is trying to do now. And after it is downloaded, it will create an image and everything. So then we will be able to see that image, new image got created here. I have not, so going back to this, I have not given colon some version number, but you could always give that colon version number. And this we saw Docker images, you can see. We'll try to run this with some new version also. We'll try to run this command also, and we can see this new version appearing here in the Docker images. And then we'll I will run the container using this image on my local. Remember, I have created the image on my local. I have not published this image to any repository yet. It's all on local. So we'll create this image and we'll run this container. And in the next session, we'll see how to deal with this container. There are various container commands. We'll be running many of those container commands. We'll be testing this application also to make sure it's running fine. I'm able to access the endpoint and everything. We'll be doing that as well. Then in the next session, we'll see how to publish this image into the Docker repository also, hub.docker.com. We'll see that as well. So if you have an account there, good. If not, then create a free account on hub.docker.com. So I think I will pause it here for time being. It will take some time to build, because there are a lot of dependencies. It will download. It will take 3-4 minutes. So so let me pause this recording. So what I'm going to do now is I'm going to create a Docker image with this particular tag. So let's see. No, I don't want to tag it. I want to build the image using this. So I'm tagging the latest with version. So that also is one possibility. So you can always say Docker build this, and you can give this, or you can, whatever has been here. What I'm trying to do is, there's a latest tag, and you saw the latest tag here also. This is the latest tag for this image. Let's try this anyway. So I am changing the latest tag to version 100. So what I'm going to do is I'm going to set this. So now I will set Docker images again. Yes. And you can see I have the another 100 tag. I have the latest one also. I have, but I tag this as 100 also. Now, if I don't want to use 100 or I don't want to use any of these, I can always delete it. So this is a command docker rmi. So here I'm giving the image name, which is this, and let me put this underscore skh and the version. Sorry, syntax error. So now if I see this, so now 1.00 is not there anymore because I just deleted it and I have the latest one only. So that's one. Now let's try to do one more thing. Let's see if this works or not. Let's take this. What I'm going to do now is, so I will try to build this, and I say docker images, and you see 2.00 is also there, and docker images, docker image, ls, both are the same commands. I see latest is there, 2.00 is there. I want to delete 2.00, so I can always do that. Now 2.00 is gone, so I have the latest one. So with this, I conclude today's session. Let me pause the recording. Basically, you must have run some of these commands already, but it's just, and I'll be repeating some of the commands in many slides for two reasons. First, to keep it reiterating this common command so that you remember, and second, those commands, the whatever topics I'll be covering in different slides, those commands are needed there as well. So I think you have done all of this. Once you start the container, one thing you can do is, you can give -p. I think in one of the assignment I saw, I think Vishal gave -p. So you can give -p, and then it's a port forwarding. So this is your port of the host, and this is the port of your container. You can give -P also. What this -P, if once you give -P, then you don't have to give any of these. You don't have to give port, host or container port. -P means whatever ports are exposed on the container, whatever ports are there on the container, those will be exposed on the host by default. But I'm using -p, so -p. This means that 8080, in this case, 8080 from local will be forwarded to 8080 on container. So last time when we started the container, we went inside as part of your, we went inside, and then inside we did the wget command or curl command to invoke the Spring Boot service. You could invoke it from outside also, from your host as well. And this is what we'll do. So now if you're using Docker desktop, you could only use, once you start your container with this command, then immediately after starting, you check if this container is running using Docker container ls. If it's running fine, then you can use this command wget or curl on the localhost itself to get from 8080. Now you are running on your localhost, which is the host. Then this port forwarding will come in play, and it will route this 8080 request to the container 8080. But if you're on Docker machine, this command will not work. So on Docker machine, you have to get the IP address of your host. And how do you get the IP address? Using Docker machine env. So this is what I have done here. So if you see Docker container run -d, then -p 8080 I have given, and the image name. And then I do Docker container ls. Then it shows me the container is running. And then I want to know the IP address of the container. So I use Docker machine env. Then it gives me Docker host, and this is the IP address I get. Then what I do is I say wget and paste this IP address, then :8080, then /tips. /tips is where Spring Boot service is running. So once I do that, it gives me the the output of this result of this Spring Boot service. Then I cat it, this is the result I'm expecting, and this is the result I get. So don't worry about the syntax and all of this. This is what I'm sending it from the from a Spring Boot service. Now, so this I did outside the container. So we will be, discussing later when we reach Kubernetes, on Kubernetes clusters, various ways of exposing the, the service, which is inside the Kubernetes cluster to outside world. But for Docker, Docker container only, this is one way you can, access the service inside the container. So, okay, so that's about the thing. So this is the output of what I just showed you. Now, last time when we were discussing the Docker file, we discussed two commands, two Docker directives, run and cmd. So I want to explain the difference between run and cmd. The difference between run and cmd is in the run, you can have as many run commands as needed. Those run commands is, image build step. For example, you want to, you can download something using run and install, using something run. So those are, the building steps to the image. And, so the run is image build step, that is state of the container after run command will be committed to the image. So if you, we will not go into details of this, how image is built, but at very high level, when you are building the image from the Docker file using Docker build command, image is built into layers. So whatever commands initially you have, that's the first layer, then next command is the second layer, and third command is third layer, and so on. So that's how image building works. This run command, it gets executed during image build time and gets written to the Docker image as new layer. This is what we just discussed. Now, what is CMD? So CMD is the command which is executed when container is starting. So it is not part of the image. So for example, the Docker file which you have used, I have used CMD command to start the Spring Boot application. So this is one use case of, this is one place where you can use CMD command for a web application. CMD can start the application, because Docker, when container is starting, I want to start the application also along with that. The command the container executes by default when you launch the build image. So it's just a reiteration of what I said. When container start, or when you launch the image to start the container, this is the command which will execute. Ideally you have one command, but in case you make a mistake and you have multiple commands, then whatever is the last command, Docker will use that. It will, ignore the previous command. Sorry for the misspelling. It's the command can be overridden when starting a container with Docker run. So when you see Docker run and you can give other command, then this command which you have given, it can be overridden. So it will use that command. I think we have used in, someone was asking me, so we used a Docker run -d, and then after that we have given command tail -f/dev/null, so that container does not crash. So that would have overridden any command which was in the Docker file of that image. So this is a difference between a run and command. So this is again a reiteration of some of the commands. So if you want to run Docker container in an interactive mode, so you want to see what is happening, then you don't use -d option. So then whenever you start, you can start seeing the logs also, and on one terminal, and when you're on another terminal also through some other application, you're accessing that container, you will see the logs on the console itself. But when you do Control-C here, your container automatically stops. If you want to use, so here we have used -d commands everywhere. Where did that go? Docker container ls. So here I have used -d command. So the reason I have used -d, if I have not have used this -d command, then I will not get this console. The whatever logs I am having, whatever you see in Docker logs, those logs will be appearing here. It's as good as in this application, this container is running on this terminal. And when you do Control-C, without giving, I don't give -d command, I run this, then I do Control-C, then container will automatically terminate. So -d means detached mode. So once I do detach, it's running in the background, and that's how I can see container is running and do various things with that container. you have seen that if you want to see the container image is running or not on local machine, you can use Docker container ls, or you could use a Docker PS also. This as part of the assignment you have done. So you can log inside the container using Docker container exe -it and give this container ID. How do you get this container ID? Using Docker container ls or Docker PS. So for example, I have given Docker container ls here, Docker container ls, and this is my container ID. So this is a container ID you give to log into the container itself, to go inside the container, like as if you are SSHing into the container. You can stop the container. So Docker stop container, Docker container stop container ID. So let's see, I can stop the container now. So Docker container ls. Now this is a command, Docker container stop, Docker container stop, and you do this, and this container is stopped now. So if I do this container ls, and now there's no container running, correct? So so these are some of the commands. And now what we'll do is, now you want to publish this command, publish this image. You use Docker build to build that image. Now you want to publish this image to Docker Hub, because Docker Hub is available to everyone, and your company might have subscription to Docker Hub, and they might tell you to publish the image there, or they might be publishing the image there, or the company might have internal repository. So follow the documentation of your internal repository how to log in. But for the Docker Hub, you just say Docker login, and it will automatically log into the, you give the user ID, password, and by default, you are not giving any URL or something. So it will automatically log into hub.docker.com. So what we do is, if you want to see the more detailed documentation, what are the different options and all those things, of while pushing the image to the Docker Hub, then you can follow this link. Now I will do this. So just before this meeting, what I had done was, so earlier I had pushed one image. So let me show you. So I had this image earlier, 1.0.0, and I had pushed 7 months back, and 23 days back I had pulled it or something, right? And this is the documentation I had given. And now what I did today, just before this meeting, was I did this. Where did that go? Sorry. Here. So I have the Docker machine running. So on this terminal also I enabled it. Then I did Docker build tag, and I gave the different version 101. It was 100 earlier. It was 100 earlier, and then I get 101, and I am in the same folder where Docker file is. So I give dot. So I build that image with version 101 for me. Now I did Docker login. So this successfully tagged with version 101. You can see with version 101. So then I did Docker login, and I had logged in some time back, so it had saved my credentials. But Docker, you can create a Docker user ID free of cost. And so you can, whatever credentials you create during, while you're creating your account in Docker, give that credentials here. It'll ask for the user ID, password, give that. And after that, it logs you in, and you should get a message, login succeeded. Now I am logged into because I have not given any other parameters. So by default, it logs into hub, Docker hub, hub.docker.com. Now what I am doing now is, after login is successful, I am pushing this image, Docker push, and this is the image I have given. And I think user ID is needed, and the image and the version. So it was 100 when I'm pushing 101. So it pushes that image and then it gives you, all these logs and everything. And if everything is fine, it just finishes. So now after I push this image, then this is the screen which I had opened it and I did not refresh it. But after I pushed, I could see 101 also here. So you can see few seconds ago. So if I refresh this now also, you could see this 101 is available. Now the consumer of your Docker image have options of using the whatever version. You could use 100 also, they could use 100 also, or they can use 101 as well. So either of both options are there, and you can give documentation for each of these and everything. So those things are possible. So it's still refreshing. So once it loads, then you could see the both versions available. This is the older one which is without refresh. So you can see, right, just 34 minutes ago before this meeting, I did that. So, and anyone wants to use, they can use this command, docker push user ID, my user, I am the owner of this, and the image name and whatever tag they want, 101 or 100 or whatever. Right? So that's about how you push into the Docker Hub. This is the URL, hub.docker.com. Once you go here, it will ask you to log in, and there will be sign in option. If you already have credentials, use that sign in option and log in after pushing your images, and then you will be able to see your images. If you don't have a user, then create one and use the same credentials to push your image, and then later check that image here as well. And this will be available to everyone. I think there is a free, because I am not a pro, I have not taken this thing. So in the free, you can use one private repository. You can't have more than one private repository. This is the repository. If you want to have more than one private repository, you can upgrade, but you can have as many public repository as you want, even in free also. So mine is free, and this is my public repository. Anyone can use this. But generally in your enterprises, you will have the Docker Hub type of system. We call it Docker repository internally. And those internal systems like JFrog is one which companies use. Those will not be visible to anyone else outside, because they will be part of your organization network, or if you're on cloud, then organization VPC or something. So you can go to JFrog. I had not looked at JFrog for a very long time, but you can go to jfrog.org. Okay, JFrog has its own website. Sorry, JFrog. So you can go to JFrog website, and they give the free version, and you can paid also, and they have all sorts of things you can use that. I have used the free version of this in one of the startups where I had worked. So see, this JFrog container registry and all those things are possible. Okay, now going back to this. Again, just a repetition of command, copy paste Docker container ls. This is how you see. You can stop the container and you can restart. But if you want to remove the container altogether, you can use Docker rm. So let's see that Docker rm command also. So this is the so this container is removed now completely. Well, so I could have shown one more thing. If this container was stopped and not removed, right? I stopped it, I did not remove, then I could say Docker container ls, then -a. So in -a, it would show me the stopped container also. Now it won't show because I removed this, but we can see if there's anything else. So these are the containers, like I was playing around the Flink and everything. So these containers I started and stopped or things like this. You could see all of those here with -a. If you don't give -a, then you see only the running containers. Docker inspect, you have already seen. So it gives the low level information in your assignment. I think many of you have done it. So it gives low level information and more details about a Docker object. So I have not pasted everything. I have given some of these. I have given the Docker inspect of something, and then some details I am seeing here. There's some commands, some commands you have used, and some commands are repeated and some commands are new here. One is thing, you can use Docker build -tag, and you can give no cache. So no cache is whatever it had previously built, it maintains in the cache. So it will, as I said, images are in layers. So, and each, like whatever commands you are giving in your Docker file, so they are building the layers. So let's say you change your Docker file, and you keep everything same, only last 2 commands you change. Then if you don't use no cache, if you use this, then what it will do is whatever layers it had built with the commands which are not changed, it will use those layers. And then whatever new commands have been, or the new commands have been added, or the existing last commands have been changed, it will change the new, it will build a new layer only for those and create an image out of that. But if you do no cache, then it will not use any of this, it will build everything afresh. You can use Docker image prune or even Docker image prune -a to remove any image which is not associated with at least one container. So this, sometimes, in your production server also you might be using this, but at least on my desktop, when I was using this a lot, a lot of Docker images I have, downloaded and installed, and eventually I realize I have, hundreds of images, and I am not using those anymore, and I don't need those. So I use Docker image prune to remove all those images. So Docker image ls show the images. Like when you say Docker pull and then give the image name from the repository, then that image gets downloaded onto your onto your system, or you build your own local image, like we have built for this application, Spring Boot application, which is only on your laptop and not on the any repository yet. If you don't push it to repository, then those images will also be available using Docker image ls. Basically whatever is on your system, whether it is locally built or whether it is pulled from the repository, all those images you can see using this. Docker container ls we have used many times. This I have explained in detached mode. You can log in inside the container using this command. exe-it means interactive, give the container ID, then --bin bash or bin sh or whatever. You can use this command. It will log you inside the container. This is a command, this is a reference. You can refer a lot of commands. Docker commands are there. You can see many commands here. Some of the it has, I don't know the number here. I think it has 100 or 150 commands. So if some command you're looking for, then and you want to see the documentation of that command, you can go into this URL and look for that. Some of the commands, good to know commands, I have pasted here. For example, if you want to search for some image, so I've given this example here. So if I am searching for, I wanted to search for Apache Spark. What are the Docker container, Docker images are available for Apache Spark. So I say Docker search Apache Spark, and these are the images which are available. Some people might have pushed public repository or something. It's up to me. How do I want to, which one I trust, and how do you want to use it? If someone is official image, generally on the, you will see this official, it will say yes. And on the Docker hub.docker also, on the website also, it will be a batch saying official image or something. So so this is the way you can search the images. You can pull the image. We have seen that Docker pull image name, and you can give the version. If you don't give the version, it will pull the latest image. We have seen Docker image ls command. Alternative command of that is Docker images. So it will show the list of images. Docker run, we have seen various versions of Docker run. You could use Docker ps also. So for example, instead of instead of doing Docker container ls, I can use Docker ps. So right now no container is running, so let me run one container. So this is the command. The command I will use to run the container, and then once container is running, I can use Docker ps. It's as good as Docker container ls. Let me show you that. And you can give name also. We have not been giving name. Using hyphen name, you can give name. If you don't give, then it will automatically get some random name for you. So and you can see, like you can see Docker container ls hyphen a. Same thing, you can see Docker ps hyphen all. So you can see all the container, even stop containers also. You can stop the container. I think we have done that. I showed you using Docker stop. You can restart a container using Docker restart. You can rename the container. You can see Docker rename old name to new name. This we have seen multiple times. You can go inside the container. This Docker logs. This was part of the assignment. You want to see the logs in the container. You can say Docker logs and container name. You can remove the container. This is an important command if you want to remove the container as well as the image which is using the container, or the image of that container. Then you can use Docker RMI container name. It will remove the container along with the image also. This will just remove the container. It will still keep the image. So that's about the Docker reference. So I'll discuss the Kubernetes architecture. What are the different components in the Kubernetes architecture and what each component does. And some of the things you might be hearing, actually most of the things you might be hearing for the first time. While explaining those things, there will be certain words, certain functionalities of Kubernetes which will be used. And I will give you a gist of that functionality, what that functionality does, but we'll cover those in details in its own section because I have section for each functionality. And when I explain in a short, if you don't understand, you can we can discuss. Okay. So what is Kubernetes? I think you all might have heard Kubernetes, and you might have a good idea. So what Kubernetes does. So if I have to, we'll go through this for definitions, but at the end of the day, it's an orchestration of your images. So you have Docker. Once you run your Docker container with your Docker command only, then so it's just one Docker container you are running, right? If you want to run multiple, then you can't run same container multiple times. Same service has to be applied on multiple nodes. So it's the same container type on multiple nodes. So Docker command itself won't do it. So Docker Compose can do it, and I think Swarm can do it, and the Kubernetes can do it. Kubernetes is more popular because of its architecture and has more flexibility. And we'll go over this. So it abstracts away the hardware infrastructure, exposes data center as computation resource. So what you put in data center, your virtual machines, and those virtual machines have your data centers have physical servers, and on physical servers we have virtual machines deployed like Hyperion or things like this. Hyperion or VMware also has something like this, which manage your virtual machines. And all those virtual machines, your application is getting deployed. So what Kubernetes does is it exposes that as a resource, like with any software resource, so you can manage that. So microservices architectures use Kubernetes a lot these days. So if these days, if you are developing any microservice, it has to, if it is not containerized, then make sure it is containerized, and either it uses the Docker and Docker Compose, or it will use Kubernetes. So this is a modern way of developing the microservices. The coding is not going to change. The coding you are still doing in whatever technology you are using, but how do you deploy? How do you wrap that application? You use Docker Kubernetes mostly. Now it's a consistent environment for dev, queue, and prod, because you saw, right? When we create a Docker image, we give the from and the beginning. Now, what do we give in the from? Like an existing image we have, like a CentOS or something built over CentOS. We use OpenJDK and or Maven JDK or something. So that image is already built, and we are adding our own code over that, or an own configuration or code over that. Now that code, whatever that image is created from there, that image is going to remain same. Whether you run in you can test that image in your dev environment, or QA environment, or in production environment. So that image is going to remain same, and no one is, so if you have dealt with production issues, you might have encountered scenarios where the people say it's working in QA, why it's not working in production? Because certain memory was different, or certain configuration was different, maybe number of threads were different. I don't know. So some configuration in your code got changed because it is not, in the legacy world, it's not wrapped as an image. Your image has everything. So there is no, so that's why there is no, there are very, still you get some components here and there, which Kubernetes can't handle, but more or less the environment specific issue gets taken care. Easy CI/CD setup, because now, it's dealing with images, and images has everything sort of wrapped inside the container and everything. So these are the advantages of Kubernetes. Now what we are going to do is we are going to go to Kubernetes components. Now I have 3-4 diagrams. So same Kubernetes components or same Kubernetes architecture is represented in 3-4 ways. The idea is to the more you go through these diagrams, the more type of diagrams you go through, the more understanding you get, and more clear it becomes. But all will be similar. All 3-4 diagrams will be similar. So what is Kubernetes component? So there are 2 types of Kubernetes components. One is the control plane, and it's called sort of master node or something. And then you have a set of worker nodes, which we call nodes. And in control plane, which is master node, in Kubernetes world, master node is not called master node, it's called control plane always. So so you have the API. So this is the API server, which is exposing the APIs of Kubernetes. So we will be running certain commands on Kubernetes using command line, kubectl or something. But those commands internally are invoking this API itself. So whatever you want to do with the cluster resourcing, scheduling, etc., that is taken care. So you have to send that request to API. The second component is scheduler. What scheduler does is scheduling. When we are programmers, sometimes we think scheduling is cron syntax or something. This is not that scheduling. So this scheduling is you ask for a pod, and we'll discuss what pod is. And a pod is basically containers. There's a wrapper above containers which is called pod, and pod is a Kubernetes terminology. So once you have the pod, and once you ask Kubernetes to have your two containers in the pod. So so once you have two containers or one container or whatever your architecture is inside a pod, and you tell Kubernetes, now you build this pod for me. Then what Kubernetes will do, it will use a scheduler service. So scheduler will check whatever nodes are having the capability of having the pods deployed on them. So it will create on those. So this is called scheduling. And we'll see what pod is and all those, and scheduling is also, we'll see that. So what etcd is, etcd is a sort of thing. It's the cache having key value pair, because Kubernetes stores so much information about you, like pod name. We will be discussing about later about namespaces, labels, and things like this. So it needs some sort of data structure, or what you call where you store the information, right? So etcd is what it uses. Etcd is an open source also. So Kubernetes uses that in the control plane. Now, what is running on the pod? So you have this, kubelet. So these APIs, when get invoked, they talk to kubelet only. So kubelet is an agent running on the worker nodes. So this agent is, sort of issuing the or doing whatever it has been asked by the components in the control panel, and the API is the component which tells it to do whatever, like spin up a pod or things like this. Then kproxy. So whatever you have deployed on your worker nodes, like some pod is deployed which is running some service, and like our service, whatever service you are dealing with, so it's that service is might be is running inside the pod, and inside the pod it's running as a container. Now and I have a diagram for that. I will show you that in a while. Now that service needs to be invoked. So how do you invoke that service? So the kproxy, so any external commands coming, any external requests coming to access that service go via kproxy, and kproxy implements some rules and everything, and we'll discuss that. So so scheduler we discussed, node we discussed. We'll discuss so we'll discuss each of these in detail. Controller manager and API server we'll discuss in detail, but let's go to the I have descriptions for each component also separately. Now this is a different diagram. Similar information showed in a different diagram. So so you have control plane. So this control plane is a master node, as I said. It has API server, it has scheduler, it has controller manager, and it has etcd. Then you have worker nodes. Each worker node has a pod. Pod consists of one or more containers. There's a Docker environment, because these images, I will discuss the environment also, because Kubernetes supports more than just Docker as well. But assume these images are in Docker, so there will be a Docker environment, and then kubelet and kubeproxy. So, and this API server can be invoked from the user interface, from the kubectl, or maybe you can directly you can invoke the API directly also, which generally is not the practice, but that option is also there. And much later in our session we'll discuss how to do that as well. Now moving on. Similar architecture in different way. So you have a control plane, you have worker nodes. So there are many worker nodes. You have in control plane you have API server, which talks to etcd, scheduler, controller manager. Kubelet is agent running on worker nodes. kubeproxy, container runtime. This container runtime. So in the previous screen we showed Docker. Here we are showing container runtime, because Kubernetes, as I said, supports more than just Docker. Similar architecture in a different representation. So I'll skip that because you know that already. Only thing you will mention, you will see that the call to the services, see, where from the external world is coming. Some services deployed on some container inside the worker node. This is a pod, and some container, or maybe these are the pods. I don't know what's trying to represent. So this is a pod, and this is a container, and this container has a service which needs to be accessible by the external client. So that external client is the internet, invokes it, goes to queue proxy routes it to the proper container. Now we'll go into the each of these components, whatever components we discussed, we'll go into each of these. What is cluster? So we you will hear a lot of these terms, cluster and all those things. So what in reality is a cluster? So cluster is, cluster has set of worker machines, which we call nodes, and there has to be minimum one or more nodes. Then, and these are worker nodes, by the way. And these nodes run containerized application by hosting pods. And we'll spend good amount of time discussing what pod is and how do you create and modify and things like this. So pod is a wrapper which can have one or more container. And that happens only in Kubernetes. If you look for some pod concept in only Docker, it won't be there because Docker deals with container directly. Kubernetes deals with container with using pod. So nodes run containerized application by hosting pods. So pods have one or more containers. Now control what is this control plane does? It's a master node. So we discussed about the worker nodes. Now this is a master node. So control plane, which is master node, manages nodes and pods. Now, how does it manage nodes and pods? We'll discuss in coming slides. But generally, control plane runs on multiple computers or multiple machines to provide fault tolerance. Right? If it's a master node in reality, if it goes down, then your cluster can go down. So for fault tolerance, it generally it runs on multiple computers. We'll go into the control plane components in little detail. First is control plane. What control plane itself does. So control the cluster and make it function. So when pod is created, when pod gets destroyed or when the node gets destroyed, what should happen and all those things. Basically, it's responsible for making the cluster work. And it is decision maker for cluster. For example, you have specified that your service is inside the pod. Now, if that pod, and you can say because your service is very popular, so one pod might not be enough. So you say I have this container in my service. My service is inside this container, and I want to have 5 pods. So there will be 5 pods created, and each pod will be having this container. Now, what if one node crashes which had this pod? So then control plane will detect it and immediately start that pod on a new node. Now this control panel, which is the master node, consists of many components. And as we already said, so we are reiterating it here. So the control panel can run on the single node, or it can run on the multiple nodes for high availability and things like this. Control panel has these components: API server, scheduler, controller manager, etcd, and we'll discuss each of these now. So, what is API server? So API server is basically you and other control plane components communicates with. So if I have to communicate to the Kubernetes cluster to spin up a pod or a service or things like this, then I will be interacting. I as a client will be interacting with the API server, whether I'm running kubectl command or UI or something internally, that is interacting with the API only. It exposes Kubernetes API, of course. It is front end of the Kubernetes control plane, and the implementation of API server is a Kube API server. So you can go into this link and read more about this Kube API server. So I will recommend that you go through this. Go to this link. If you search for Kube API server on Google, I think this is the first or second link which comes up anyway. So go to this link. It has many details. So we will not be covering all those details here, but to just give an idea that this is the responsibility of API server. Now the APIs are exposed using REST endpoints. So ultimately it's a REST endpoint only. It manages pods, services, replication controllers, etc. And we'll discuss each of these in details in coming sessions. A scheduler. So see, we discussed API server now. Now we are on scheduler. So what does scheduler do? So it schedules container across nodes using pods. So it watches newly created pods with no assigned nodes and select nodes for them to run on. So if someone has requested a new pod to be created, so the pod gets created, now it needs nodes where it needs to run on. So that's why scheduler comes into play. So basically, at very high level, what it does, it assigns pods to nodes. So whatever in a pod, I can say, there are two containers inside the pod, and run this on, I have two replica. So it will start on two nodes possibly, and whichever nodes are free, this is a responsibility of scheduler to detect which of these nodes this pods needs to run on. So how does it do that? It is based upon available resources, hardware, software constraints, support needs to a certain memory and all those things. So whatever nodes has it, then it detects it. So it ranks each valid node and binds to the pod to a suitable node. So if there are many nodes, it just keeps ranking, and whatever is higher in the rank, it just assigns it. A cube scheduler is the reference implementation. So maybe like the way we saw, this cube API server. I forgot to give the link, but you can go and read about the cube scheduler also on the Kubernetes IO documentation. So that's about scheduler. What is control manager? Controller manager, sorry. This controller manager, it runs controller process. Now, what are these controller processes? So this is the third component here, you can see, right? So what are the controller processes? So you have, there are many types of controllers. One is the node controller. So node controller is responsible for noticing and responding when node goes down, right? So this is what we said, right? The Kubernetes takes care of node crash or something. So that's the node controller. And these are all part of controller manager. Job controller. So we'll have a job object also in Kubernetes, and we'll discuss what this job object is. Watches for job objects that represent one of tasks. So if you're running some task, background task or something, so then it creates pods to run those tasks to completion. So then endpoint controller populates the endpoint object. For example, service, it joins services and pods. So what is pod? Pod we already discussed, right? A pod is having container. So you cannot just deploy only container on the Kubernetes. So container has to be part of the pod. Now this pod needs to be accessible outside. So for that, you create a service object, and we'll discuss in details with example how to create service objects and everything. But for time being, understand that if the pod has to be, if the pod exposes REST endpoint, then it has to be accessible outside so that external customers can also use. If pod is only running background job, then of course job controller takes it and run the background job when it needs to run. But if pod is having the services which needs to be exposed outside, then service object is created, and then it basically joins, binds service to pods or something. So that's called endpoint controller. Service account and token controller create default accounts and API access tokens for new namespaces. See, so we'll discuss what namespace is also. So generally namespace is like, if you have, generally companies have one Kubernetes cluster, and there are different teams which use the Kubernetes cluster. So each team is assigned certain namespace. That's how even in current company it happens. So each team is assigned namespace. Now, so if you assign, each team needs to have its own namespace, then there is some infrastructure thing which needs to happen, right? It needs to have its own account, it needs to have its own API access token, so that if I am doing something, if I get access to Kubernetes cluster, I should be able to do something only with my services. I should not be able to hit some other services to which I do not have access, or which I should not be accessing, or things like this. So that is taken care by service account and token controllers. There is a cloud manager controller which links the cluster to cloud provider APIs. So see, what we are discussing now is Kubernetes. There are each cloud provider has there's a Kubernetes service. There's Azure Kubernetes service. It's called AKS or something. Then AWS has its own Kubernetes service. Google Cloud has its own Kubernetes service. So they do also provide certain functionality. So if you're dealing with and we will not be discussing those here because we'll be focusing on the core concepts of Kubernetes. But once we're dealing with the cloud providers, then the controller manager might have a cloud controller manager also. So basically, because whatever you are creating, for example, you are in AWS, you are creating you ask for a new pod, or that pod has to be a EC2 instance has to be created for that port. Now, how do you create that EC2 instance? AWS has APIs to create those EC2 instances. So maybe Cloud Controller Manager will deal with those APIs and get the EC2 instance created and things like this, and then port, get the port deployed or, so these are controller. So it also performs cluster level functions like below. So replicating components, tracking worker nodes, handling node failures. So I think we have, node failure, worker nodes, when they go down, when they crashes, then this controller manager detects it and, starts it. If some components need to be replicated, for example, we discussed some, some components need to be on high availability or something. So then controller manager is responsible for that. etcd, we discussed this. It's highly available key value store for all cluster data. So what is this cluster data? You're getting ports, namespaces, labels, jobs, services, and so many other things. Controller manager also might be creating some data. So the ports, their states, their namespaces. So Kubernetes needs some way of storing this. So it's distributed data stores which stores cluster information, and it should be backed up. By default, backing up is not enabled, so you have to back it up. And you can go to this documentation to see to tell. See, you might never need to deal with these components yourself. You will be mostly dealing with the kubectl, or your CI/CD process might be dealing with this. So that you might need to understand what is namespace, what is pod, what is service, what is job, and things like this. So and internally Kubernetes, once you tell, and how do you tell Kubernetes will discuss it, that I want a pod or service or a job or things like this. So you can tell Kubernetes in certain way, and we'll discuss what is that way. But once you tell Kubernetes is what you want, then Kubernetes internally will deal with all this control panel and node and what are components on this. Kubernetes internally will deal with that. You might want to, like, if you are an admin or something, you might really want to know the etcd things, or the API server or things like this, unless you are invoking API directly, for example. etcd is a separate open source framework, so you can go into this documentation, and you can go to this license also. You can use it outside your Kubernetes implementation as well. Now we'll go to the worker node components, what those components are. So kubelet, right? Each worker node has kubelet. So what kubelet does is an agent running on each worker node. So it monitors containers inside pods, if they're running or not running and are healthy, and it talks to the API server and manages container on its node. Like even when you have to start the pods, and everything. So kubelet only is invoked, and if they are not running or if they are not healthy, then it talks to the API server. And API server, if let's say something crashes, then kubelet will detect it, and then it will go to the API server. The API server will tell scheduler, and scheduler will schedule it, or things like this. Kubeproxy, it load balances network traffic between application components, maintains network rule on each node. So this is the kubeproxy, and on the each node, so it maintains a network rules on each node. What is network rules? Network rules allow network communication to the pods from inside or outside the cluster. So you can invoke kubeproxy from inside the cluster also. For example, I have 3 pods and 3 different pods, and pod 1 need to access pod 2 using REST endpoint. So it goes via kubeproxy. Or pod 2 can be accessed from outside also. So that also goes via kubeproxy. So user must create a service with the API server to configure the proxy, and we'll discuss how the service needs to be. Service and object. So these pods, services, namespaces, all those are objects. And maybe today, if you get time, we'll discuss, how to create a pod also. So it hides all the pods from the clients. So, clients don't need to know, where that pod exists and things like this. So clients just need to know this is the service which is to invoke, and this is a REST endpoint, and it can just invoke it. Intercept requests destined for cluster IP and routes it internally to the service within the node. So you might be on this worker node, there might be many pods running. That's a possibility. So it intercepts the request which is coming and say, okay, this is the request for this service, and which is inside this port, so it routes it there. So that's about kubeproxy, and you can go and read about kubeproxy in the Kubernetes IO also. It has a lot more information than I'm just representing, but you might not understand all of it. But Just go through this and see what all you get, get from there. Now this container runtime. So container runtime is a software. So remember in the diagram we see one place Docker and second place container runtime. So container runtime is the software that is responsible for running containers, because ultimately inside the pod you are running containers only. And Kubernetes supports several container runtimes. So Docker is one container runtime. Container D is another container runtime. CRIO is another container runtime, and any implementation of Kubernetes CRI interface. So Kubernetes CRI interface, you can read the documentation from here, which is container runtime interface. You can implement your custom also if you want. And and your the images, Docker images are all these images, Docker container D CRIO adheres to this. So that's why Kubernetes is able to understand and spin up pods containing those containers. Now, how does control panel and node communicate, right? You might not need it initially, but you might need to understand once you set up SSL or something. So you might need to know such information. So node to control panel. Node is worker node. To control panel, to master node. So nodes or pods or nodes communicate or interact with only API server control panel, right? So nodes connect to API service using client certificate. See, these are all REST endpoints. So there is a separate topic I have secrets how this communication works, because if you are if these are SSL based REST endpoints, then there has to be some certificate setup and all those things. But and it in the API server needs to know this request is coming from genuine client or something like this. So this is how the communication happens. So for you, if you want to just take away only one thing from here, and that thing you should take away is node talks to the API to the control panel using the API server only. If control panel has to talk to nodes, then API server to kubelet. So it for fetching logs. So kubelet is the agent we discussed, right? It's running on the worker nodes. So it connects to kubelet for fetching logs, attaching to running pods, and we'll see how to attach to running pods also, etc. Terminate at kubelet HTTP. It terminates at kubelet HTTPS endpoint. Kubelet is also has an endpoint. It terminates it there, and after that, it's a local call. Kubernetes will just delegate it to Kubernetes will do kubelet will do whatever that call is asking. So API server to nodes. API server can connect to nodes also. It can connect to ports also, and it can connect services also, like services which we have exposed to be, which we have written, which needs to be exposed to the outside world. So API server can connect to each of these as well. And this is a reference documentation. You can go and read more about this here. There are various add-ons to Kubernetes cluster. So list of add-ons is here. So let me open one, and you can see there's many of her. And one thing which I was reading is if you want to have some if you're bugged in any DevOps, if you know about DevOps work, they need to collect some data from your service and put it into some server or something where you can see. And so some of these are do this and some of these have different functionality, but idea is that there are add-ons available, and these are third-party add-ons not given by Kubernetes. So if you check these add-ons, if anything is needed by you, then you can use this as well. Kubernetes. So now how running Kubernetes works. So this is probably the last slide here. See what you do, and I have maybe in the subsequent session I have one more diagram which depicts this. So what you do is so what you all did what we did last time was, so we created an image and put it to image registry. So we use Docker Hub only for image registry, correct? And it just has all the app description and everything. Then this image registry is once you tell this is as part of CI/CD process, or on you might be issuing commands manually also. Now you want to use this image in this image registry, and using this image you want to build some pod because you want to test it, you want to do whatever you want, and but you need to have your service which is part of this image to be deployed on the Kubernetes cluster. So you issue a command to control panel, Then what control panel will do is, control panel will tell kubelet to do something. Then kubelet will connect to so there's a Docker runtime environment. So what happens is, once the control panel receives the request, it has to be deployed. The image gets pulled from the image registry, and then it gets deployed on the, see, this is Docker runtime environment, it connects the image registry. So it pulls that image, creates the pod out of that image, and we have seen how this controller manager and all those things work. So and scheduler basically. So once pod is created, then scheduler will allocate those pods to the different nodes. So then so that's how it works. So you can see these are the different services. This is a container image. This is a container image which gets pulled, and then this has, when you have this is multiple containers running inside one pod. This is one pod, this is another pod, and these are multiple containers running. And these pods are built on the images which has come from the image registry only. And when did they come? When when someone, either some automated process, CI/CD, or some user manually issued a command to tell Kubernetes that I want pods for these images to run. And how do you tell images inside the pod? And we'll see that. But there is a way to tell that run the pod which uses this image, and you can give replica and all those things. So you issue that command to control panel, it goes to Kubernetes, Dockers pull the images and deploys, and to and fro communication happens, pod gets created, scheduler and all those things assign nodes, and all those things happen. So this is how, and I have another detailed diagram step by step how this happens, but this is just to give you a high level idea that how the image comes from the Docker registry, image registry. It need not be just Docker, it can be any. We discuss what other type of runtime it supports. So it can be any image, but in our case we'll be using Docker image. So from image registry, how image comes and how it gets deployed and everything. So so that's about the Kubernetes architecture. So now we'll discuss Kubernetes pods. So what this pod is, how this got created, and things like this. So we'll go into details of pods later, but what we'll do is immediately we'll start a pod. We'll create a pod, and and then we'll see if the pod is running or not running. So this pod will have the service which we are using. For tips, we have the Spring Boot testing point. So we'll deploy the service inside this pod, and we'll try to access that pod like we did for Docker also. So first of all, you can, so there are multiple ways. You can create a YAML file also, and you can invoke the APIs. We'll be dealing mostly with the YAML files. In the YAML files, you can give the definitions and whatever, etc. So YAML file has the YAML file code for Kubernetes has a standard. So we'll start with the pods, and we'll see what each of these means and what we are specifying. So if you want to know, Kubernetes, this thing, what you should pods, what is the standard for Kubernetes pod? What you should do is, and I have this in the different documentation also. 1 second. Sorry, I made it worse. What I wanted to show was this command. You can say kubectl explain pods. So what it does is, once you explain the pods, it will tell what each syntax.
Sandeep, we have the YAML file option, and what is the other option?
Vandana, can you hold on your question? It's getting recorded. I don't want questions to be recorded. Sure. So hold on to your questions. So so this is so you can do the explain pods. So in pods, it will tell what is this. You have this kind, then this version. What is the description of this? What are the different fields you have? API string, API version. What this API version does, and things like this. You can go through this. But what we'll do now is we'll go through this ourselves. So, so what we are telling is for Kubernetes to create an object, and that object is of type pod. And the Kubernetes should use API version. Each API version of for pod, might have different values here, but we'll be using API version 1 and type of pod and some metadata. So in metadata, this is mandatory. We specify the name of the pod. This is the name of the pod. Then the specification of the pod. Now, as we discussed, the pod contains containers. So we are specifying the, with the specification, and inside the specification is in, what is the, what is inside the containers. So we tell containers, and then we say containers consist of image. This is the image name. This is the same image which you have created using Docker command. If you are logged into your, so generally what we'll do is, for our testing and practice, we'll be having that image only on our local, and we'll be pushing from local. But generally you will be logged into, if you're doing on some testing on your laptop itself, so you might be logged into your Docker repository, image repository, like Docker Hub or something like this. Now, so we are telling, this is the image, and version we are giving latest, but you can give any version. Image pull policy is if not present. What is this image pull policy? Image pull policy is that when should Kubernetes pull this image, the name you have given, from the image registry, like Docker Hub or your internal company image registry. You can always say always. So it will always, pull it from the image registry, and you give always when you are using the image which you have not created, someone else has created. Then you can say always take, from the image registry. But we'll be creating image on our own, and that image when we create the image using Docker, the image will be on our on our system itself, on our laptop itself. So we don't want it to go to image registry and pull again and again. So if you remove this, then it will try to go to image registry and pull it, and it takes time. I didn't want to do it, so I said pull from the image registry only when it is not present on the local. If not present, only if it's not present on the local. So that's what image pull policy is. Command. So when the pod is running up, what command I want to give? So this is the command I want to give. I want to run my application. So this also has, this container which uses image has also has a name. So I give this name, and the pod. Hey, people, please go on mute. Now all this getting recorded, and it will be published for everyone in future also. So we are exposing the port 8080 on this container, and how we'll access and all those things. We discuss the service object. So we will not be discussing service object. So we'll be using port forwarding for time being, and maybe in the next session we'll do it. But idea is that the container port, the container port is 8080. Now you have given this specification. Now how do you tell Kubernetes? This is a YAML file. Now how do you tell Kubernetes to run this? So use this command kubectl create -f and give this file name. This specification is stored in this file called create-pods, and it's part of the GitHub repo. You have to ask for access. So this create-pods YAML file is there in that GitHub repo itself. So now once we let me show you. I just ran before this meeting. So let me close this. So so this is the pod. So I started my servers and everything, and then whatever ports I had deleted, that. Then when I say kubectl get ports, I don't get any port. Then this is what file I was showing. So create-pods.yaml. So it has API version 1, kind pod, metadata is this. Then this is a specification of containers and things like this. There's a liveness clause. Don't worry about this liveness clause. We'll discuss later. Basically, it tells where your service is running. You just keep checking after these intervals. So we'll come to that when we discuss the liveness clause. But here I am giving this command to run and everything. So then I use this command kubectl create -f create-pods YAML. This is a file name, and it says this got created. Now how would I know it got created? So I issue kubectl get pods. It show me this pod and say it's ready and running, status is running. There has not been restart. If there's any problem in your configuration or image is not available, you will see many restarts happening here. But luckily everything is fine. So it 0 restart. Now I want to see the logs. So I can give the kubectl logs, and this is the pod name, right? When you say kubectl get pods, this is your pod name. And this pod name, so I give this pod /pod name, and shows me the logs, like it would have started, pulled the dependencies and started and everything, right? It shows me that log. Now what I wanted to do was I wanted to go inside this pod and do something. So I say same, like similar thing which we did with Docker, we'll do for Kubernetes also. So kubectl exec -it, and this is the pod name. This is not the container name. This is a pod name, and then give okay, go to bin as such. I could be bash also. So I went inside this. I did bash, and then I gave wrong command, so it exited me out. So but I went again, and the wget was not available. So I used curl command. So I went inside this pod again. Ultimately, I'm logging to container only, and then I use the curl command. This is the service which we are deployed, right? So I use the curl command, and this is the output we got, and so that's it. So that's how we are able to create pod. We are able to create our container inside that pod and be able to access the container and everything. What we'll do in coming session is we might spend little more time on these specifications and this YAML, and there are many extra things which I'm going to this YAML. So we'll be spending significant time on pod YAML only for time being, but also we can do in the pod and what are the other configurations available. So but for today, that is it. So one of the things I forgot to tell you, and is that if you are using Windows, then there is one file, Docker file for Windows. So generally, as we discussed, there is there's a window puts its own characters, and we want to convert to Unix characters. And if you want to use the same commands to start up and everything, here you should use this as a reference. So we install DOS to Unix. We need to install there, and once you install DOS to Unix, then we run this DOS to Unix mvnw, because apparently this mvnw file is the one where Windows was putting its end of line character or something. So if you run DOS to Unix on this, and then we follow our usual run this in offline mode, and then we run our Spring Boot application like this. So let's try it out. If it doesn't work, let me know, then we'll discuss. So now we'll go back to the pods. So last time we had created a pod, and we had gone through this diagram earlier also. So I will go through the diagram once again, just to refresh and to give you a complete picture what happens after you create the image, and from that image how that Kubernetes creates the image. Kubernetes creates the pod. So you create the image using Docker. So this is a command. So you're using Docker build, you sort of create an image, and using Docker push. So this Docker build will create the image on your local Docker push, and you can issue this command, or sometimes if your automated process CI/CD is doing, that can issue that can also issue that command. But for our testing, we only will be doing all of this. And you have done this already. So Docker push will push the image on the local from the local disk into the Docker image repository, Docker repo. So this image will go here. Then so this image is in the Docker now. So assume that you want to run this image from Docker, from the Docker repo or image repo. So you can run this using kubectl YAML or command or even API. And we have seen the YAML file of type pod, where we create the image, where we run the image. So either using YAML file or using command, you run this using kubectl, you run the image. So what happens during that is, when you use kubectl, you have given all the thing, image name and everything else, and kubectl takes it invokes the REST API server of Kubernetes. Now we are in Kubernetes cluster. You see big rectangle is Kubernetes cluster. In the Kubernetes cluster, inside master node, which is control plane, inside control plane, REST API gets invoked by kubectl. Then based upon whatever definition you have given, pod is created, and it's scheduled on the worker nodes. So that scheduler takes care of it. So how it schedules on the worker node? The control plane node, which is the master node, calls kubelet on whatever scheduler tells these are the worker nodes or which this pod should be scheduled. For those worker nodes, kubelet is invoked. There is a runtime environment. In our case, it's Docker. So kubelet has Docker to run the image. Docker will go to the image repository. It can need not be Docker. It can be this repository need not contain Docker image. It can contain any image. So, but we are dealing with Docker image. So this will go to that repository, look for this Docker image, gets a Docker image, and deploys it, and then image start running, right? Because this is a Docker image, Dockers can pull it from here and then deploy it. So and it sets, as I said, right, pull from image and sets up the pod, and that's it. So this is a total workflow. Now your pod has a container which has the this container in the pod is Docker container which has this image running which you have mentioned. Now what is pod? We'll go a little bit into details into the pod. So pod is a group of one or more related containers. So you saw, how you can create more than one containers inside a pod, because containers is a plural. So you can add as many containers as you want in the pod. They always run together on the same worker node. So if you specify more than one container inside the pod, they will always run on the same worker node as part of the same pod. And they run in the same Linux workspace. They have their own IP address, host name, processes, everything is same. So now service we will discuss later, but just to give you an example, let's say you have one pod 1 has 2 containers running, pod 2 has another 2 containers running, and see A, B, C, D, and like this. Now you want to access, for example, some container. Then what happens is you invoke a service which we'll discuss later, and each pod has its own IP address. So you remember that each pod has its own IP address. So now this, when you are accessing container, service X provided by container C. When you're accessing a service, you don't access container directly, you access a service, and this service is provided by container C, for example. And let's say container B is trying to invoke that service. So container B will hit the service object, which we will create in some further session, and that service session identifies, okay, the service which is being asked is in container C, and then this points to that pod, and then within the pod, the call goes to that container, and it's a sort of load balancer type of thing. There's a separate load balancer also, but because containers in 2 different locations, so it might route these calls according to the load or something. And we will discuss service in much details later. And now if you want to list the pods, this command you will be using quite frequently, kubectl get pods, or short abbreviation of this is kubectl get po. If you want to see details of the pods, you see kubectl describe pod. Now, why do we need pods? So often a set of containers need to be grouped together, as they might need to share files. Let's say some system is writing to the log files, or some system is writing to some file, other system has to read from the same file, something like this. Or you might need to share files for whatever other reasons also. Maybe your log file where you're writing is a NFS or something. So one is writing, another is trying to read and forward it to Splunk or something. That's another reason. So there could be various reasons, or another reason could be that so you are writing, it's mostly files, or there is some you have some application which needs for performance reasons, I don't know, you want to have some reference database mounted on this on the same pod, so that your application layer can read it. So that's another reason you might want to have that database and the pod in the same container. Depending upon your business logic, there might be multiple reasons. And so a set of containers will group together for whatever reason I mentioned, or they connect with each other, or RPC, remote procedure call. So because of these 2 main reasons, grouping of 2 containers might be needed. When I say grouping of 2 containers should be inside one pod itself, because IP address it is a pod. So these 2 containers can talk to each other properly. So because they share the same network and same Linux space, which I mentioned, have the same host name. A container can communicate with that container in the same pod through localhost, right? So you don't have to get the pod IP address. It's 2 containers on the same pod, they can communicate through localhost. Now you want to see the container logs. So if you want to see port logs, you can give kubectl logs port name. But if you want to see the container logs, you can give the container ID. How do you get container ID? You have, and we'll see example of this. You have described the port. So kubectl describe code. It will give you the information, all the information, including containers inside the port. let's run some of these commands, and we'll see. So I have run few of these, but I will start from here. So I want to get port, for example, kubectl get ports. So one port is already running, so I will not restart it. So I would say kubectl describe port. Kubectl describe. I can say ports and give this name, or I can say port slash this also would work. So you can see a lot of information about this. It tells when it started and everything. We'll talk about load selector also, and the commands which it used. Run this is the container ID. See, I was telling you, right? You can get the container. This is the container ID inside the port, one container only. This is the image container is using. This is the image ID. I have not given any port or something, so it's not showing. And this is the IP address of the port. We'll discuss the labels also. There are some ports can have labels which are key value pair. I will discuss it. So it shows those. This shows the node name and the node IP address over which this port is deployed. And this is the name of the port, and namespace also we'll discuss later. So you can get this information by using port describe. Now you want to see the logs of the port. So you can say, let's see the port name again. So kubectl logs, then port slash, and this. So this will show you the logs if you want to see the what happened inside the port something. To see the container of the to see the logs of the container, I will leave it to you. You go and do that as a homework. So if you want to see the container logs, issue this command. Port network. And now that if ports want to communicate with each other, so on one node there can be multiple ports. So this is one port inside node A, and this is another port, and these are the IP addresses. Each port has two containers, container 1, container 2, and this is the IP address of each port. So they can directly access using the because they are part of Kubernetes cluster, they can directly access each other using IP address. No need for NAT. So when you access, so NAT is, what is NAT? So NAT was network address translation. It generally involves rewriting the source or destination address IP packets as they pass through a router or firewall. And you can read more details about this here. But in this case, there is no need for that. It just directly IP invocation would work. We already discussed this ports create. So you create the port via REST endpoint by passing YAML or JSON. You can, that's one way. Other way could be that, you don't have YAML or JSON. You directly invoke command line, which are, kubectl image command, kubectl run image command, where you can pass the parameters. And this was the assignment also. So that's another way. Third way is you can directly invoke the REST endpoints. The REST endpoints payload and everything is properly documented in Kubernetes documentation, and we'll discuss that also in some further session. So now kubectl explain ports. So let's run the explain command also and see what happens. So I will again get a port, kubectl port. I keep forgetting the name, so for that name I keep using this command. This is the name. So kubectl explain. Sorry, I didn't this name honestly for this. So what I want from explain ports is that what is the version it is using for type port and the description. So in this we already saw description and the API version. So what this API version is and details of API version, kind of course is port. So it explains about this metadata, spec, status. So I want to see what are the things inside a port, what are the properties of a port. pod. So I can use explain pods and I can see at high level, this is what it is. There are lot many things go inside the spec. You can go and read, I think, inside this, what are the specs and all those things. And we'll have a lot of examples too, for various values inside each of these. If you want to see only the specific version, so you can say kubectl explain pod.api version. So let's see that. kubectl explain API version. So it will tell you only about the API version. If you want to see spec, so you can see. So this is a spec, whatever is inside spec. See, earlier we saw when you say explain pod, it just gives spec. But if you want to see what is inside the spec in the YAML file, these are the properties you can give inside the spec, and many of these will use. Right, we will not use all of it, but many of these we will use. Right. So this is the spec. This is inside the spec. So I will again reiterate. So if you see only pod, it will tell you that this is the spec and just give you 2-3 liners of spec. Now, if you want to see what is inside the spec, what all you can give inside the spec key. So these are the things you can give inside the spec key. Volumes for volume mount, some service account. So there will be nodes restart policy, node selector will also be there, priority is also there, node name, and all those things. So this is what all you can give. Now, so what we will do is, as part of this exercise, we'll always, most of the time, almost all the time, we'll create pod using YAML file, and we have YAML file for each type of pod. When we discuss different topics, for Kubernetes, we'll have YAML file for each of these. Now, if you want to see how we have created our YAML file and given to the Kubernetes, and Kubernetes created a pod. Now, if you want to see, how the complete description of the YAML which Kubernetes might have used, it might have done some things of its own after getting our YAML. So I can, we can see this. We can use this command kubectl get pod, the pod name, and then -o YAML. So let's see that. So this is our pod. So kubectl get pod, then -o. So this is what this is the YAML for this pod produced by Kubernetes. So you can see this, and whatever value you have given, for sure those values will be there. But it adds some of its own also when it got created. This we had given, and this I added what's a UID. This added by default. This commands we had given. This we had given, but then this they had, it added itself. So some things it adds. Sometimes we might need to refer some of these properties. So we can use this command. Container status is, it tells this the container, it's ready. There's no restart on this container. It's already started. State is running. It started at this time and so on. Port IP address is this and all those things. Now coming to pod dashboards. Generally, you can look at the logs. We saw that you can look at the logs. You say kubectl logs, then pod slash. I forgot to pod slash here. Pod slash and give the pod name. You can see the log, and we saw that just now. You can look at the dashboards also. Kubernetes, these are Kubernetes dashboard. These are not pod dashboard. It's a Kubernetes dashboard. So if you are using Docker desktop, then on the Docker desktop icon at the, once you click on Docker desktop icon, it will show an option of dashboard also. So you can select that option and it will show you something like this. But if you are using Minikube, then you can start the dashboard using Minikube dashboard. This is what I have done. So I said Minikube dashboard. So it started the dashboard for me. And then this is the dashboard. This is a dashboard. So you can see all of this. Like I have pods running here, and all of this will cover cron, daemon, deployment, job will cover in session. So this is a pod which is getting deployed. I can click on this pod. It will show me a lot of information about this pod. Cluster, roles, namespaces, nodes. Only one node will be running here, which is Minikube, because it's my local machine. If you want to see details of this, you can see all of this. about this node and everything. If you are on real cluster, it will show set of nodes, and you can see details of this. So you can look at the Kubernetes node for all such things. When we discuss each of the section, when we discuss cron job section, for example, and we create cron job, that will start appearing here, right? So so far we have discussed only pods. Okay, that's about the dashboard. Moving on, you can create a pod from the command line without YAML. We discussed that. You can say you can run kubectl run -help for details. Some two examples I have given. If you want to run nginx image, uh, you could very well say kubectl run nginx image nginx, and that would have done the trick, because nginx image has its own properties and everything. If you want to override some of the things, right, because when you give to Kubernetes, we discussed that you could create your own YAML and everything. Or if you run this from this command, this we are not creating any YAML, we are telling Kubernetes to run this image, then Kubernetes will create a YAML, and in that YAML which Kubernetes has created as per this command we have not created, if you want to override some things, then you can override few things, like you can override the API version, you can give some spec or something, and you can customize using command line also. Another example is we ran our command. So kubectl run, give this our pod name. This can be an arbitrary name using this image. An image pull policy, as I said, never pull it from the repo, because it's always on my local. It means that I always take it from local. And this is a command I want to give, and once pod has started, then the container inside the pod should have this command, user bin tail -f, and then this is syntax -f, two hyphens and space and -f dev null. Basically, if I don't give this, then if I start this, then it will start the container, start the pod, then it has nothing to do, it will automatically try to terminate it. So to keep it busy, I give this command, and then that's another way to start this. Now we will discuss the service object or something, but if I want to access the pod from outside without getting service object or something, for time being, we can use port forwarding. And how do you use port forwarding? So this address, generally use it for debugging purposes, and this is a syntax kubectl port forward and the pod name, and this is your local host. This is your host over which your pod is deployed, the node over which pod is running, and this is the port on the pod. And if you make any request on this port on the node over which pod is running, then that request will be redirected to port 8080 on this port. Okay, so we'll see an example. I think I had already started something here. So I had given this example. Let me terminate this, or let it be there. So I've given this kubectl port forward 8888 on my local and 8080 on this pod, and let's see if this pod is running or not. Kubectl get port. So this pod is running, and this is the pod I have given here. And remember, we had on this pod, we have exposed the service on port 8080, the Spring Boot service which you deployed inside the container of this pod. So if I don't have this running, then let's see when this is running. If I do wget, let me remove, I already got it. So there's a file tips, I got it. So if I say wget localhost, so remember I'm giving localhost, I'm not giving the pod IP address or something. So on that localhost, I'm saying 8888. This is on my local machine, which is Mac in my case. I'm giving localhost 8888 and then /tips. And then I do this. Okay, looks like, oh, because I restarted the pod, sorry. So once I restart, I have to do this also. So let's do this. Run this kubectl for port forward command again. And then do this. So now I got this, right? So when I say this has come from the pod. Now, and it shows that, I have given this localhost 8848/tips, and I have configured that, port on the localhost on this command on this request on this port should be routed to this port on this port, and it did that. So it says handling connection for 888 from, which means on my local machine Mac, and then this forwarding it is forwarding by default to 8080. Correct. So, and this is the request I got from the container. So this is one way if you want to quickly debug or quickly test something, you can use this port forwarding. Moving on. Now, this is the last topic we'll discuss for today. You can organize pod with labels. Now, labels as such are just key value pair attached to a resource like a pod. Labels do not have any impact on the functionality of the pod. How pod starts, how pod runs, why pod fails. Labels have no impact on that. So that way you can consider labels as some sort of metadata for these pods. Now, why do we need this? You need this, and these are heavily used. Let's say you have, you want to get, when generally there's one Kubernetes cluster in a company. One Kubernetes cluster for dev, one Kubernetes cluster, let's say forget dev, there's one Kubernetes cluster where various teams use that cluster. Now, each team wants to have their own, application deployed on the cluster. And if I say, let's say there are, in a reasonable size company, there are around 1,000 to 2,000 applications, and those many pods will be created. Each application might be getting more than one pod also. So when I say kubectl will get pods, you might get thousands of pods, and every time you have to look for your pod and do something. So that way we can use label, and it helps in categorizing the pods into subsets. So one team can use some label, other team can use some other label, or within one team itself. You can use one label for dev, we can use one label for QA, like same code when it goes to dev and it creates the pods in dev, and you want to deal with this, so you can label those pods with dev or something. So, so it basically helps you in dealing with the pods in a better way. So we use label selectors, to get the pods belonging to certain labels. And when I say, here I'm saying pods, but it could be any resource, and other resource other than the pod will be covering as part of this, subsequent sessions. Now we have taken a hypothetical example, and we'll see how to, handle that. So let's say you own a company, and in that company there are three, organizations, and each organization created their one microservice. So there is one sales service, there's an order management service, and there's HR service. So once they have this microservice or apps, right? So whether these are apps or microservice or whatever, the idea is that these need to be deployed on Kubernetes cluster. Now each of these app or service need to go through these environments: dev for dev testing, QA for QA testing, canary is the environment which you use generally for, for the when you're doing a limited release. You don't want to release to all the people, but you want to release to certain people to test it out. So that's where you use canary and prod. So same application will be deployed on all the environments, because it would be going through dev, QA, canary, and prod testing. So, but in reality, there will be thousands of services in any org. We have taken example of few services to explain the concept better. So now, the one question about pod forwarding is that can pod forwarding be done in detached mode also? Yes, pod forwarding can be done in detached mode as well. As long as pod is running, you can do pod forwarding. Coming back to this, so this is a diagram. Let's say I want to assign two labels: app name and release environment. So app name represents this, release environment represents this. So how it look like? So for release environment dev, you have app sales, you have app order management, you have app HR. So so sales dev pod, how will it look like? Sales dev pod will have labels: app name is equal to sales service, which is this, release environment equal to dev, and so same sales in the QA. This app name is sales service, release environment is equal to QA, and so on. Canary and pod app name will remain same. Similarly, for order management app, it will be there in dev, QA, canary, and pod. So labels will look like this. App name in all of these environments will represent the same name, but the release environment will be different for each of these. Same with HR and something. Right. So this is how for three applications, four applications. Here I have given only three applications. I want to represent, I want to identify pods and the applications. I want to identify pods based on the application and the release environment. So what we'll do is, I'll go through this slides, then I will run the example also. So I have a YAML file. This YAML file creates a pod with this image, and it assigns some label: app name and release date, and everything else, we have discussed that. So then once I create this pod, Then I can see the labels. I have to assign, I have to add extra parameter hyphen show labels. So these label, once I do this show labels, it will show me the pod along with the labels. So these are two labels this pod has, and these are the two labels I had given here: app name sales, release environment dev, right? So this label get created, a pod with the labels get created. If I want to see the pods with selected labels, so uh, I can say the pod, no, the pod can have thousands of labels or hundreds of labels. I don't know. Generally, we don't have. Generally, you have 10, 12 labels, possibly max. But let's say I want to select pod with, and I want to select pod along with certain label which I'm interested in. So you can say kubectl get pod and use hyphen capital L option. And you can say these labels, it represents labels that show me pods along with these labels. So I'm selecting app name and release environment. So it shows me app name label and release environment label along with the other information of the pod. I can add or modify labels. So right now it has only app name and release environment label. I want to add other labels I created by a CI/CD. Then and then I say show labels. It shows me all the labels together: sales, created by, and release environment. If I want to modify a label, let's say for whatever reason I by mistake I gave the release environment as dev, it should be QA. So I first of all, let's see, this is a pod name. Then I say kubectl label. See here I'm adding label and pod, the pod name. Then I say release environment equal to QA and overwrite. So I use the overwrite option. So it will override the release environment from dev to QA. And this is what, when I say show labels again, so it says everything same. Release environment label has been changed from dev to QA. If I want to remove some label, so I can say same thing, kubectl label pods. I can give PO also, the pod name created, and I say hyphen here, a minus sign or hyphen. So whatever created I have done here, created by, I could have said created by, it will remove it from here. Okay. So let's see these commands in action, and then we'll discuss further topics on the label only. So this is my YAML file. It exists in the GitHub. So let's see that. So cat pods with the labels. So you see this. This is the label I'm giving. So let's delete existing pod, for example, just so as to not cause confusion. I'm giving the same name everywhere. So I'll delete the existing pod. So kubectl delete pod. Pod name is same everywhere, so I can copy this. Okay, kubectl spelling was wrong. CTL. So pod got deleted. So when I say kubectl get pod, there's nothing. Now I say kubectl create -f and give this YAML file. So I can say kubectl get pod. It shows me this pod. So I want to see the labels also. So kubectl get pod pods PO -f show labels. So it shows me these labels. These are same labels which I created here. Now let's go the another one. I want to select only the few labels. So using -l. So kubectl get pod -l. Let's say I want only app name. Here I have given both, but I want only app name, for example. So it gives me a pod with that app name. If I want both, then say release. Hope spelling is correct. Spelling was not correct. Let me copy. Release env. Sorry, release env. So it gives me okay. So it gives me this these labels. Now what I wanted to do was next I wanted to add my own label at runtime. So let's go the previous command, kubectl label, and then you see PO and the image name and the new label. Then the new label, I remove this and I say created by equal to, I say automation. I can give any name, doesn't matter, right? Oh sorry, forgot to give the pod name. Java Docker labeled. So now I say kubectl get pods labels. So it shows me that another label got added, created by automation. What next thing I want to do? So this I did. I wanted to overwrite options for release environment. I will change it there from QA. So kubectl label PO, kubectl label PO. I'll copy paste this PO only. This pod, where did that go? Then what I want was release this to QA. Then the overwrite option I have to use overwrite. So now I see the again. So it became from dev to QA. So that's about label. And if I want to remove some label, then same thing, kubectl label pod. Then I say release env, or I will release what I have added, created by hyphen. I see show labels. Now created by is gone. So this is how I can remove the label also using the command line. And whatever you can do using command line, you can do using API, YAML, and everything. So so that's about label. Now selecting ports via label selector. Now it is we saw how you can select the labels, how you can see the labels of the port. But if I want to, and we saw one example where you can see ports belonging to that label. But labels, there's a label selector, basically tells you can select the ports based on the label, and it provides good amount of extra functionality. And we'll see that now. So what is label selector? It is basically filter ports based upon the key, based upon key or key and value, based upon the only key, based upon key and value together. There are multiple criteria. And what are those criteria? The pod has or does not has label with a key. Like when I say label and the value, what do you mean by that? This app name is label, for example, and sales is value. The release environment is label and QA is value, right? This is what label and value means. So you can select port which has or does not has label with a key, which has label with a certain key and a value, which has label with certain key, but value is not equal to the one specified. And so I create this pod I just created. I will create another pod also. And the difference between this and another pod is that here you have app name sales and dev, and you have app name HR and QA. The app name is HR and release environment is QA. Correct? Here app name is sales and this environment is dev. So let's create that as well. And what we'll do, let's go through this first and then we'll see the example. Then you see the labels of both of these. For one, you see sales, app name sales, release environment dev. Other, you see app name HR and release environment QA. Then I want to see the ports with certain labels. I can say get port hyphen small l now. App name equal to HR I can specify. So it will not show me the sales and result, it will show me for HR only. Then I can see, both app name equal to HR and release environment equal to QA. Then again, it will show me the result. The idea here is to show you, you can have the multiple labels while selecting the ports based on certain labels. One example I have given is that you can select the port which doesn't have the label app name, because our both ports have a label app name, so it will not return any result. But this is how you should, not in single code. So any port which doesn't have the label app name will show here. So let's see this example, then we'll go through these other options available. So the example for this is, so let's create another port. So cat port with ports with labels, I think ports with labels, and underscore to YAML. So you see here the app name is HR and QA. For the previous one we had sent, the labels was app name sales release environment dev. So let's create this. So we'll do kubectl create -f. This support got created. So now you can say kubectl get port. I should say show labels. So you see, first port has app name sales, regional QA. Second has app name HR and regional QA. We changed the region. It was day when we changed it to QA for first port also. Now what I want to do is, so this is we have done. Now kubectl get ports -L. So kubectl get ports -L and say app name equal to HR, then show labels. So it shows me only the port which has app name HR, and I can give both of these as well to app name HR and this. Sorry, okay, both and maybe a space also. Sorry, my mistake. So I get this. Now this we did. This also we did. So now what I want to do was, if I want to select the port which doesn't have label, so what I'm going to do now is modify this and remove this and say not and say this. So we will not have any port which doesn't have app name, right? So it returns nothing. Other options available are, you can say label name, give me the ports where certain label name doesn't have this value. So it will return that. Or you can label names have, in like, if you know SQL, you fire SQL query, say where, zip code in first zip code, second zip code, third zip code, you could use that also here. Or you can say not in, like it will return the ports where the value of this label is one of these. If you want other reverse, give me the ports where this label doesn't have any of these values, then you use not in. So these are the options which are available. We'll come to node selector next time. So I'll pause it here. So we'll, I'll just walk over the Docker and Kubernetes plugins into the IntelliJ. So Docker is free, and Kubernetes, I think I had told you can have the Google Cloud Kubernetes plugin, so you can use that. So when you have the Docker plugin installed and you open your Docker file, for example, here this file I have opened, and when you click on this, it will run your this thing here only, and in the IntelliJ itself. And you can see here you can go to services, and you can see Docker containers. So I don't know whether service is available for community edition or not, because I have ultimate edition, but you can try it out. So under services, you will see these are two containers, and this is a container I have running. And you can right click and say stop, start, all those things, restart, pause, stop. You can do all of this. Here also it stopped, so I'm still working on this, but you can do everything, many things here. And you can exec whatever command you run, and all those things you can do. You can see images also, what all images are available. You can see networks if you have created, or whatever is there by default, some volumes which you might have created earlier. So if you click on running containers, you can see many things for that. One of the things you can see is the logs. Second thing, you can see some properties, image ID, container ID, container name. I have Postgres running on my local in a Docker container. So it's showing that. Some environment variables, whatever is default, some you might have set up, it shows there. Port bindings. So I have bound the port, container port, Postgres work on 5432. So I have bound 5432 on the container to local 5432. So that when I run on my host some command on 5432, it goes to container 5432. If you have volume bindings, I think it gave one by default, but if you have done some bindings in your in your Docker configuration, it shows here. One of the things which I like most is the files. So if you're running containers, you want to see the files, and I don't want to, you can always SSH and see all those things, but it gives you a visual representation of files inside. And that's what I like a lot. So you can see all the files these files are inside this container. So you can go and look at the files, you want to look at some configuration, etc, whatever cron, kernel, whatever you want to do. You can browse through files here. And that's pretty cool feature. So libraries, whatever folders in the in the root, and or you can go to any subfolders and do all of those things. So this I like. So that's one thing you can do. Well, let me see if there's anything. So you can edit while running. You can right click and edit, and you can say build image. That's another. You can build the image from here only. You don't have to run command like Docker, that -t or something. We are doing image -t. So that you don't have to manually do it. You can run it from here. You can edit the configuration. So I have the Docker running on my. So I had started the Docker machine here. Some Docker environment was running. So I have started the Docker machine here. Docker machine start. And after I started running, it started showing here. And so you can give the container name when you run the when you run a when a container, you can specify the name also. So this is about Docker and its configuration. Right now, if you see Kubernetes Explorer, it's not showing anything because I am not running the Kubernetes Explorer. I'm not running any Kubernetes cluster. So what I'm going to do now is I'm going to start Kubernetes on my local environment. So Kubernetes start. And once I do Kubernetes start, you will see, whatever images are running is trying to load that. You will see that Kubernetes is coming here also. And then there are certain commands I can run from within the Kubernetes. Let's see, there is nothing. It selects your local also, but I am more interested in going here and trying to see Kubernetes Explorer. So let it load. Let it load, and then I will be able to see the Kubernetes here. Okay, while it is running, let's see where we have reached in the command. It's still loading. 71%, 75%, it's over. Let's wait for a couple of minutes. Is there anything let's check the edit configurations. Yeah, there's a Docker file configuration you can check, and Kubernetes thing. I have not played around with much, but there is something on Kubernetes also it provides. And Docker files, I have shown this already to you. You want to do something before, and these are like IntelliJ configurations. I think if you know, if you work on IntelliJ, you might know about this already. What else? So you can pull the image. So these images are on the wherever Docker repository you are connected to. So you can pull the image. For example, let's say I want to pull the image for give any image name Redis. So I want to pull the image for Redis. So it takes some time. Sorry, it takes some time to search and everything, and then it will show you these are the images available. This is pretty cool. You can always use Docker pull from your command line, but you can do from here also. And here you get an advantage. What are the Redis images available? It shows all of that, and so you can pull select whatever you want, and you can pull that from the repository. So that's about it. So this mini cube is starting. While it's starting, let's see. Now you see, earlier it was nothing. Now mini cube has come. It will show the nodes because it's starting, so it's still loading. So once it's run, it will show okay, one node is running. These are namespaces. We'll discuss namespaces last time. We did not complete the namespace, so we'll discuss the namespace today and various objects of Kubernetes. It shows here, and we'll go into many of these in our coming sessions. So this basically covers the about our IntelliJ setup. And it comes very handy when you are developing, and you can, instead of writing so many commands yourself, you can use the plugins available. It will increase your productivity. So let me close this because IntelliJ consumes a lot of resources. Close. Okay, done. Close. So what I'm going to do now is now let's come back to the continuation from the last session. So I will come here. So where we had left last session was on the namespaces, I think. So let's go to the namespace. Okay, annotations we had finished. So let's go to namespace. So namespace, it split objects into separate non-overlapping groups. And what are those non-overlapping groups? Those could be, different components into your company's applications, or the idea is that some components need to have more resources, some components need to have less resources. So you can define those resources using namespaces, and you can have the access control to resources by users. And as I said, you can also limit amount of resources. It's just reflection of this. If you want to get the namespace, now we'll go as per this. So if you want to get the existing namespace, you run the kubectl get ns. Ns means namespace command. So I will do that. So kubectl get ns. So these are the namespaces you see which are already there, and there's a Kubernetes dashboard also. That's cool. We'll see the dashboard also later. Now, if you want to get the pods belonging to a namespace, then you run this command. So kubectl get pod. You can say get pod or pods and namespace, and then you give the namespace name. We'll take one. It's a kube system I want to see. These are the pods. And the kube system, right? We discussed it as scheduler, it has a API server, and it has controller manager. We discussed all of that, right? So these are the things which are coming here. Let's see what is in the kube dashboard. So there's a metric scraper, there's a dashboard. These are the two pods running on Kubernetes. So this is how you see the pods belonging to namespace. See, here we are seeing the pods for the namespace which are created by Kubernetes. But once you create your own namespaces, so in your organization there might be many teams using the Kubernetes cluster. You might be part of one team or more than one team and things like this. So each team's pods will also be under some namespaces. And if you know the namespace and you want to see the pods under that, and the namespace is what you or someone in your team or some other team might have created, and you want to see the pods, you could very well give that. So don't confuse because I'm giving only the Kubernetes created namespaces. You could don't confuse it with that. You can see only the Kubernetes namespace pods. It's not so. Any namespace pod you can see, or any namespace you can see, whatever has been created by Kubernetes or by you or by anyone else, provided you have access to that. Moving on. So you can create the namespace, and this is the file. So I will go into that file. We have the file, go into that. So let's, one thing we want to see is that this file uses a namespace, some namespace, and this namespace you have to create. So you can, okay, this namespace, I can either you can create via YAML file, or you can create via command line. In YAML file, you can give configurations, and this namespace you are given. That's how the name get namespace we have seen, right? Get ns. So this name will start appearing there. So what we'll do is, let's see, LT. Okay, LT is my abbreviation I have created for ls minus LTR. So I see namespace. So let's see this YAML file. Name. So the name of the namespace I have given as with -ns as a suffix, and this is a namespace name I have given. And this namespace will create, there are some containers it's supposed to create, which will be based on this image. And this is a standard, configuration which you have been using so far, right? So let's see now. So it will create the namespace, it will create pod under this namespace and set up some. We'll discuss the liveness probe today. We have been using it for some time, but we never discuss it. So we'll discuss it today. So now let's do one thing. Let's create this file, create this, run this file, kubectl create -f, and give this name. Oh, okay, namespace, my name. Okay, so looks like I have to create the namespace first. So I have to create this namespace. Kubectl create namespace. Let's see that file again. So let's see. This is the name. Hold on a second. Check one more thing. Here I'm saying it's a pod. So this pod uses this namespace. Yeah. So this pod uses this namespace. So I will create this namespace, and I will let this pod use this namespace. So that's what this YAML file does. So kubectl, and I will use this command only, create namespace, create space, and I will do this namespace, and then kubectl get ns, sorry, mistake. I will see this is the names I have created. Now let's do one thing. Let's try to get the pods under this namespace. So we have not created any pod yet. So let's see my namespace. There's no resource there under this namespace. Now what we are going to do is we are going to create a pod which uses this namespace, and this is the YAML file we just saw. So we run this. Now, if you see the pods, you will see the pods got created. Okay, pod got created. Now what we are going to do is we are going to see the pods under this namespace. So you see get pods, this is the name, and this is the status, and all those things. So this, you see under this get pods under this namespace. This is a pod I got under this namespace. So let's see what else is there in this. I will open that file. Okay, this is a container pod v1 main namespace containers. This is the container, and this is the image I'm using, the configuration, this is a command, and this is a name. So this is how I built the namespace and the pod inside this namespace. Hold on a second. It's running. Let's get the pods. This is the pod. Let's see, get pods under this namespace. Yeah, this is the pod which is running under this namespace, and I will say show labels. I have not labeled it to anything, so showing label as none, and it got started some. There's a one restart 20 seconds ago. There's 81 seconds before I ran this command, almost 1.5 minutes back. Okay, now so this is the this is the namespace thing. This we discussed. This is just we ran. type pod and all those things. And one thing which I wanted to show you was when you're creating the namespace, you can use, so I have this, YAML file also. Let's open that. I created namespace using command, but you could always, create using YAML file. My config. Okay, let's see my namespace. No, I think I had this command and somehow had this file, somehow I renamed it or moved it elsewhere. But you could create using command. Only thing is you give the API version v1 and kind is namespace, right? So let me again try. I might still have it. No, what is my config? This is a config map. We'll come to config map later and not right now. So, I'll find it out and, discuss in the next session. Okay. Now, how you can, we discussed that, and you can allocate the resources to the namespace because your cluster has nodes on the cluster have so much resources. So you want to allocate some resources to certain namespace. So this is defined here. So let me copy this. Let me copy this, and we will see there. Here, I think I had it open, resource management. Let's see this. I'll open it one more time. Here. So configure memory and CPU quotas for namespace. This is some Kubernetes documentation. So create a namespace and you create a resource quota separately. You can go through this. I will not cover as part of example, but you can go through this. You can have the hard limit. The CPU is 1, memory is 1 GB. You can limit the CPUs. It starts with 1, it can go up to maximum 2 and the 2 GB memory. And this is your resource quota. Then you are creating a pod. And then here a manifest example pod, creating a pod. This is the name of the pod, is a container. Image is this is the resource you are allocating for the pod. And another thing which you are doing here is create the resource quota for this namespace. So you created a namespace before, quota memory CPU cycle. You are allocating the quota to this namespace. So, and you can see the detailed information also here. And I'm just saying, just go through this. This is a Kubernetes documentation, is quite exhaustive. If you try to create a second pod, if it has resources, it does. If it doesn't have resources, then it shows some error. So I have not gone through this myself, but please go through this. If you want to know how to assign resources, and resources are just the CPUs and the memory, 2 namespaces, and then those will be allocated to the ports inside the namespace. So that's about that. There are few commands. We will go through this and we'll revise those commands now. If you want to delete a pod, then you can delete by pod a name. So let's see. cpl get pod, and get pod and pod post returns the same thing. And this is let me check one thing. I was trying something here. So this is the replication, replica set. I will cover replica set later. I was trying it and it's running. So let me delete this first, and then figure out ports also. kubectl. Okay, so there should not be any replica set. Now there should be any pod. So let's create one pod, and which will delete that pod using some commands which we are discussing now. So get, let's see, Kubernetes post.yaml. So this is a pod we'll create now, and then delete it using by name. So kubectl create create post.yaml. So it got created. Now I say kubectl and get pods. So this is a pod which is running, and this is the name of the pod. And it's ready, it's running, and all those things, right? So now let's go back, and I want to delete by name. So you can see kubectl get PO, or you can see kubectl get pods. Both mean the same thing. So now I'm going to delete this. So kubectl delete. Now you can do delete. You can run the delete command in two ways. You can say delete pods and give this name. That also will work. Or you can do this kubectl delete and say pod, singular pod, and delete this. So it got deleted. and then you say pod again, you won't find it. Right? Now, if you want to see, you can delete the namespace. Let's see the namespace first. kubectl get namespace. These are namespace. I want to delete this namespace. So you can say kubectl delete ns and then namespace name. kubectl delete and namespace space and then this name. So it got deleted. And but it takes a while to delete it. So there's another way to delete that. We'll try that way also. So let's create this namespace again. Control C, controller, namespace, and controller. Okay, I want to create the namespace. I want to go to that command where I'm creating the namespace. Create namespace, correct? So now to delete it, we ran this command earlier. Now let's try to run this command. I never run this earlier, but let's see if this works. Namespace refresh. So you can use either of this. You can give, delete command with the namespace and then give the namespace, or you can give ns hyphen namespace. It got deleted also. So if I see the namespace, I won't find that namespace. Okay, you can delete the, ports by labels. I think I deleted all the ports, but this you can try yourself. kubectl delete ports hyphen small l and the some labels, label name and the label value. So you can use that to delete ports with those labels. So now we'll discuss the replication controller and replica set in the next, in this next session, next slide, whether today or whether now or later, we'll see. But if you're using replication controller, and we'll see what replication controller and all those things is, then you can delete the pod and delete the replication controller later, or you can delete the replication controller and it will automatically delete the pod. And we'll discuss that in detail. Now pod's health. Now, when you create a pod, during creation, pod is scheduled to be created on a node. Now there's a kubelet on that node which runs the pod containers, and we've seen the full flow, right? What happens when you create a pod, the flow we have seen. So basically, it's a kubelet which tells the runtime, Docker runtime, for example, to pull the image, run it on the container. So kubelet is responsible. If container goes down, let's say your pod, your node is running, and suddenly something happens in the container because of whatever reason, it goes down. So kubelet will automatically restart it. So now, but let's say container is not going down, container is running, but your application is going down inside the container. And why application can go down? Because of some application bug or some out of memory error or something. Then how do you detect it? See, if your container goes down, then kubelet will start it. But if container is up, but your application is not responding, then you need to have some way of figuring that out, that your application is not running. And that's where liveness probe comes into play. So we'll discuss the liveness probe. So let me put into slideshow. So Kubernetes can check if container is alive. I mean, basically your application inside the container is alive. So can set it for each container in the pod. Kubernetes will periodically execute it and restarts container if it fails. So there are three ways to check it. You can have an HTTP get. So get on containers IP address, port, and path we specify. So it automatically considers return code with the 200 and HTTP status codes, right? So HTTP status code with 200 and 300 are normally considered successful. But if it goes into 400, you'll see 404 or 500 internal server error or something. So anything other than HTTP status code of 200 and 300 are considered failures. There's a TCP socket probe also. You can set those also. We are not going to set this up. At exec, you can run the arbitrary commands inside the container, and maybe you have a script inside the container. The script is check the application health. And what is the application health? It can check many things. Memory, if within an application you have various endpoints, it automatically checks those endpoints, and whatever you want, it can check all of that. And you can invoke that script using exec. And once you invoke that script, and if script, the way you should design your script is, if whatever needs to, whatever is, things need to run fine for your application to be up. Your database connectivity should be there. All the application should be running on this port. Memory should be, should not be, all memory should not be consumed. Your whatever volume, should have a space, and all those things. You can do all of that in your script and then invoke that script using the exec. And if that script is returning 0, that means that script should return 0 if everything is fine. And that script should return some negative value if something is wrong. So that way exe will consider the 0 as a success, and negative as the, something has gone wrong. So your probe will fail in that case. So what we are going to discuss is, okay, I don't know why it's not appearing here. So pod YAML and the specs. So what we'll do is, I think we have seen that. So this liveness probe we have seen here only. Where is that file now? Oh, sorry, my mistake. I should have done beam. So this is a liveness probe. So if your type, if your object is of type pod, and under specs, under containers, within the containers, you can specify the liveness probe. This container is using this image, for example, and a liveness probe is you're trying to get HTTP GET on port 8080. And there is period seconds and there's a timeout second. So we'll discuss that, here. So this is what we are discussing, liveness probe. Okay, it came now. So period seconds and timeout second. This is what I showed you. And okay, it doesn't have that. So basically, what period second does is, see, if your timeout is, and it will, period seconds after each 20 seconds, it will keep checking, right? If any time it fails, then it will considered as a, failure. And timeout is, if it checks this at 80 and at 80 never responds, at 80 is this port, it checks at this port at this path, which is a root path, and the application inside the container is not responding within 15 seconds, which is a timeout second here, then the application is considered to be a failure. And then it will, it will tell this the application is not alive. So now what we are going to do is, we are going to, we are going to describe the support, and we'll see the liveness there. So let's do this. So I'll indicate the pod with this pod with liveness probe. So what's the pod name that you can get from here? You see the name here. So you can say kubectl describe. Sorry, describe pod. So you can see anyway, it's saying liveness probe failed, whatever. So connection refused. It's unhealthy. You can see this is unhealthy for 34 seconds. And later we'll see debug why this is unhealthy, but at least you are seeing this state and it keeps saying unhealthy. Right after each 20 seconds, we said, right? Remember that this settings we said period second after each 20 seconds you check. So 24, then 20 seconds, 34, and then after 54, it will keep checking. And let's see if there's anything else. What I do is generally, instead of going via this, grep -i. So this is the liveness it shows here, right? So there has been one success and 3 failures, and whatever I specified in my configuration, timeout is 15 second, period is 20 seconds, and so on. And the path and the port, it keeps checking there, correct? So somewhere you will see this liveliness here. This is the liveliness. You see this here. And yeah, so that's how you check this pod is live. It's not live, it's unhealthy right now. And how the liveness is set up using the liveness setting in the describe port, which you are set up in your YAML file. That's about YAML. That's about liveness. You can do port forwarding also. So if you want, for this particular image, for this particular pod, you want your on your local, if you want 888 48 port to be redirected to this containers 8080 ports inside the container of this pod. So that's how you do that, right? So that's port forwarding. This we already discussed, the liveness check. There is let's see this pod with resources. Let's check this also. Okay, let me go back here and I copy that. I think pods with resources, I think it's already open, but let me see. This is what is resource management. So you can create a pod, and this is a normal pod, and you can have the resources inside this pod. So this pod should have this memory and this CPU, and this is up to maximum. It can go up to this. There's another container inside this pod, and it should have this memory and this CPU. During startup when it starts, and then it can go up to this memory and this CPU. So that's how you can assign the resources to the containers inside the pod. Correct. And you can go through this. I think there are this Kubernetes IO has lot many documentation. So if you understand, sometimes it confuses you if you don't know the concepts, but after you understand the concepts, it's better to go through this also. So, so that's about the resources. There are few troubleshooting things we'll walk over this, which will might encounter a lot during your development or using Kubernetes. There are many other things also. We will not be covering every error, but the major error, the main errors which you see in your when you're working with Kubernetes. The first thing is you see image pullback off. Now, what is this image pullback off? And you will see that here when you see kubectl reports. So status is here. Now let me do one thing. I will cause this problem, and I will tell you how we'll cause this. Let me delete this kubectl delete pod. I deleted this. Now let me modify this YAML file vm reports.yaml. So I am not logged into any Docker repository yet. So what I did is I added this policy, image pull policy. Image pull policy is from the Docker repository, only do when if not present. And if I don't specify this setting, then by default it always tries to go to the Docker repository and pull, because I am not logged into Docker, so you won't be able to find, and I will get this error. So let me do one thing. Let me just comment this out, come out of this, and then I will create this kubectl create. Then now let's see the status. Okay, it's creating the container, image pull. After some time it will say image pull back off. So let me see. So you can see kubectl logs code. So you can see bad request container in pod waiting to start trying to fail and pull the image. It's not able to pull from the repo because I'm not logged into any repo anyway. So let's see image pull back off. After error image pull, it moves to image pull back off status. And let's go through this. It's not able to get image from the repo. Now, what could be the reason? Either you specify the image name wrong, which does not exist in the repo you are connected to, and you can see the error using. Let's run this command also. Let me go to this and run this command. You can see the real error. Okay, this is what it's saying 23 seconds before. It's a error image pullback or whatever. It's trying to pull this image. It does not exist in repository because I'm not connected to repository. So you can use this. So now how do you fix this? Let me put this in a slideshow mode. So how do you fix this? So either you can use Docker login to the repository you're connected to, or if image is existing on your only on your local and is not on the repository, then you can give the setting image pull policy if not present. Or if you think the image is in the repository and still not pulling, then there could be two problems. One problem could be that you have given the image name wrong. Check the spelling of that. Or you have given here we have given only the let me open this YAML file. Okay, VIM. So here we have given only the image name, this label also. So we have given on latest here. So sometimes you can give the version which you specify. Here given this is the version. So I have given the latest version, but you could always specify 1.0 or 2.0, whatever the version is. So you check the name of this image. If that is correct, then check the version of this image. That should be correct. There is a possibility you might have made mistake in any of those. So with this, if everything is correct, then Kubernetes should be able to pull the image. So let me now revert it back, because it's my local. So I want to take it from local, and I will see the status of the pod. It will showing image full back. So I'm going to delete this image. Delete, then pod slash control V. This got deleted. Now when I run the create again, create, control C, cube, CTL, create, FN, Kubernetes FN pods, FN pods dot YAML. So it got created. Now I should see the status of this. It's running because it's able to find the image on my local this thing only, local laptop only, right? That's about the image pullback of error. You will see crash loop back of error is same status if there's no command to run. So what happens with this? This is a problem with the Kubernetes images. So, and you can experiment it yourself as homework, if you want. So if you pull the, let's say you pull a, CentOS image. CentOS is a version of Linux. It's pretty popular. CentOS, and CentOS is used in many production as a production server also in many setups. So you pull a, you say Docker pull image and use CentOS image. Now you run that image using Docker run command. So when you see after you pull the Docker CentOS image using Docker pull command, so you can say Docker image ls, you will see that CentOS image is there. Now you run a container using CentOS image itself. So Docker run command you say and give the CentOS image. What will happen is it will start the container and immediately it will error out. It will say crash loopback of error, something like this. Why does this happen? Once the container starts, if it doesn't have any command to run, if you don't tell it to run, it will automatically die down. So in our case, it's not dying down. Why it's not dying down? Because if you see our our pod, we are telling this is a command you need to run. So when container starts, it has some command to run, so it will not die down. But if I remove this command, then it will die down and it will give the crash loopback error. So so the reason is if there's no command to run inside the container, then it gives this error after it has started up. So solution, run a command inside the container so that it keeps alive, and you can see the same thing, right? Whatever. So if it's if you are so one way is that give this command inside this. There are various other ways also to give this command inside when container is starting. You can give command to run as soon as it starts. So you can as a homework you can check this out. But to be on safer side, if you want to be completely safe, give this command option. At least something should keep running. And some if your image doesn't have any application deployed which you can run or something, then you can run some while loop, some infinite, some in bash script or something that just run this while and it just keeps running, so that at least the container will have some commands to run and it will not crash or something. So that's one ad hoc approach where during development you want to do some testing or something, and you are not able to figure out which command to run to keep the container running. You could use that, but generally you have your own commands to run some, you are spinning up container for something, right? So you are trying to do something inside, even if you're using a pre-built image, but you are using that because you want to put something inside that. So use that, use some command inside that, so that at least container will find some work to do, then it will not die down. So that's about crash loopback of error. I think this you had, this part of the assignment, a pod with multiple containers, but we'll go through this, right now also. So what we are going to do in this example is we are going to create a pod with the two containers. One for MySQL and second is custom Spring Boot app, which we have been using. Right now, there is there's some extra thing we'll be doing, and you will see why we are doing this. So first of all, we'll create a persistent volume first. We have not discussed persistent volume yet, but and why we need this persistent volume. When we use MySQL container, it needs some volume where it can save the data or something. So what we are going to do is we are going to create a persistent volume. So we are going to create a YAML. So this is a YAML I have created, and it's a API version v1. Kind is persistent volume claim. Some metadata I have to give, and this is a name I am giving. This is a spec. There are various storage class names. I have given standard, volume mode is file system, access mode is read write ones, resources is I am giving 20 GB resources. So I create this, I run this file using kubectl create command, and I get this, it says it's created successfully. Then I can see whether it's created successfully or not by running this command kubectl get persistent volume claim / the name which I have given, right? And you can copy paste from here also the output of the command. You can copy paste from here also, and you can see this claim got created, and this is the volume, and this is the capacity, and access mode read write, or I don't know, O means override or something. So this is the access mode. Now I created a persistence volume. Now I need to create a secret. We'll discuss about secret in the in coming sessions. There's a big set of examples I have given for some secret object, but for timing, you understand secret. Kubernetes provide you, like it provides you pod, like it provides you namespace, like it provides you labels. It does provide you a object called secret also. So you can create the secret object, and there is various ways to create the secret object, which we will discuss when we reach the secret topic. But for time, we will be creating the secret. For this example, we are creating secret object from literals, which you are passing. So I am creating a secret object, and it's a generic. And there are different type of secret objects we will discuss when we reach the secret topic. But for you understand that kubectl create secret. Right now we are creating generic type, and this is the name of the secret we are giving, and we are creating the secret from literal. And what is the secret? We are saying password is equal to welcome123. So I create the secret, then I say kubectl get secrets. This again we'll discuss in details when we reach the secret topic. So but for timing, when we get the secrets, I get this secret which I created, right? What was that? Password. Somewhere you should see the password also. Maybe it's not appearing. I did not copy even if it was appearing. So there will be, MySQL. Here it is. Sorry, my mistake. This is the secret we have created, MySQL password. And this you see MySQL password appearing here. And I had created, when I ran this command, immediately I run the get also. So 8 seconds before I had created. So I created the, some persistent volume claim. I created the secret. Now let's see what we are going to do. You can, there's a YAML which I created. It's called 2-port containers pod YAML. And, I have taken example from this. I have referred the Kubernetes tutorial on this link. So you can go and read. So this example has been taken from there. So it's a type of pod. This is the name of the pod. And here I'm using 2 containers. One is this and second is this. Now let's see, this first one is pretty simple, right? This is what we have been using so far. So this is the name of the image, latest version, image pull policy is not present. Command is this when the container starts on this command, and this is the name of the container. Now second is MySQL. So MySQL, I want to use version 8, and the name I want to give is MySQL. And again, image pull policy, if I have in my local, take it from there, otherwise take it from repository. Now, when you use the MySQL, and you can go to hub.docker.com and search for MySQL and see the documentation of that. What they want is when you are spinning up a container for MySQL, you have to pass some environment variables. So now what are those environment variables? One is you have to pass a MySQL root password. How do you pass? And this again we'll discuss a lot what is this secret and all those things when we reach the secret topic. For timing, you understand this is how you are passing the environment variable. The name of the environment variable is MySQL root password. And where it is taking the value from? It is taking the value from some reference where the secret key reference, and this key I have created MySQL. This is a secret I have created. See, you see MySQL password. So this is the name I have given here. And in this secret, what is the key? So this is this is the name of the secret. Within secret, I have given a key value pair, and that key name is password, and the value will be automatically taken as welcome123. So I've given setting up this environment variable. I'm setting the value of this environment variable, and value is coming from some secret key reference, and that secret key reference I had created. The name of that secret is this, and within that secret I can have multiple key values. So pick up the key which whose name is password. So now this is a port. I am for this MySQL image, I'm creating a port, and this container will be listening on container port will be 3306. So container will be listening on 3306 port. this MySQL container. Volume mounts, I'm creating a volume mount. So MySQL persistent volume, this is the volume which I've created. Persistence volume, if you see, the name and all those things. Okay. So come back here. This is the name of the MySQL persistent volume. So this is a volume mount I'm doing. Before I do volume mounts, I have to describe a volumes property here. So what is the name of this property? MySQL persistent storage, and this name MySQL persistent storage should be same as the name I have given in the volume mount. So when I give volume mount name, it is going to refer to volumes having this name. Now what I'm specifying in this, I'm specifying persistence volume claim is MySQL PV claim 1, and this is what I have specified here, MySQL PV claim 1, right? So it's going to, there I have specified the storage and access and all those things, right? Now, class name, volume mode of file system and everything. So this is what I have given the claim name, and this becomes my volume, and this is the volume I have specified here, and it should be mounted on what? So I've given the path that it should be mounted on where lib MySQL K8 or something, right? This is where you mount. It's on the container, correct? Now, so I have created this YAML, I run this YAML, kubectl create -f2 containers pod, then I describe this. So now, and you can see a lot of information while describe this. I think we have seen this command multiple times. Check 2 containers in a pod sharing same IP. We discussed that, right? In one pod, if you have 2 containers, both will have the same IP. So when you see describe, this pod you are describing, it will show the containers, both containers, and you check the IP address of both containers. One is this IP address. This is one container, which is your custom image, and second is the MySQL, right? But both have the same IP, and you can see the container ID for our application is this, image is this, and all this command is this, whatever you given. MySQL container ID is this, image is this, image ID is this, port is this, whatever, right? And give the environment variable. So both containers using the same, same IP address. So that's about the multiple containers. I think this ends our session of the pods. This was the last slide. Yeah. So so daemon set is a pod which gets automatically installed on each of the node. Now, why would you need such pod? Generally, you need such pod for various things. Like in one of the things which the companies do is they have this separate standalone machines running. If you're on cloud, then it might be EC instances or EMR instances, and they're generating a lot of logs. Now they might want to put all these logs which applications are generating into Splunk, for example. So different people have the different log aggregation mechanisms. Splunk is one of the most widely used. Or you have this Kibana, I forgot that, Elasticsearch, Kibana, and that stack also. So whatever it is, so you might idea is that on each machine, whatever logs are getting generated, you might want to put those logs into Splunk. So we call those log forwarders. So now when someone is spinning up a new pod, that person need not worry whether about the log forwarding and all. So by default, a pod which is forwarding the log should automatically be created there without even user knowing it. That's one use case of this daemon set. There could be other use cases where they want to check, if the logs contain some, PII information or any information which should not be logged, for example, password or social security number or things like this. So the pod is checking this constantly on the log files, and whenever it detects such things, it just sends an alert or some notification or something. So this is another example of why you might want to have a default pod on each of the nodes. So that default, the way to do this is daemon set. So this example, what is trying to do is, and also there will be one replica of this pod on all the nodes. You cannot tell daemon set to have 2 pods on the same node. By default, it will create one pod. If this pod gets deleted, then it will immediately start the same pod on the same node. So you have a daemon set. You have 3 nodes. and you have one replica set, which we were just discussing. It has 6 replicas. For example, 2 here, 1 here, and 3 here. And your daemon set will have only one. You can't give the replicas in the daemon set. It will by default have one replica on all the ports. So that's about daemon set. I'm just reiterating what I said. A pod on each node if you want, use daemon set. Daemon set creates as many pods as nodes. Daemon set doesn't have notion of desired replica set like you have in replication controller or in replica set. Design replica, it should, it's written wrongly. It doesn't have the notion of desired replica like you have in replication controller and in replica set. Why? Because it's not needed. It automatically ensures that pod, a pod, daemon set pod is already there on each node. You could very well have the, sometimes you don't want, daemon set on certain pods. For example, some pods are generating the financial data, which is even log also has, logging also contains some data which should not be on the Splunk or should not be, it should not be even looked at. So on those nodes, you don't want daemon set to be running, for example. So for such use cases, you can have the node selector in the daemon set also. And we'll take an example of this. So if node is going down, then daemon set does not start elsewhere. So in this example, if this port, daemon set port goes down, it will start. But if this complete node itself has gone down, then daemon set will not worry about, it had 3, ports running. Now one port it has to restart. It does not worry about that because the node itself has gone down. If a new node gets started, of course, daemon set will, spin up there also. So this is what I'm saying. New node coming up, daemon set deploys a new pod instance on it. So by default, it will run on each node, but one can use node selector to run on the certain nodes only. So this is what I just explained. So take an example. If I want to run on the certain nodes, how does that work? So use node selector property. So there's a node selector. I think we had discussed in the past ones. So this node selector property in the port template, which is part of daemon set definition, we should use that property. So what is node selector? It defines the nodes. The daemon set deploys the port to. It should not be node. It defines a node. The daemon set deploys the port to. Daemon set will deploy to even unscheduled nodes if those are node selector. So what are unscheduled nodes? It preventing pods to get deployed on them. For example, in your Kubernetes cluster, there are some machines which are where no pod should be deployed. Those are called unscheduled nodes. But those nodes have a node, and we'll see how you can label a node. So those nodes have certain label, which is matching with the label of node selector in the daemon set. So in that case, the daemon set pod will get started there also. And why it's reasonable if daemon sets are used to run system services, even on unscheduled pods. For example, if the unscheduled unscheduled nodes are generating the, some logs by running, which are some default applications which might be running there, you might want to look at those logs as well. Or some pod, I don't know, just a hypothetical example, generally use Grafana and all those things. If you want daemon set to monitor some system metrics, memory or hard disk or something, so you might want to monitor on the unscheduled nodes also. This example, you have node 1, node 2, and node 3. In node 1, you have this node selector. This, remember, this label is on the node, not on the pod. So node has label app name sales, app name HR, and app name sales. And you have a daemon set. Daemon set name is app monitor, and the node selector in the daemon set is app name equal to sales. Now, because it's app name equal to sales, it will be set here on these node 1 and node 3. Because node 2 doesn't have app name sales label, and this is the app monitor, right? So the pod app monitor here, pod app monitor here, and on the node 2 there might be some other pod running, but it will not have the daemon set. I will show you some example of this, live example of this, but let's understand the daemon set definition, daemon set YAML. This is a link which has good amount of information. I did not put all of this in the slides. It has more than what I will be covering the slides. It's just 1 second. 1 second.
Obviously, now
So, so a daemon set is like replication controller only. but it skips the Kubernetes scheduler. Kubernetes scheduler is basically, we discussed when you are trying to, spin up a pod or application controller, the scheduler decides, you have these 3 replicas of this pod, then which are the nodes over which this pod should be started. So that's a scheduling process. For daemons set, you don't need that scheduling process, because by default on each of the, pod, or at least from the nodes which have the node select that node label, this daemon set pod will get started. So this is a daemon set YAML file, and we'll go into this. So you have spec.selector and spec.selector. This is the pod selector, right? This name spec.selector match labels should match in the template. You should have the label, same label. So these two are same, correct? And so this is what I've described. So it should match the spec template metadata label, which is this. So these two should match. It is needed that daemon set will be on the pod created from spec template, and on the on same pod rest of the settings is to be applied. Yeah, because even if you give the node selector, that node might have different pods running, more than one pod running there. So in that case, you want to apply this to only the pods on the same node which has these labels. So spec template, we have discussed the spec template. It creates a pod with this template. It's needed and represents pod. Same schema as pod without kind or API version. So it's the same as pod, but you don't find kind or API. It's just supports information. All is inside the template. Spec template, spec node selector. So which is this. So daemon set will run on the nodes with this label. Spec template, spec image. This is a daemon set image. Spec templates, it's a container image. I forgot to put container here. So it's a container image. So I have created a new container. I will walk you through what I am trying to do, what I am trying to demo here. But I have created a new Docker image called log checker. What that log checker does, it's very crude, very basic thing. It looks into the log file, and the log file is also hard coded there /tmp/tips.log. It's looking to that log file, and then if it finds SSN or password, like a really word called SSN and a word called password, then it just logs it. In reality, you might be sending emails and notification, but this is very crude and very basic. Just for timing, it just logging in. Now there are a couple of other things which are happening into this. One thing is happening is that I'm doing a volume mount here. So on my host path, I have this user ID /user/my username, and it's being I'm naming this as temp. Then in the container, this temp I'm mounting as a /tmp1. So basically, if you go to the container, you log into the pod, you will see /tmp1, which is basically showing you the files which are inside this folder on your host machine, and we'll see an example of that. Correct. Now what happens? So if you think about it, right, because a daemon set has to match a node if you give node selector, and within that node it has to match pods because you are given these labels. Once it matches the pod, then on that node, sorry. So it will start a pod with this label, but it has to match that. It has to match that node. So we'll see right now. We'll in our demo we'll change the node selector, and we'll make this. We'll have the node have the same label. We'll change the node to have the same label which you have given in the node selector, and we'll see the if the daemon set is getting started there or not. Okay. So
Sandeep, I have a question. So you told daemon set.
One second. Right. So now, so this log checker code is here. You can give your GitHub ID. I can give you the access. And what it does is, so let me open this code. So this is a controller. Actually, I already have it open. This is the controller, and all this controller does is exposes a /check endpoint, and it calls the security checker, which is very crude security checker. All it does is, I have hard coded this. Generally, you don't hard code, you pass as a configuration, but I wrote it very quickly, so I'm just hard coded for for convenience. So what all it does is, it looks into this log file, and the moment it finds SSN or password, it then it just, log the information, log.cs security breach or something. Generally, you send email, pagerduty alert, or whatever mechanism you might have. Generally, that's what you do. But for our fruit checker, we are just logging it, correct? And we'll see that as in the demo. So, so this is our log checker services. Now, what happens is this is the flow. Our application which we are using for so far, like it's a tips application, like slash tips we use, right? It writes to some, it writes logs to /tmp tips.log, correct? And the same log file is being checked by our security checker, correct? Now, the way I have done is, as I showed you here, on this daemon set, I'm mounting a volume, which is pointing to this folder, and it is mounted on the /tmp location on the daemon set. In my application also, let's see, in my application also, I do the same thing. So I have pod, which is again, this is a new pod which I have, new YAML which I have created. In this pod, I am mounting the same, path onto the pod also, right? So same path is mounted onto the log checker. Same path is mounted onto the my pod, which is doing the real business application. And this pod is generating a log file, and our log checker is checking. Log checker is nothing but daemon set. It's running as a daemon set pod. It is checking that as a, it is checking that log file, correct? So so that's it. So if you see, right, the this pod definition doesn't have anything. It just has the name, and it has the spec and the container information and the volume, correct? So you have this application pod, and it is has some external volume mounted. So it's writing to that pod that on the external volume. For this application, it's a path inside the container itself, but that path inside the container is mounted from external volume. We will discuss the volume and all those things in the next, in the subsequent sessions. But this is how this application is writing. Then this daemon pod is running, checking the pod file because it has mounted the same volume in the log file. It's checking the log file and finds those SSN or password. It just logs it. So now what we are going to do is, let me see if I can create this pod again. I might already be having this pod running, but let's see. CTL get pod. Right. So this is a daemon. Let me delete both the pods. Let me delete every pod. Or before that, I had the daemon set running. So let me delete the daemon set. kubectl delete daemon set / monitor. And then I don't have daemon set, and I will have the pod which is related to daemon set deleted. Now let me delete this pod also. kubectl pod. This is the application pod. I'll delete this as well, correct? So I don't have any pod running at this moment, and I don't have any daemon set also running, correct? Now let's start. So I will have this pod created. So let's see what this pod is. Or sorry. Sorry. Sorry, what's the name? Pod volume mount. So this is a pod I'm going to create. It doesn't have any label or anything, but this is what it is, correct? So kubectl create -f. So this pod got created. Now if I say get pods, and I can say show labels also. So there's no label, and this is a pod which is running on this, correct? So now let's go to the next step. And if you see the same pod, right, the volume mount and all those things happening, my home directory on Mac is being mounted as on the temp1 folder inside this pod, correct? Now what I'm going to do is I'm logging to the pod, and just to validate it. So kubectl exec-it, IT means interactive, and then dash. And once I log into this port, I will see ls-ltr/tmp1. This is showing whatever I have on my local, Mac. So if I do the same command on local Mac, you will see same files being there. So now I will exit out of this port. So this port has been has volume mounted, and now what we'll do is uh, so we'll create a daemon set port. So I said our labels app name, sales on the node. So on the node, this daemon set will run on the, so we'll use the node selector in the daemon set, and the daemon set will have the label called app name equal to sales. So daemon set will look for the nodes with this label app name equal to sales, and any node having this label will get the daemon set port. So what we are going to do is we are going to get all nodes first. So kubectl get nodes. So let's see, kubectl get nodes. So this is the node, and actually I should have some show labels also. So it had the label or didn't have the label. I'm not able to see. What was the label name? App name equal to sales. I actually had already added it. So if you do not have it, so let's see if I can overwrite this app name equal to sales, and there's a command to overwrite this. So get label nodes, kubectl label node. Let me remove this first. kubectl label node, minikube is the name of my node. Then I will copy paste this, and then hyphen overwrite, hyphen overwrite. OVER, right.
kubectl.
kubectl hyphen override. So now what I'm going to do is I'm going to show the labels. Or somehow still showing it. Hold on a second. Label minikube, label node minikube, label node minikube, app name equal to sales, and hyphen overwrite. Like that, it should have removed it. Hyphen overwrite, not label, node minikube, not label. Oh, sorry, get not show labels. Some are still appearing. I think there's some glitch in this command, but what I wanted to show you was this. So so now what I'm going to do now is I'm going to create a daemon set, right? So earlier when I was running this before, it didn't have this label. So what I'm going to do now is I will create a daemon set, and the daemon set definition is like this. So you have the API version apps v1 kind daemon set, metadata app monitor, selector, match labels, app check security. And why we have given these labels? So that we can use the same label here. This is the same example which I was showing you in the previous one of the previous slide. It's the same. So this is a port template. Metadata labels this. Then I'm creating this a port with this, and here the image I'm giving is the different one. This is a log checker image, and the same volume I'm mounting, right? So let's see that. Unless this is daemon set, right? So I forgot the name of the file. This is the name of the file. So cat daemon set 1. You see it's the same thing which I was showing you, right? So now I'll do a kubectl create -f daemon set 1. So it's created a daemon set, and I can check the daemon set now. Kubectl get daemon set, and it's showing the node selector equal to app sales. Now, when I didn't have that label on the node, it was showing that desired count is 1, current is 0, ready is 0, and up to date is 0, right? And that's what I was, I had shown here. So it desired it was 0 because it didn't find anything. current is 0, ready is 0, up to date is 0 because the labels are not matching on any node. Then I change the label. Let me see if I can change the label now. Instead of app name equal to sales, I can give something else. Let's see if that works. App name equal to sales 1. Let's see, get nodes. Now it sales 1. Now we'll see what is the value of this daemon set, how this daemon set appears. So now see, there's no desired, this daemon set is not running on any port, right? Now what I'm going to do, and because it has this node selector and this node doesn't have this same label. So what I'm going to do is I'm going to change the label back of the nodes to sales 1. And now let's check the DS, because now the node has this label app name equal to sales. Now you see the daemon set is running on one node. Incidentally, on our local environment, we have only one node, so that's why it's running on one node only. Right. So now let's do this. So let me clear this out. Now what we are going to do is so this we validated. Now we see the desired current and ready up to date available count as 1 because that's the number of nodes we have. This pod is running on. And now the question was, if the daemon set is able to select the node using a node selector, then it will be, it will be running for all the pods. So there's no correlation, right? Because daemon set will be a pod in itself. So what we are told daemon set is to do something inside that pod. Now there might be 5 pods, 10 pods, some extra pods, 10 other extra pods running on that node. Daemon set doesn't care what those pods are doing. In our example, what we are expecting those pods to write the logs into certain base log folder, and this daemon set is supposed to take the logs from that base folder and put it into Splunk. So if you have one pod running on the node and you set a daemon set and it's not matching that node, then you will have only one pod running. But let's say you change the label selector, node select, you change the label in the node and change it to the value which is same as a node selector on the daemon set. The moment you change it, the daemon set will get started on that node, and after that you will see one extra pod is running on that node, and that pod will be for daemon set. So that's how it works. So now what we are going to do is we are going to do a little experimentation, right? So so now we have, if you see the ports, let's check the ports now. kubectl get ports. So now you have 2 ports running. One is a daemon set port and second is your application port, correct? Now what I'm going to do is I'm going to open the log files. This is the log files which has been daemon set has been checking, and what I'm going to do is I'm going to edit this, and I'm going to tell in this file I'm going to tell how to, let me delete this. Sorry, I'm going to manually write some some words which it is looking for example password and SSN, correct? So let me do this. Then I will write SSN password, okay, and I will save this. Okay. Now, if I look at this again, it has SSN password, and this is a file which this is the volume we mounted, and this is the file which our checker is checking. So I will. And how do I know? So the reason I know is because if I go here and let me do one thing. Let me say kubectl exec-it is the image -bash. So I'm logging into the daemon set port. So if I go to tmp1 and I look for the file, sorry, let me clear this out and look for this file which I modified, tips.log. So tail -f tips.log. This is what I added, SSN and password. And because this volume is mounted on the daemon set, so I can see this in the daemon set. This is a daemon set, pod. I'm logged in there, and this I can see this file there. Now, what I'm going to do is I am going to log into this daemon set from other this thing also. kubectl. Now there is on the daemon set. On the daemon set there is another checker.log. No, 1 second. Let me log it again. and ls, you will see checker.log. So I'm going to tail this file checker.log. So now let me tell you what these two files are. The first file where I have written this, tips.log, where I have manually entered SSN password. This is a file which is generated by this pod. This is an application pod. Now there's another pod, this the daemon set pod. It is going to monitor this file. And the moment it finds some problem there, it is going to log a statement into this checker.log file that I found a problem inside this log file. And what that problem is, it's going to log that problem inside this checker log. Now, how would it do? So what I'm going to do now is I'm going to log into the daemon set, thing again. We have to invoke that web service, for daemon set pod. So exec-it this. Okay. So now what I'm going to do is, I showed you in the controller, daemon set controller, right? Let me show you again. In the daemon set controller, I have this /check, and this /check invokes the security checker, and this security checker check this application log file, and the moment it finds password and SSN, it logs into the and that log is into checker.log. So this is what I'm going to show this to you. So I'm going to invoke this service. So the service which I'm going to invoke is curl localhost 8080/check. Because I am on that daemon set port anyway, it's easier to invoke from there instead of setting a port forwarding and everything. So I'll invoke this here. So it found, completed yes, and it found this. It found the SSN, and it finds that SSN is found and security is breached. Password is found and security is breached. So that's what it checks, and that's how it logs. I'm just reiterating again. For our crude and wake service, we have been logging it, and we are passing the log file also. We have hard coded the log file. Generally, you pass these as the parameters, and when you find a problem, then you just send alert or notification. Alerts are PagerDuty alerts, notifications are emails or Slack messages and things like this. So that's how it works. That's how daemon set works. So what we'll discuss today is a replication controller, replica set, and daemon set. Replication controller and replica set are similar. Replication controller is the older way of doing the same thing which replica set is doing currently. The reason we'll go through replication controller is because many applications or many configurations are still in replication controller. So it's good to know in case you need to deal with those applications. So replication controller, what it is and why do we need this? So in the past sessions we have discussed, you could create pods using YAML file where you give type pod. Generally we don't create pods directly. The reason we don't create pods directly is that if that pod cracks, if the container inside the pod is crashed, then pod will start the container. So that gets taken care. But what about when the pod itself has crashed, or the node where the pod is, that node itself has crashed? So then you can't restart that pod because you created only pod. Generally you create deployments or application controllers which can create and manage pods also. So if you use either of these, we'll discuss deployments in some later sections. But if you use either of these, then if pod in node crashes in node, or which pod is deployed, if that crashes, then automatically a new pod gets created by these objects. This I already discussed. Node failure also gets detected. There can be pod failure and there can be node failure also. So node can remain intact, but pod can fail for whatever reason. So that pod will get started, or the node itself can fail. It can crash. And when you're dealing with clouds, your nodes, there's a high probability of nodes keep getting crashed. So that also gets handled. Now the way replication controller works is it operates on pods matching certain label selector, and we will see that. So how does this replication controller manage the pod? Let's say on node 1, you have pod 1 and pod B. Pod B is managed by replication controller. Pod 1 is not managed by replication controller. And then you have some other node which has some another pod running. Now let's say node 1 has crashed after some time. And when node 1 has crashed, this no longer exists. But because pod B was managed by replication controller, pod B gets restarted on some other node because replication controller is managing it. But pod A has gone for good because it was not managed by replication controller, for example. So how do you create a replication controller? So as with many, as with every object in Kubernetes, you can create using command line or API or YAML. So we'll use YAML here. We'll go through this YAML, and then I will run and create one. Actually, let me start the. Just give me a second. I will go through this, then I will start my Kubernetes and Docker. So this YAML, of course, the API version v1 at this moment. And here we are specifying kind is application controller. Earlier we were specifying kind is pod or other things. So here it's replication controller. The name of this replication controller is, this is the name I have given. The spec, the replicas, I want to have 2 instances of this pod running. Selector, this is the selector I'm giving, and this should match what I'm giving in the template below. We'll go through this. This is a pod template. In pod template, you have metadata and your labels, and this what value you have, selector key value here, it should match to this key value here. Then you have spec, there should be indentation. So, forget my, wrong formatting here. So under spec, you have containers. It's the same, you are using the same, the name is this, image is this, image pull policy is not present, and I'm opening 8080 port here, and this is the command. This we have been using in the pod for a quite long time. So let's try to run this. Give me 1 second. So now we are going to create a replication controller. So before I do that, kubectl rc, I think that's what it is. There is no replication controller yet. So I will create one, and now replication controller got created. And now you can see the replication controller, it's desiring 2 pods and 2 are running. So I can see those pods also, kubectl get pods. So this pod was already running. So I will, don't worry about this, but these 2 pods got started. And it's saying error image pull. For whatever reasons, the images it's not able to find. So minikube kub image ls min. So looks like I don't have that image here. That's why it's not able to find that image, and it's not on the Docker also. So that's why it's saying erase error image pull. I'll fix that image issue, but as you can see, right, it has the 2 pods started. Okay, and what is the version of the image I have given here? It is supposed to take image latest only. Okay, let's see. Okay, the image is not found here. So what I'm going to do now is I'm going to check if this image exists in Docker. Docker image ls. So these are the images. That image is here with version 9. So it's not there with version latest. So what I'm going to do now is I'm going to open that, my replication controller, and change it to version 9. REPL controller, and change this to version 9. And what was the 9.0? Latest instead of latest. Say 9.0. And I'm going to see if 9.0 exists here or not. I'm going to load it and then see it should work. Now let me get replication controller, and I'm seeing I'm using this Java -docker_sh 9. We're still not able to find. Unable to add the image Java docker sh. Oh, it is underscore. My mistake. Keep making mistakes. Let's load it right now here. I was playing around with certain things. I ended up changing the name of images, etc. So that's why it's causing this. So now I have update this again. I will say instead of hyphen, it's underscore. Save this. This is the thing. So let it load. It takes a while. While it is loading, I will run that command again. What I am going to do now is I am going to delete that application controller. So now what you're going to see is kubectl get port. It will still be having, oh, somehow it's running because for whatever magic has happened, it found the image and it's running. So let's keep that here for time being. And now I am able to start the replication controller and I'm able to see that kubectl get RC means replication controller. This replication controller is running and there are two ports it wants and both ports have started. So the port names will be this complete thing and hyphen some characters which Kubernetes will put. So these are the port two ports which are running. Now next one. What happens if I delete an existing pod? So delete existing pod. So I will delete using this kubectl delete pod command, and then we'll see what happens. So now I see these two ports, right? So I'll take one of these ports and I say kubectl delete pod. I can do this also. And I deleted it. Now let's see what happens. It again started something, the new one. So this one does not exist anymore because this is what was existing earlier. I deleted that, but then it started new one. This new one it started because replication controller wanted two ports to be there. It detected that one port is not there anymore. And in the replica set here, if you see the setting of the replication controller, I said replica equal to 2. It always wanted 2. One was not there. Only one was there because I deleted the other one. So it started the new one to keep it, to keep the replica count to 2. So that's, to validate that, replication controller asserts or make sure the specified number of replicas of ports are running. So this we already did. Try deleting one port and then kubectl get ports. Then we'll see this, and we can always see the describe and everything. So I deleted that, and okay, this we have done. Describe. Let's see the describe replication controller and see what happens. So we have not done that. So where is the replication controller? We'll do that again. kubectl get rc. And we'll say kubectl describe rc DESCR. So this is what it is. So it says this is a selector. It is using selector and label replicas. There are two replicas it desires and two are running, and both are running. No one is waiting or failing or anything. The port, the command, whatever given in the YAML file, all get displayed here, and it just tells which thing was running. So it was initially running these two. Then I deleted one of these two and started this one. So it prints that log also here. Let's describe this. We are done. Now what I'm going to do is let's run this command. Kubectl get port. You see two ports running. Kubectl get RC. You see replication controller running. Now you say kubectl delete. Now I'm going to delete only the replication controller. So RC, and I'm going to give this and see what happens. Spelling mistake. kubectl, it deleted. Now you see RC does not exist. sorry, this is the RC, it does not exist, and ports also don't exist, correct? Because port got created by replication controller. If port went, then replication controller. If replication controller went, then port also went. This is a port which I have been doing some work on, so it's already, so don't worry about this port. You can always create it back. This we already did. We have described it, and this we did. We did the kubectl delete. So generally, cascade files is a flag. If I give that and see what happens. So what I'm going to do is I'm going to create the pod again, create the replication controller again. Where is that command? So kubectl create -f. So I created that. Now I will run the same thing again. You see replication controller created, you see pod created. Now I'm going to run the command again with this flag. I'm going to delete the replication controller with this flag. What is this flag? -fs cascade equal to fast, and then see what happens. CASCAD equal to false. Okay. Now you see the replication controller is gone. There is no replication controller anymore. You see that here, but the pod it has started are still running. Why? Because I have said cascade equal false, means you don't cascade the deletion to the children object of pods. So that's what it means. Now I can go ahead and delete the pods. kubectl delete pod, this one, then pod, sorry, the next one got deleted. Now I say get pod. So now those pods are not there anymore. So if you, by default, if you delete replication controller, pods automatically gets deleted, pods which got created by this replication controller. But if you give cascade equal to false, then only replication controller gets deleted and pods remain intact. So this is the flow. So replication controller check the number of pods matching the label selector. We discuss the label selector here, right? And we'll go into more details of this. So this is a label selector app, this one, and the pod which you are creating also have this one, and replica has two. As long as you have two pods with this label, replication controller is good. But what happens if the pods do not match? Is the match count same as desired the code count? If it is less, then it creates a new pod. Create a new pod from the current template. And we saw that I deleted one pod, then it ended up creating the new pod. And I will show you in subsequent sections that it will create the new pod with the same label anyway. Sometimes if you also end up creating pod outside the replication controller and you also give the same label which replication controller is using, so the replica count of the pod will increase, and replication controller will check that. Although the pod got created by outside, it will check, okay, this is the pod you created which has the same label, and now the number of desired pod count is more, so it will delete the extra pod and keep the count same as desired. So that's how replication controller works. Now what we're going to do is, so replication controller manages pods that match its label selector. We discussed that. Pod can be removed from replication controller by changing its label. Once we do that, then this pod will become like any other manually created pod. So what we are going to do is, we're going to see the labels of the pod. So kubectl get pods, show labels. Oh, I forgot to create the replication controller. So let's do that. Now we'll see show labels. You see both have the same label. And of course, let's see the replication controller also while we are at it. The replication controller also exists. So now what you're going to do is change label of one of the pod and see what happens. So how are you going to change the label of the pod? So I'm going to write the exact same command, cube label pod. Let's do this, kubectl label pod, and I'll choose some random pod. I'm choosing this, and after that, app equal to, I can give anything, app equal to some random thing I will give. Then I have to give this -hyphen override. We discussed that during the available time. OVER overwrite. Now you see the ports. So it was for the random which I created is still there, but because replication controller detected that the number of ports with this label are less, so just 4 seconds ago it ended up creating new one, so that the number of ports with the same label are exactly matching the replica number of replica which had given. Okay, so this is done. Okay, this we discussed in the label anyway, so forget that. Now you can change the template of port with below command. So let's see how to change the template. So you can say, clear this out, kubectl, then edit, then rc, edit, rc, and what's the name of our rc? I wanted to copy that, this one, control C, control V. Once you do that, then it opens an editor for you, automatically opens an editor, and you can change. You want to change replica to 3, or you want to make some other similar changes. You can go ahead and make those changes, and that's it. That's the, I'm not making any change, but you could always make the change, and then once you save it, then it will automatically execute that while saving itself. So that's one way, but it will be effective for will open the new editor and you can change the template there. What I said was not correct here. It will be effective for new ports only. What do you mean by that? I make this the template, I may change this template, and then I do not do anything, and the ports are same, no, nothing happens to the port, then no change. But if I delete, let's say I open this, open this, and I change something. Let's say I change the image or something of this command, like the command option here. Then once I start a new pod, once a new pod gets started because of the pod crash or because I deleted the pod, then it has to start automatically new pod. Then these changes will be applicable. Okay, so let's read this. I did not read this. Please edit the object below. Lines beginning with the hash will be ignored. An empty file will abort the edit. If an error occurs while saving this file will be reopened for relevant failures. Yeah, so that it makes this editor make sure of that. All right. How do you do horizontal scaling of pods? You can change the number of replicas using this command to any number of replicas you want. But I discussed that you can do using edit also. You can change the number of things. We'll do both. We'll do both and see what happens. So right now, kubectl and get pod. So we have I should say show labels. Show labels. So I want to delete this because it's unnecessary. kubectl delete pod this, and I will delete the another one which I had created for my some other testing. I will delete this also. So now these are the 2 pods running. Right now I run this command kubectl scale rc, kubectl scale rc, and I give this, and then I give this -FN replica is equal to 4. I will give 10 will be too much. My laptop is already heating up. Now I go to this and say you 4 ports with the same level I've started. That's one way. And I will use the edit also, edit option. So we'll do the edit. Where did that go? Edit. And 4 were already there. I'll make it 5 here, just to be sure. 5. Then I save this. Then I say 1, 2, 3, 4. 1, 2, 3. Sorry, we discussed that this changes because of, let's check one more thing one more time. 1, 2, 3, 4. The changes in the edit won't be applicable till the new pod or something else happens. So that's why let's check the edit again. Oh, sorry, my mistake. It had, how many it had running earlier? 4. Let's try to change it to 5. Let's see what happens. Let's try to change it to 5. 5. Now fifth one is created. See, the replica it's taking immediately, but if you make any other change, and don't make change to replica, and replica remains same, you make any other change, then it will take in the next pod creation, not in the existing pod. So now let's go and change it to 2 only. Let's see if it works. So I'll change it to 2. And I save this. Now let's see. It's terminating. You know, it was 5. 2 terminated, 3 it was terminating. So now I do it again. Now you'll have 2. So that's how for replica changes it affects immediately. So this we already discussed. When you're deleting, you can delete only the replication controller and not the ports using this feature cascade equal to false, or you can delete both as well. Either you manually give cascade equal to true, or you just don't give this, then by default deleting the replication controller will delete the port as well. And that's what we saw when you deleted the replication controller, ports associated with that were gone. So so that's about deleting. Now we'll move to the replica set. So replication controller is deprecated right now. We should use replica set instead. And the reason we went to replication controller is, as I discussed, right? Many applications configurations still have a replication controller. So you should know such object exists. The replica sets are created by higher level deployment resource. The replica set allows selecting ports which lacks or has a label key, regardless of label value. So this you didn't have in the replication controller. So here you can say the matching can be done on the label key, no matter what the value is, what value the label has. Our replication controller, RC means replication controller, RS means replica set. Replication controller can't match this environment equal to double or development or environment equal to production, but replica set can match both. A replica set can match all ports with just key also. I think we just discussed that it can match with all keys as well. So we'll define the replica set. So let's see the replica set thing. Cat and K8 I think I renamed it. Let's search for set. Cat. Sorry. LS. LS. So this is a replica set. So cat replica set. So this is why I'm creating the replica set. This is the API version apps/v1. For different type of object, you might have different apps API version. For replica set, this is the apps API version. So kind is replica set. This is the name I'm giving. The number of replicas I'm giving 3, and the selector match label app Java tips backend. I think same I'm giving here, and it's the same policy, same image. Let's see if the latest exists or not, because I was not able to create the replication controller. So let's see. So kubectl get ports and get replication controller. So I'm going to terminate the replication controller and start the replica set. Delete replication controller / control B, deleted. I should not have any replication controller, neither should be ports. So there are no ports. So what I'm going to do now is I'm going to create the replica set. So kubectl create some F. Okay, it got created. Ports are running, so it found the image, and I can check the instead of get port, I can say replica set. So replica set is also running. So 3 desired, 3 current, and these are ports. So let's describe it just for our satisfaction. DSCRI describe replica set. This one namespace is default. These are the selectors. We are not using label or annotation. 3 replicas are running, 3 ports are running, and this is a port template, and this is what had happened. So now let's do one thing. I will get the ports and will describe one of the port also. just for curiosity, kubectl describe pod. All right, too much information. So this is what I wanted to check here. It is controlled by, this pod is controlled by this replica set service, this replica set object. So this is a name, namespace default, priority, node, it's running on this node, start time, label, of course, annotation we have not given, status running, IP address. It's controlled by this replica set. This it has this container, information about this container, and other things are, you know, usual things. Conditions, volumes, information is here. There's no node selector we have given, and the events. So it created this container, and all those things. Yes, good. So that's how replica set works. We have seen this create. We have gone through this describe also, and we have seen this kubectl get replica set command also. Now we'll delete it and see what happens. Let's try to delete it with cascade files and see if that works here also or not. It should work, but let's see that. It's a replica set and it's a pod, correct? Now kubectl delete replica set slash this one, and say cascade cascad equal to false. Cascad equal to false. Let's see what happens. Deleted. Now replica set does not exist anymore. Let's see pod. Oh, cascade works here also. So good. So what I'm going to do is I'm going to delete. I will delete those pods separately. So let's pause it here for today. We discussed this, and if you give cascade false, then cascade true, then it will delete the ports also, like it did for application controller. We'll pause it here. Next time we'll discuss the daemon set, but what is daemon set, how you can configure and how you can run. So let's keep it for the next session. Thank you very much. And yeah, so I will discuss the job resource today in Kubernetes. So a job resource is a single task which terminates or completes. So it could be one task which runs only one time, or it could be a repeatable task which runs after certain intervals. So generally when you have a pod, if something happens to the pod, a container inside the pod, the pod gets restarted. But here what we want is when the job inside the container is finished, then it should not restart. Nothing should happen to the pod. And so we want that. But when the node gets failed, the pods on that node should be rescheduled to another node by the job resource. And that's what job resource does. So if you have a job running on some pod and the node has failed, it will, as normal Kubernetes process, it will start the same pod which has a job resource on the other node. Process failures, if you have to identify the job which is running inside your pod, if that is successful or not, that is identified by the return code of that job. If return code, generally you see, right, -1 or something is considered as failure. Same is the case here. You can configure the job to restart after the, in case of failure, it can restart the container because failure might have happened because of some temporary issue with the container. Or you can configure to not restart the container, because even if you restart, nothing is going to happen, job might still fail. So these are the configurations which you can do. So what I have done for this, just an experimentation, I created a separate code repo, and that code repo is, geocoding, because I wanted to do some one-time task. So there is something which does something and then finishes it. So it's a Maven application, Maven Java application. It has a main method. So you can, jar is built by Maven with many class defined in pom.xml. So in pom.xml has all the setup and everything. So once you do Maven clean install, it will build a jar which is, which is runnable. So it knows which main method is. So I'll tell you, what this, what this job does is. So in this place, this is the the code. So only one class is there, reverse geocoder. So at any time in your if you ever work with the geocoding or geocoder, geocoding is basically getting the latitude and longitude based upon the address. Reverse geocoding is you pass the latitude and longitude. This is the latitude and longitude I am passing. You can get the address. So this is the external API I'm invoking, API position stack, whatever, reverse geocoding. And this my key, this is a confidential key. If you want to access, maybe you can create your own or whatever. And so this is the API which I'm invoking. And then I get the response. And I think somewhere I'm just printing the response. I'm not doing anything. I'm just saying system.out.println and get the response and print it. This is the main method from the main method. So main method called this reverse geocoder. Only one thing is, because I want to simulate the error scenarios also. I want this, what I want to show what happens to the job, Kubernetes job, when error happens, when the job runs into error. So create this error, to create these error scenarios, I sort of designed this a Boolean flag you can pass in the constructor of this job, and if Boolean flag is true, then it considers the wrong data. And then if it is wrong data, if the flag is true, it just throw an exception. It's wrong data, throwing exception or something, right? So something like this I do. There is one more thing somewhere I had put, if you pass more than one argument also, then also it fails. We'll see that. So right now, this is how the job is. And now going back to the slides. Okay. Now let's see so I have created a Docker file out of this. So this is, I use this image and work directory, whatever. This is a normal Docker file. From this Docker file, I created I run this Docker file. I created an image. If you are using Minikube and you create, this is how you create the image. Docker build -t then geocoder. This is the name of the image, geocoder. It should be GEO. So this is the name of the image, and this is the image I created. And once you have this image, then if you are using Minikube, then you have to specifically load that image. If you are using Docker desktop, then you don't have to do this step. But in the Minikube, we have to do, because Minikube does not recognize images we just created using Docker automatically. So you load this image which you created using Docker in Minikube so that you can use that. Now, as I said, there are two types of jobs. A one-time job which runs once and finishes and then never runs again. Second is cron job, which needs to run at periodic intervals. So both are supported by Kubernetes job resource. You can restart if the job has failed. You can restart the job, or you can configure it to not restart also. And we'll see one example of that. So this is one YAML file of a job. So what I do is, this is the batch v1 version, API version for a job, and kind is job. This is the name I'm giving. That this is a template. This name and this name should match, because this is type job. It will create a code also for this job, so they should match. Actually, no, this is just a name and this is a label. That's fine. You have to create a spec, and there it's a normal pod template, right? Restart policy on failure, containers. This is the name of the container. I'm giving the same name as the image name. Image pull policy is never. I mean, I'm telling not to go to Docker repository because my image is already on my local. And this is what I pass. Java -jar, and all of this, right? This is the because in the Docker file I had already I created Docker file also, and then I'm just running this Java -jar and creating this. So just checking something. Yeah, so everything is in the source folder. So you compile it, and then I already have the jar file created. So in the Docker file, jar file is jar file is already uploaded, and then you can run this Java -jar, and this is a command. When the code starts, the container will start with this process. And now this I already explained you. API version, label, create code, and job object should have same label. So spec template metadata label, spec template metadata label. This is the name, and uh, create pod and job object should have this label. So I think the label needs to be same. This is a geocoder app, and this label I have not defined. I don't think it needs to be same. The image, restart policy, and then you create. So let's do one thing. I will create this job right now, and these YAML files are inside this project itself. Inside this project itself. So all the job YAMLs are here. So what I'm going to create is I'm going to go to that project. So I'm inside that project. So I create, this is the, this is a job. This is the YAML file. So whatever I explained, I have given that here. We'll come to this backup limit 2 later in the session. So let me create this file, create this, job. F. This is the name of YAML. So now if you see kubectl get job. So one job, right? Now you see, let me show you get code also, so that there's something which I want to explain. Now if you see, right, the job, it is supposed to have one completion, and that completion is over. So it's 1 out of 1 completion is over. It's one-time job. In the pod, you will see, it's 0 out of 1 is ready, but the status is completed. Status is not failure, like you see, when you have a problem in starting your pod or container. Here, status is completed means, of course, this pod is created by this job only, and it was supposed to run some process, some code. It did finish, and it's completed. So now it's no longer running, right? And the reason it stays here, ideally, you could very well delete this job after it is completed. But if you delete this pod after it's completed, but they don't delete the pod after the job is completed, in case you want to see the logs of this pod, whatever has happened. That's why it's not deleted, although it is completed and it's not running anymore, right? So now let's see that. This I explained. Now what I do in my code, if you go and see the code, what I do in that code is, I showed you, I run the, I print the geocode address. So I pass this latitude and longitude, and whatever response I get, I print that. So if I print that, then let's see, it should be available somewhere. So for that, let me go back here and let me put in the slideshow. So I can see the kubectl logs. So first you can see the, okay, you can see one more thing I wanted to show you was this. We were discussing about the labels in the job and the pod. So let's see both labels. So you have this job, I can say show labels, and I have this pod, show labels. So both are going to have the same labels, app geocoder job and app geocoder job. So that's how you can always describe the job also. But this way, this is a job, geocoder hyphen job, and this is a type job, because this is type job because I saw the job. It has the same label, and this is type pod, which has the same label, right? So because it got started by the job, so it ended up giving the same label to pod and the job also. Now it has run once because it's completed, and you see 1 out of 1 completion is done. So I want to see the logs also. So kubectl get logs pod. Sorry, mistake, kubectl logs. So this is the this is some other spam retreat Bangalore, and I just found out the latitude longitude of some property that I was seeing, and they showed the map. I copied the latitude longitude of that and used that the same thing. It's some property in Adashpam Street in Bangalore or something in Belanduru. It's near Belanduru, so you can see all of that. This is our, it's in India, and all those things. Somewhere it must be saying Bangalore also. This is the name and all those things, so you can see that. Here it's saying region code Karnataka, county is Bangalore, which is city, locality is Bangalore, neighborhood is this, whatever. So this is the result which is given by the service, and I just logged it. So now what we are doing is, if the job fails, right? So what happens? So I have this, we'll see. I have this YAML file, job one-time failure. So we have the restart policy. I think let's see this YAML file, job one-time failure. Get job one-time failure. So you have restart policy of never, and I'll tell you what this never is. Never, we misunderstand that it will not restart if it fails. It's not that. And this back off limit is true, and I will explain what that limit is. So before I run this, let me delete the existing job which I have. So kubectl get jobs, and if I see get ports also, if I delete the job, port will automatically go away. So kubectl delete job, and it got deleted. Now if you see the job, there's nothing. If I see the port, there's nothing, because the port was started by the job itself. Now let's run this kubectl create SMS. So this port got job and port both would have gotten created now. So if I see this get port, it's running into error, and you see it's starting. It keeps starting. If I see this, after some time it keeps starting. But let's see the job also. So job is not even completed, and why it's running into error? So somewhere in my code I have the logic that if you pass an argument, then the job will run into an error. Okay, that's how the code is designed. Now it's running, and it only thing I have said is let's see the code. It will keep starting, and you will see after some time it keeps starting it forever. While it's doing that, let's see that restart policy is on failure. There are I think I have changed. I had in the when I copied passages, I had it on failure, but now you had never. So we'll see both of the same. It will restart the job on the same port. 6 is the limit by default for how many times restart will happen. So what we are going to do is I change it to never. Now let me change it back to restart policy on failure, and then see what happens. Right. So, but in the meantime, let's see. It started only 3 times. Okay. kubectl get jobs. So job is still there. I'm just checking this. kubectl delete job. So job got deleted. Pod will also go away now. Job also is gone. Right. So now let me modify this this file. What is that? Let me copy paste the file name. VIM. Then job one time failure. Job one time failure. And what was the restart policy on failure? Just validating it on failure only. Yes. On failure. So let me restart this. Control R. Sorry, Control C. Control R. Create. Got created. kubectl get jobs. Job is there. Get pods. So pod is there. So now we'll see what happens. It will restart. You will see the number of restarts increasing here. Right? That's what is going to happen. Oh, pod went away. What happened? Sorry. Job is there. Strange. So generally, we have to check why it's not restarting. But when you have the on failure, it will restart the job on the same pod. So I'm wondering whether starting a new pod itself. CTL describe job, and where is my job? Not code. This is my job. So job has reached specified back of limit. Okay, so generally the back of limit is 6. uh, Either it is less, or we did not see, suddenly it reached out the back of limit, and then it's deleted the pod. So it created the pod and deleted the pod. Something like this had happened immediately. It found, these are not in right order. These are happened only you know at the same time. So first it should have come, job has reached the specified back of limit, and it is 2 times in 44 seconds. I think somewhere I have changed the setting, instead of 6 I have changed it to 2. So if it I think in the subsequent slides, I think I have covered where you can change the setting. So for me, I have changed it to, if 2 times it fails, then just consider it as failure, and then it leads a job. But the thing is, it happens on the same port. That's the advantage of on failure. Now you saw I had given a never here. So never means it will not start on the same port. It will keep starting on the different ports, and it will make all the ports available. And we'll see that also. So this is what I had done, and I was seeing this error. Initially restart was 0, then restart became 1, and so that's how it was happening. Now okay, so now we'll change the restart. This is what I had done. So I had just done restart policy was never. Now this is what was happening. It just kept creating the ports after ports to keep retrying. You see some port got created 6 minutes back also. So here never will restart the job on different port. It has no limit by default for how many times restart will happen on different port. See here, you knew that at least by default 6 times, and somehow I changed it to 2 times for me, that on the same pod on failure, when it happens 6 times, then just consider the job as a failed and delete the pod and everything. It will still keep the job though, but it will delete the pod. But when you have never, it will just, never ends. That's what never means. It just keeps doing it. Now we want to control it, right? And, so basically, oh, I know why it's happened. Sorry, why it happened 2 times. I know. So let me show you the file. This is a good thing. We will test that also right now. So LT, so one time success. Yes, it's a back of limit. So, so I had changed that back of limit. So VIM, VIM. So I had given this back of limit of 2. So let me, if I remove this, we'll test it out right away. Remove this, and let's delete the kubectl get jobs. So let's delete that job, kubectl delete job. Now let's run this again, and this had on never, I changed it to on failure. I should have created different YAMLs for this, but bear with me. On failure. So if I do this on failure, now kubectl create SMS, and we got created. Now let's see, get the ports. Get port. It will just keep restarting. I think, I don't know how long it waits, but it will keep starting, and after 6 times it will say it's done. Okay, yeah. So we saw it restarted around 2 times and then backed off. I remove the back of limit. Oh, it says completed. Sorry, my mistake. I should not have changed this. This is a success file. I changed the success file. I should have changed the failed file. So let me delete the pod again. Delete pod. Deleted the pod. Now let me change this one. It had back of limit, and that's where it will start. Because here I'm passing a parameter, extra parameter, which makes my job fail. So now let's see that. So kubectl create -f, on this file. So let's get the ports. So restart happened once, restart happened after some time again, restart will happen. Keep doing it, we'll check it later. Let's move on with the other parts. So you will see restart keep increasing, and after 6 times it will just delete the port itself. And we can see the described job, it will tell you why we deleted that. So restart second time has happened, incidentally after some 20 seconds or so it does that. So we'll see 6 times, but let's move on. So for restart policy never, these many times pod will start on different nodes. I mean, whatever nodes is available to, because on never the new pods get created, and whatever scheduler decides wherever whichever nodes have the pod, it will get restarted. So there's no guarantee that the pod will be started on the same node. So that now we discuss the difference between on failure and specify. So to control the number of restarts, we can specify the backup limit. So it works for never also. With never also we can specify the backup limit. Now let's see, and I want to move on to the different one. Still 3. So let it complete to 6. And in the meantime, let's see describe the job. So it still has that it's successfully created pod, and the pod is still running because it has on failure. So it will restart the 6 times, and then so I'm just deleting that. I want to discuss the other things also, but you get the idea. So now jobs can be configured to run more than one pod instance. Those instances can run parallelly, or you can run sequentially also, and we'll see example of those. It is done by setting the completions and the parallelism properties in the job spec. And this is an example. So here I want to run sequentially. So I have this job and the name of the job is this. And in the completions, I want to see 5. And rest of the everything is same. So now here I am changing it to just 5. And I am not in the subsequent, when you want to run parallelly, you can give parallelism flag. But here I am not giving this parallelism flag. So which means by default, it will start one after another. And we'll see that also. Let's see where it has reached. It's still 4. Okay. So in the meantime, let's look at this file. So job one time multiple instances of file, VIM job one time multiple instances. I think I renamed it to sequentially. SC sequentially, and I might rename the job also to sequentially, so that I can identify sequentially. Now I am running this 5 instances of sequentially, and all will do the same thing, right? I'm not passing any extra parameters so that my job won't fail, and I can see the logs all 5 times. I should see the address based on the latitude and longitude which we have. So now let's do this. kubectl create -f. So got created kubectl get jobs. Sorry, what was it? Get jobs. So 2 out of 5 are running. If I do it again, 4 out of 5, but I can see the ports also. So one port was anyway, so these are the ports, these are the ports started by the job sequence object, right? So now this this was the one which was running previously, right? So this will go off after a certain time when it started 6. So so now and these are all completed because these are successful jobs. These are completed and no longer running. Now if I see the logs of any of these, kubectl logs code, I will see the address, and I can pick up any other. Let's say the last one also I pick up. Control C kubectl logs port. So same thing. So all ports are doing the same thing. Let's see. These are all completed, and these are all still running, so that I can see the log. The previous one is still somehow not started 6 times. So we'll just wait for that. Now what I'm going to do is I'm going to delete the sequential job. kubectl get jobs. kubectl delete job. And this sequential. So 5 out of 5 are running, and the other one is running to error. So it's still 0 out of sorry. This one. And got deleted. So I won't see that anymore, and I see the pods. I won't see that. Still starting 5 times. So still waiting. Okay. Just give me 1 second. Okay. So this is how you run sequentially, and so I have given the 5 instances that we run 5. First, when the way it runs is one pod it creates. After first pod is created, it finishes the job which I told it to do. Once it is finished, then it will start the second one. And second, the pod will not be deleted. Pod will still be there, but the job which I had told it to run inside the YAML file, it will run that. And it will mark as completed. Then third pod will start, and then fourth will start, and fifth pod will start, like this, one after another. If there's any pod failure, it will trigger that job creating, it will trigger the job by creating a new pod and submit the job there. If I run this parallelly, so it will see here I have given, it will in total will run 5 jobs, and 3 pods will get created and done parallelly. And once any of these get over, then fourth gets picked up, then another is over, then fifth gets picked up. So that's how it's run. I'll show you that also, but let's see, complete this slide first. After container of, so these 3 pods get created and run parallelly. After container of any pod finishes, then next pod is created. Pod failures will trigger job creating a new pod. So this is a YAML file. And I had run this YAML file earlier when I created this slide. And you could see that at one time, and you got the pods after it got created, you'll see at one time 3 are running. And after some time, 2 are over, and then another 2 got started. So total 5 are running. So you will not see more than 3 started at the same time. The container creating or running, those status together won't cross more than 3. So this is how it is. So let's run that now also. Let's see what happened to this. So that is gone. It completed 6 times. So back of limit reached, and that is gone. So now let's see get jobs. Let me delete that job also. CTL delete job. Now there is no job and there is no pod. So what I'm going to do is kubectl create -f and job. Still, these are not cron jobs. These are still one-time jobs. Job one time, multiple instances parallelly. Let's see this first. Let me copy this. Control C. Let's see, it's the same file which I'm showing you in the slide. Okay, so completions 5, total 5, 3 parallel can run at the same time, and this is the command I wanted to run. So Control V. Sorry, mistake. What did I do? Control C. kubectl create -f. So job got created. So kubectl get jobs. I see these 3 are running at the same time because this is what I have told. So if you see the code, it might have completed all by the time I run this command, it had completed all the jobs. But at 3 at same time it ran. So you can see the output of this. I will see output from the one kubectl logs code. KUBE, and you can see same command, right? So this is how it runs parallelly. So let's go through this. You can change the number of parallelism. So I have given 3. So let's go through this first. Scaling job can change parallelism and job is running. It's similar like if you've seen in replica set, we have increase the number of replica in the replica set also. So you can use kubectl command, scale command. So kubectl scale job and -fn replica 3. So let's try this. Kubectl. Okay, I have to remember the job name. Kubectl. Let's get the job. Get jobs. Multi-completion value. I think I did not change the job name, but anyway, kubectl get port. So 5 are over kubectl ctl, then scale job, geoportal job, then because of scale kubectl scale job, and this is a job name geoportal job, and geoportal job and replicas. I want to change. How do it get this job name? 1 second. I could not find this kubectl get describe job, and this is the job. So it created the pod and everything. Let's see what else is there. This is the container it is creating. This is the name of this job. This is the namespace in default. This is a selector. Yeah, these are labels. This is the label. This is annotation. This is a parallelism. Okay, that's fine. Where did it get this name from? So kubectl scale. Let's try this. kubectl scale job. The job name was job name is here geoportal-job geoportal-job. Which job did I run? So when parallelly scale the job name geoportal, it should not have created this job. Sorry, my mistake. Let's see the YAML file again. Parallelly. Change this to parallel just to identify between this job and other job. Anyway, that should not have mattered. So multi-completion batch job replica 3. Let's try this. Let me copy paste this. Sorry. Let me copy paste this multi-completion batch job replicas 3. If it finds that. This also is not found. And I will give this okay, somehow it's not finding. I'll figure that out, and maybe the next time I'll explain you. So, skipping this for time being and moving on to the cron tab. So cron tab, as you all know, right? You have worked in the some time or other. You might have used cron text. So you can run the job either at defined intervals or one time in future. And here in the previous YAMLs, we were getting job of type the resource type as job. Here the resource type will be cron job, and it is the cron tab format. So at configured time, what happens when it is supposed to run when Kubernetes is supposed to run that job? A job resource as per the job template will be created. One or more replica created and job started as per the job template. Okay. So there is something called starting deadline second. If the job here I have given, for example, 15 in the spec, I will show you in the YAML file also. If the job does not start after 15 seconds, after the schedule time, then job will not run and it will be marked as failure. So this is how we run. Actually, I have not given that here. It should have, you see spec and you see schedule. So after spec, after schedule, you could do the starting deadline seconds also. But let's go through this cron tab. Now you see the difference. The kind is cron tab. The metadata name is, the geoportal job. So name of the job, it will be appearing in the kubectl get jobs. This is the spec and this is the schedule because it's cron job. So I can give the schedule. And if you don't know the cron schedule, this is how it works. So you have this, the first thing here is the minutes between 0 to 59. Second thing is hours. Third thing is day of month, 1 to 31. And then day of the year. And then day of the week, right? And 0 to 7. So 0 and 7 both are Sundays, because 0 to 7 is total 8. So 0 and 7 both are considered Sundays. So here I'm given this, minute, which is */2, which means it runs every 2 minutes of every hour, every day of the week, every month. That's what it means. And same, I'm using the geocoder image, and rest of the things are same. And we already discussed the restart policy. So so let's see the cron job here. So cat ls, don't remember, I keep changing the file names, so I want to see which file is as a cron job. So cat job cron. So this is the same file which I showed you. So what I'm going to do is, let's see any existing code running or job running. There's a job, let me delete that jobs. kubectl delete job, sorry, job got deleted. I will not have any job, and I will not have any port also, because all ports are for that job. Now what I'm going to do is, I'm going to create this, create a job from this symbol, from YAML. So kubectl create SMS. So this job got created. So let's see the now let's go through this. Earlier I was seeing the jobs. Now I have to see cron jobs. So let's see that cron jobs. So I am seeing this cron. So it's still running and it's not suspended. It will run after each 2 minutes. And let's see the pod also. If there's any pod, it has, because the 2 minutes are not over. So there's no pod. Once 2 minutes it's about to start, it will start a pod and run on that pod. So let's wait. And somehow I had given it 2 minutes, but it was starting after each 60 seconds or something. You see, after 12 seconds when I ran it, then after 60 seconds, then after 132 seconds, 72 plus 60 is 132 seconds. That's how it was starting. So let's wait. Get 4. It got started now, and it completed also, by the way. So within 29 seconds it got started. Just before 29 seconds before it got started, and it finished within 29 seconds itself. So after 2 minutes we'll start again, and you will see the difference. Somehow it was showing me 89 seconds. So I had to I was not able to figure out, although I gave 2 minutes, but it's starting after 60 seconds. So that I was trying to check that out. So let's wait, let it run. We'll move on to the other one in the meantime. I think that is all for the jobs. So I'll stop, and you can see the Kubernetes documentation of cron jobs here. I did not put Kubernetes documentation for job. I think that also will be similar /jobs or something. So that's about jobs. There is one thing for replica, changing at runtime, that I will tell you in the next session. But we discuss jobs, single completed jobs, what happens on failure, and restart policy on failure and never, and the cron jobs. So these are the topics we discussed. Yeah, so today we'll discuss Kubernetes service, and we'll discuss what this is, and how to create and things like this. So let's say you have created many pods. If you follow the microservice architecture, your one big system can be split into multiple microservices, and each microservice can have its own set of pods. These pods need to interact with each other. Let's say one microservice needs to call another microservice. For example, just say one example, but there could be many other examples of having pods need to interact with each other. So now the problem with this, and the pods need to interact with each other. Pods are ephemeral, what means that there's a tangent that it can crash. Once it crashes, then Kubernetes will start that pod immediately, a new pod immediately. So the new pod IP address will change, because earlier port had different IP address. It, for whatever reason, it crashed. New port has some other IP address. Now there's another thing. There could be, as I said, one microservice can have multiple ports underneath. But I don't need to know, as a user of that service, I don't need to know about the set of ports which are serving that service. I just need to know one IP address. So now, how do you define this problem? If some set of ports, so let's say just for our understanding, let's call these backends, provide functionality to other ports. Let's call those front ends inside the cluster. So now how do the front ends find out and keep track of which IP address to connect to for backend? So that front end can use the backend part of the workload. Now, that's one. So here we are talking about backend services which are consumed by the front end. Now, front end is also need to be, front end is also on the Kubernetes, backend is also on the Kubernetes. So front end will consume backend, but front end also needs to be consumed outside. So the outside users who are consuming front end, they also need to know one, unique IP address which does not change. The problem becomes worse because the front end and the back end both are on ports, and ports can keep coming and going, and ports IP address will keep changing. So this is a problem. Now the solution of that is service object. So you create a service object. So what is service object? It is a resource for making single constant point of entry to group of ports providing the same service. If the front end is a set of front end, set of back ends, they are providing the same service. I just need to invoke that, one IP address, and automatically internally it will figure out which port to connect and how to get the request served and everything. Now service has an IP address which can't change while service exists. Ports can keep coming and going, but service, as long as service, and when ports keep, crash and recover and everything, the IP addresses of ports will change. But for service, as long as service object is there, the IP address won't change. So now, what does that mean? That means that, no matter what happens to the ports, they're always accessible by the single IP address. This service is over the ports. Now, how that works and everything we'll discuss, we'll see in details. So client connections will be routed to one of the backing ports. Client won't need to know about ports behind the service. Ports can come and go, moved around, but services remain. So this is what client connect to the front end service. See here we are connected to the front end service. Then it has front end ports, and then actually this arrow should be here. My mistake, I will change it. So front end ports connect to the backend service, and backend service it connects to the port. So this how it should be. This arrow should be down, and this arrow should be connecting to the backend service, because as I said, we won't connect to ports directly. So I will correct this diagram. So what is service? Call to ports via service, is load balanced. There are various flavor of service, and we'll discuss, most of these flavors. But how ports are assigned to service? Ports are assigned to service via label selector. Take an example. We have covered how, when we create the ports, each port can have a label, and here also in this coming example also we'll see that. Let's say you have one port which has this label app, tips hyphen backend. So there are 3 ports, and the service also will have the same backend. So service in the service will have the label selector. So once we have the label selector, then this backend ports will be assigned to that service, and this service will be serving those ports. And there's another port which has some other label, and that label is different than the label selector defined in service. So a service won't be associating itself to this port. So let's do one thing. What we'll do is we'll create a pod, and we'll create a service also. So let's go through this YAML. And I think before this meeting, I was already doing that. So I can show you that. So there is a YAML, service one.yaml. It's in the same project which I've shared with you. This type is pod, and it's a pod, YAML. This is a label. Main thing to note, this is a name. You can give any name, and label. This is the main thing to note. It's app Java tips backend. This is a container. I think we have been giving this spec for many times now. Now this is service. Now I have given this in one YAML. One thing you will notice, there are two types I'm defining in one YAML file itself. One is pod and second is service. So if I have multiple types I want to define in one file in one YAML, I have to separate those by three dashes. That's how Kubernetes will understand new resource definition is coming. So here I am defining, so API version is V1 for service at this moment. The kind is service, here kind was pod, here kind is service. Metadata, name I can give anything. The spec, here I am giving pods. We'll discuss about the pods, but main thing is this Java tips backend, right? You see the label here, Java tips backend and selector app Java tips backend. So it is selecting those pods. Selector is, it means selecting those pods which have this label, and this pod has this label. What is pod? The service to the outside world will be available on this pod. But once I invoke this service object, Java tip service, once I invoke this service object, then internally service will delegate this to 8080 port of what? Of the ports which are having this label. And this port was exposing a REST endpoint on 8080. So this is how service and port are correlated. So let's do one thing. So let me show you that YAML here. I have already created that. So if you see here, so I created using this. Forget about this tips app and everything. So I will, why I'm not able to select. So ignore these, ports. Just focus on this port only, Java tips, because this is what I have created. So let me show you this services one.yml. So this is the same thing which I was showing you. This is the pod, this is the label, and this is a container spec. So I'm using the same image which I've been using for so long. And then this is a service, selector is same, and these are the pods, port and target port. And I've created created this service and port here. Once I created, I got the port, so I got this running. And then one thing which I have to show you is you got the port. Now I created a service. How do you get service? I say kubectl will get SVC. It will return the service. So this is a Java tip service which I was creating. Correct. So this is what you were seeing here in the YAML. This is a Java tip service. Correct. So this is the service which I had created. Now important thing to note here is in this service there is something called cluster IP, and you can see the port also which the service is opened on. This cluster IP is the IP which through which the service can be accessed, but within the Kubernetes cluster. If you are outside the Kubernetes cluster and you want to access the service, there's a different mechanism. There are a set of different mechanisms. We'll cover some of those later. But for time being, using any cluster IP of any service, you can access the service from within the cluster. You can log into any node in the cluster and you can access this service using this IP address. And we have done that. So, but before that, you can describe any object in Kubernetes. So I described this service object. So kubectl describe an SVC, and this is the name of the service. And it says one thing which of course you can check the everything else. But one thing which I wanted to show you was the label, the selector. There's a selector label, and it has will come to session affinity also later. And this is the port it is opened on, and it will request coming to this port will be sent to this port 8080 on the ports which it is associated with. Now how? So I got this. So I have this label here, and I wanted to show the same label in the port which it created, which is this, and you can see the same label is here also. Now let's go back to the here. It's the same thing which I showed you. Now I want to access this service, and I want to see this service is delegating the call or routing the call to the this service object is routing to the call to the port. So So this we have done. So I installed, by the way, Docker desktop. So now we'll be, doing everything using Docker desktop. So now what I need to do is I can say kubectl exec port name and curl. So why are we doing the exec port name? Because as I said, right, let me go back here. This service, this cluster IP, the service has this cluster IP, and this cluster IP is accessible from within the cluster itself. Now this laptop is outside the cluster. So you can log into cluster. How to log into cluster? Go to any pod in the cluster. It need not be the pod created by created by this YAML. You can go to any pod in the cluster, and from that pod you can invoke the service using this IP address and this port. So this is what I am doing here. Here also you can see. So I say kubexec and I go to Java tips. This is the pod I created, and then hyphen. Once I say hyphen, so I mentioned it here also. It means that kubectl command is over. Hyphen means kubectl command is over, and command inside the pod starts. So now you're running some command inside the pod itself, because you're logging into this pod and using kubectl. And once you log in, then what you want to do, you give that after hyphen. So hyphen curl -s, and this is the cluster IP, and then this is the port, and this is the of course my service has this context, this path. So now so I using this I invoke the service, and I got the response. By the way, here you can see the response. So using service, I invoke the service using cluster IP on this port, and service was able to reroute the request to the port directly, because service itself doesn't have any REST endpoint running. It's on the port itself, which is this port. So this is how service in the pod works, and how I can invoke the service, how I can invoke a endpoint on the pod using the service object. Session infinity. So not just in Kubernetes, but in outside Kubernetes also, you would want. Let's say you have an application which is running on 5 machines, and those 5 machines, I'm talking about a normal architecture outside Kubernetes now. Let's say you are on Google Cloud or AWS or Azure, and those services are behind the load balancers. All clouds provide load balancer. So now when you are invoking, when a outside customer is invoking the service, the load balancer gets hit, and the backend instance of the service gets invoked. So now the client invokes the service again. Now it's not necessary that the instance which was invoked by load balancer the first time for the same client, the same instance will be invoked for that service, because the service is running on 5 nodes, and all the same service. It's the same service on 5 nodes, and all those 5 nodes are behind one load balancer. The same client invoking the same service multiple times can make load balancer hit any of these 5 nodes. There's no guarantee the same node, so the same client will hit every time. But now what we want is, we want if I am invoking a service, and it goes through load balancer, and if it's node 1, the next time when I hit the service, it should hold node 1 only again. It should not go to anyone else. So that's a scenario in load balancer and nodes. Same is the scenario in Kubernetes I want. So you have a service object, and you have ports behind the service objects, and ports are more than 1 ports. So if you have more than 1 ports behind the service object, and I invoke the service object, I invoke the service using the service cluster IP, and I want whatever port it hit for the first time, I want same port to be hit on the multiple invocations of the same service. So that's called session infinity. So I will just read it out. When we invoke a service which is on port having multiple replicas behind one service, then request can hit any port. So create replica set and service using below YAML. So what we will do is, now so there, what I have not mentioned here is that I want to have it write only what's one one replica, same replica of the pod every time. So so let's go through this. So I'll create a replica set, and I will have this name, and the replicas are 3, And of course, the match label, Java tips backend, and this is a template which has this label, which is same as this, and the container, it's it's the same thing. Now I'm invoking a service, and this label is Java tips, and this is a sorry metadata. It's just a name. I can give any name, and this selector Java tips backend should be same as this. Now this name, because this is a replica set, so this name should be saved. This label should be same in the port template also, a port template label also, and it should be same in the service selector also. So so let's go through this. So then I will you will see I will just do it right now also. A service replica set and ports are created. So we'll see the desired count. I have given the desired count as 3, replica as 3 here. So we'll be able to see 3 replicas running of of the from the replica set, 3 ports running from the replica set. And now I show the service, and this is a cluster IP of the service, right? And I see the replica set had 3 desired and 3 current, so all are running. So whatever I wanted, those many number of ports, replicas are running. So now what I will do is from the Docker desktop, because I've been using Docker desktop, I will use the curl command, and it's the same, so it will same command which I've been using, so it will give the same response. What I can do is I can check the logs. So one thing which I did not do here, we did not tell here was in this I have not specified anything related to session affinity. So what I wanted to show you was, once you see the logs of 3 ports, and we'll see that it will hit 3 ports randomly, because here I have not specified session affinity, and once I hit these ports, it will I can see the request hitting different ports directly. Just give me just 1 second. Yeah. So you will see this request which we are getting from this request which we are hitting, this is what we will use. It will hit different ports multiple times, because there are 3 replicas, 3 ports from the same replica set. So it will hit any of these 3, and we'll see in the logs. But now so once we check the logs all port 1 by 1, we will observe each call can go to any of the ports behind the service. Now what we do is, but if we want session affinity, calls from one client should always go to same port. So here, so enter session affinity. So here in the service definition, in the under spec, we'll say session affinity client IP, correct? So everything else is same. So once is, and then we'll do the same thing, we'll create the replica set. This is a YAML which I've used, different YAML, and we'll check everything again, and we'll run the same thing again, and we check the logs. It will always go to one port only, correct? So now, and this is a command to check the log, kubectl logs -f, and then give the port name, correct? So let's do one thing. Let's start from here, correct? So this is a YAML replica set with the service. So let's see that YAML first. Before that, let me I was trying something else. Let me delete that resource. Ctl, sorry, ctl. ctl delete, so that this goes away. ctl get for only one port should be there, which we need, correct? So now what I'm going to do is I'm going to delete the replica set, and I'm going to delete this port and the service. ctl get sec kubectl delete port, and this is the port we have. This port got deleted. kubectl delete sec. This is what I want to delete. This get deleted. So now I will let's look into this replica set with service. PLI replica set replica set. Let's see that. Let's replica set with service. So let's see this. That. So you can see this. I have a replica set type and replica 3. This is Java tips backend label. Is the image and the service, which has the same label, which has the same this thing, label selector, and the rest of the things we discuss in the service are same. So what I'm going to do now is I'm going to create -f, sorry, kubectl. Let's see, ctl code all are running. Just give me 1 second. Right, so I created this replica set which has this ports running. I can check the service also. As we see, so service also running, and this is the cluster IP address of this service, correct? So now what I want to do is I want to go here and see. So this we have done, and of course we can check the replica set also. So we had 3 desired count and 3 are current and ready. So this looks good. Now what I'm going to do is going to look at the ports, this port, and see the log kubectl. What was the command for logs? I keep forgetting. Kubectl logs. Yes. kubectl logs. Yes. kubectl. I can say -f so that I can see it running. -f and prod. Control C, Control V, and these are the things running. Same thing I will do here. kubectl logs -f prod, and this is the second log we'll have running. kubectl logs -f prod, and the third we'll have running. Cool. Okay, so let's give some space or something here. Now what I'm going to do is I'm going to issue this command kubectl exec, kubectl and this is any pod I want to log in, just to log into the cluster. So I'm mentioning third pod. Exec this. Sorry. FLT RSZP FLT, then curl -s stabbing. Okay, good. Third pod I've chosen. Let's see what happens. Right button. Or maybe I have not given this thing correctly. So given correctly. Let me copy paste anyway again. kubectl exec -fn curl -s. Okay, good. It takes something. First one I will take. Okay. Oh, sorry, my mistake. I did not give the right cluster IP address. I have to give the right cluster IP, which is this. This is a service cluster IP. So I have to give this. Now we'll see. So it hit this service, right? You can see returning tips. Now let me run it again. Again, it's hitting same thing. Hey, why? Now it hit this. Hit the other one. Now let's see this. Hit another one. Let's see this. Hit again this. Now this hits another one. Again another one. Now it's server 1. So randomly it's picking something, right? So this is without session affinity. Now what we are going to do now is we'll check the same thing with session affinity. So Control C, because I will be deleting the ports and the service and recreating with session affinity, and then we'll see. Cube CTL get replica set. So I'll delete this cube CTL. Delete replica set slash this replica set. Okay, spelling comes down. Now service is also there. Cube CTL get SVC. Cube CTL delete SVC slash. Correct. So it got deleted. Now going back to the presentation, session affinity. So we have covered this. I just want to know the this thing. So this is replica set with session affinity. So let's replica with affinity, correct? So let's see this. What is there? So only thing there is that I have mentioned session affinity colon client IP. Everything else remains same. So now we don't have any pod running. Cube CTL get pod. We don't have any service running, and we do one Kubernetes service filter anyway, and we don't have any replica set running. Right? Good. So let's create this one. Cube CTL -f. Okay. Now let's run the command again. First check replica set is running. Yes. Service is running, and this is the cluster IP. We have to remember that. Let me copy this. Copy this, and we have ports running. So I'll take any random port and run that exe command again. All right, this one, and first let me change the cluster IP because I have copied it already, and take any, let's say, middle one. And before I do that, I have to do the logs also for each of these. So what is this? It's taking that thing. Okay. Temporal logs, and I want to change this with the new pod which got created. This is the first one. Remember, this is the first one. Control V. Correct. And come here. And this will be the second one. Second pod from that on top of this list. And this will be the third pod. What did I do? I copied here only by mistake. This is a third pod. Cool. Now take any random port and give the session affinity. It should always hit that port. All right. Okay, it's hitting this third port. So, but I have taken the second port. So, but it is in this port. Now it will always hit this port. We run it 7-8 times. You can see, right? It's a logging hit here. It is not going to any other port like it was going to other port in the previous run without session affinity. So this is about session affinity. Now moving on, this we have covered. Now, what if you want to expose multiple ports? Why would you want to do that? One reason is you want to have some service available, HTTP and some more HTTPS also. So that's one reason to expose multiple ports from the same service. Now what we'll do is we'll enable HTTPS on the Spring Boot, like whatever applications have, we'll enable HTTPS also. Now, this will be accessible on 8080 and 8443. I think I have already done it. Let me check that out. Let me log into one of these ports. Which port was this? Take any port. I've given this. Let me do port here only. Get ports. There. Let me log into one port. Kubectl. Okay, let me do this. Control rexcc, and instead of doing curl, I am going to, sorry, what did I do? Rexcc, and instead of doing curl, I will go to bash shell of this particular port. Bash. I hope bash is enabled there. Bash. Oh, I forgot to put -it. If you want to interactive mode, then you have to be -it. So I am inside the port now. So let's see if I have this local host colon 8080/tips. That should be there. So, okay, this is there. Okay, I think this one. Now let me see if it is there on 8443. I think I had it enabled 8443, and it should be HTTPS. Okay, because there is a certificate issue. There is a way to disable that certificate. I'm forgetting that. See, SSL self-certificate. I have used self certificate for this, so we'll see. Anyway, I think there's a setting I have explained about. So this, okay, this service I already have it working on two nodes, 8080 and 8443. Now if you have your own service, and let's say Spring Boot service, then you can follow these documentations to set it up on two different ports and enable HTTPS also. So I have given this documentation. I followed this. If you have service not in Spring Boot, in Python or in C# or any other language, or in Java only but without Spring Boot, then you follow the corresponding documentation. Every of this technology has their documentation of how to enable, how to open more than one port, or HTTP port or HTTPS port also. Just follow that documentation. So what I had done was I had followed these instructions, made the code change, did the memory clean install, created the jar and everything, and tested it also. So it was working fine. And what we'll do is we don't need to change the Docker file, but we need to build it. So I have already done it. So if you are using Minikube, then you have to do some infrastructure work. So and forget about that, because now I'm also not using Minikube. Because you have created a new application, you have changed the setup in your application, so you have to create a new image. Now what we'll do is let's go through this YAML. We have this YAML, and which is type service. Now this service, this is just a name, and in the spec I have two ports, HTTP on 80, and 80 will forward it to 8080 service. 8080 of my port service. It is on the service object, this service object, and it will be routing it to 80 on my port. 443 is on this service, it's HTTPS, and it will be routing to 8443. And this is a selector. I have given both ports. So I create a port now. So whatever selector I have given, I give that as a label, and same is a container definition, right? This is the image you should use and everything. So now let's do this. What's the file name? Two ports, same service. All right. Inside this, I have to exit out the port. So let me delete the existing ports now. Control C, Control C, Control C, kubectl, get svc. I'll delete the service first. Kubectl, delete svc slash. It's already there. Then kubectl ports, kubectl delete port slash this. I should have given, like, you could give all the ports in one delete command itself, like this. What is this? Okay, I don't know what this did. Control V. Okay. I have this utility installed which auto complete, so that's causing problem. So let me delete that. Oh, this already deleted. The second one was this one, and third one was this one. So these ports got deleted. I don't have any more ports running now. Hey, a replica set I should delete, because if I don't delete replica set, it will start. My mistake. kubectl get replica set, kubectl delete replica set slash this replica set. My replica set is gone. Ports are also gone. So now cat to container ports. It's the same thing which I showed you. Oh, this is what is this YAML? Sorry, no, not this. I wanted two ports, same service. Two ports, same service. So same thing. Service HTTP/80 routing it to 800, HTTPS 443 routing to 8443. This is the label which I have, and this is the port. It has same label as this, and this is the definition. So let's create this. kubectl create -f. Now let's see. I have not created a replica set now. I've created for end of service. So kubectl get pod. Okay. Okay. Oh, my mistake. I don't have the latest image 9.0 now. Either I can build it or I can change this to the latest only, because I have latest only. So, and latest also has the both ports enabled. So what I'm going to do now is I'm going to delete this pod. kubectl delete pod. This one. And I'm going to delete this service also, and then I'm going to change this. Okay. Because I'll be creating this service again. So kubectl delete scc slash. Okay. Now this was the file. So what I'm going to do now is vim we have the latest. You should use the proper versions. I made the mistake of using latest and I'm carrying over from that, but you should always 1, 2, 3 or whatever version. Each company has their version strategy. Like for mine, for major version, it should have 1 dot something. If you upgrade to if there's a major change, it should become 2 dot something. If it's a small change, then it should become 1.1 or something like this. So follow that versioning strategy. So now what I'm going to do now is I'm going to create this again. Create this again, and let's get the ports. Service is running fine. Let's port. What is this? Let's check this again. Okay, let's check the images first. Docker image ls. These are the images I have. Let's see the image. It has the latest. It did not give the latest one. LATESR. This seems correct. Okay. Now let's see the code again. Maybe it's running fine. kubectl get code. kubectl describe. Describe. I want to see what error it is having. Code slash. Okay. I don't have the same image name is incorrect. I think you are right. Image name is incorrect. Docker image ls. This was the image name. I'll just copy the same image name from here. This hyphen and all the things are mixed. Copy. I go here. Where is my VM? And I give the same image name here. Correct. Save it. Let's see the port. I'll delete this port. controller. Delete the service also. Inside the service, delete the pod also. Okay, I don't have any pod. kubectl get pod, nothing. kubectl get service, nothing. Only one service is there. Now what I do is I create it. It got created. So now I see get pod, kubectl get pod. Now it's running, and I can see kubectl get service. This is the cluster IP of the service, correct? So we are able to create this. Now what we are going to do is, so it opens two ports, HTTP and HTTPS. And oh, you can see this port visible through this also. All right, see here, when I say get service, this service has two ports, 80 and 443. And so selector we already discussed, we did it, so we created this also. Now what we are going to do is I just wanted to skip the I just wanted to see that command where we can skip the cell side. This is the command which is getting, so -k, this is what I was looking for. So -k, if you do, it will skip the certificate verification, right? Because I'm using cell side certificate, so that's why it's causing problem. So what I'm going to do now is same thing. I'm going to use kubectl cube, or let me just do this exec controller exec. What is this? What I'm doing? Exec. So what I'm going to do is not this. This one I wanted. So I'll give this pod which I have running. This is a pod. So control V, and what I want to do, and this is a cluster IP. And it's running on port 80 now. So I can give 80 or I can skip this also. So I got this, right? Even if when a port is 80, you can even skip giving the port name. I think it will work. Yeah. So now what I will do now is I'll give -k and give HTTPS. And now port is 443. This is the line I'm following. The same cluster IP and the port 443 and it's HTTPS. Correct? Let's see. Cool. So it gave me this. So now we are able to see we created one port with two ports and a service which could access these two ports. One was on the service had 80 and 443. 80 was routing to 8080 of the port. 443 was routing to 8443 of the port. In production, in real applications, I have used self-signed certificate here. But in real applications, you will not be using the self-signed certificate. You will be using a real certificates. And because I am using self-signed certificate, so I have to give -k to skip verification of the certificate. So that's about using two ports. This we did. Now we'll cover only this. You can name the ports. So far we have been using the ports as is. You can give certain names to the ports. And why you want to give? Because sometimes remembering the port numbers could be difficult, especially while using non-standard ports. See, 80 and 443 was easy, 8080, 8443 was also easy, but sometimes your applications or your systems might be using some port numbers which are difficult to remember. The port numbers are difficult to remember, but if you give the names are easy to remember. That's one reason. The reason is that you can change the ports in port without changing the service, because in the port you will be giving the port number and the name, and you will be referring that name only in the service. So tomorrow, if you want to change the port, you want to change the port to give different port, because now your service is getting exposed in different port. So you have to change only the port definition. You don't need to change the service definition. So this is what we'll use. So we have this, service definition, some metadata, and this is a name and the port and the target port name. And I think it's the same thing which we have seen. I think it's a, let's see, whatever we saw here also. We have used it already here anyway. But let's see. This is the name HTTP open on port 80, and this target port here. The difference, the target port here, there in the previous definition without naming, we were giving 8080, but here we are giving HTTP. This HTTP is the name of the port, name of the port which have defined in the port definition. This is the name you have given. You could give any name actually. I have given same name, HTTP only, but this could be any name. Whatever that name is, you can define. You should define it here. Same with HTTPS. It's 443, and the target port is HTTPS. And this HTTPS is the one which I have defined here in the port definition, and it is 8443. So 443 will get it to 8443. 80 will get it to 8080. Tomorrow you want to change the port definition to have some different port, you just change it here because you have given these names, and these names are getting referred in the service definition here, and here we don't need to change the service. Okay? So that's how. Let's go through this. We'll create this. I will not run this, but I think I have a file. So let's see Java service name port. I don't remember the file name. So grep named. So port with name port. So these are the two YAMLs. This is the YAML I had, name ports with some same service. That YAML. Okay. Yeah, it's the same thing, right? So I have given. So I mean, as an exercise, you can try this yourself and see it working. And you can change. You can change these names also. Here I have given HTTP. You can change to something else. Change this to something. I'll put this as a homework. So you can do that yourself and see it working. And you can access the application using the curl command and the cluster IP and the curl command which I'm showing you. So that's about it today. I will stop it here. In the next session, we'll cover, okay, this we have done. Port discovering service via environment variables. So this is one thing. Discovering service via DNS. Then connecting to service outside cluster. It needs some infrastructure which I do not have on the laptop. So most of the time we'll, for this outside service, we'll cover, the mostly theory. Yeah, so there are different ways of connecting, and there's a node port and the load balancer are the ingress. Node port, load balancer, ingress control are the main things, which you should be aware of. And we'll discuss about, most of these things in the next session. So that's about it today. Okay, so so a pod, discover. So we'll see how the services appear in the pod, and those appear as an environment variable in the pod. So so how does pod knows about the existing service? So we'll cover that. When service is created first and pods are created after service, then when pod is created, so remember you have created the service and after that you are creating the pod. Kubernetes has an environment variable for each service which exists at that moment. What does mean? If you create a service after the pod, if let's say you created 3 services and then you created a pod, you will have the environment variable for that service, 3 services in the pod, and after pod has been created, you create the 4th service. So this 4th service environment variable will not exist in the pod. So that's how it works. Let's say, so it's the same YAML file which you showed. So what we are going to do is, in that YAML file, you have service and associated pod, and so now then you have another YAML file. So what I will show you is that you create a service and then you create a pod, you will see that service appearing in the pod. And after pod has been created, you create a new service, you will not see that new service appearing in the environment variable inside the pod. So what we'll do is run the random service. Oh, so here I'm running the random service YAML first. This is the some random service YAML I've created, and see the environment variable for pod in the first YAML, right? Now check the environment. So okay, so here I'm showing you the other way. So let's go through this YAML files. Name pod same service YAML. So cat name pod same service YAML. So what I am doing here is I am creating a service. First I'm creating a service, and then I'm creating a pod, and of course this is selector name pod and everything. So this pod will have this service. So let's do that. And no, before that, second file random service.yaml. So let's see that random service.yaml. It has some just random service. It doesn't have any pod associated or no selector or anything. It just is a service which has two ports exposing 80 and 443. So now, so first we'll run the random YAML. So remember, this random YAML has no code associated. So we'll see, if this service environment variable are also appearing in the code which we'll create later. So kubectl create -f. So it got created. So now, so if I say kubectl get svc, I will see this service and cluster IP and ports. Now what I'm going to do is I'm going to create this kubectl create -f. So I created this. Now let's see kubectl get port. So why I am not getting this code? kubectl. Oh, I think I might know. Let's see this name port YAML. Control C, VIM, Control V. If I see, this is the latest. I thought image was a problem. It's the same problem. Hyphen I had here. I have all underscore. So let me get the images. kubectl images. I think no. Sorry, Docker images. My mistake. Docker images. And this image is this. I want to see which one has latest. This one has it has two versions, latest one and latest. I will just to be doubly sure, I will do this. Then I do the VIM and I change the image to this proper name. Control V. Now come out and kubectl get svc. I delete those both services. No, I need to delete only this service because it will get recreated again. kubectl delete svc name port. Then kubectl get port. Then kubectl delete port with name port. Right. So that gets done. Now where is this one? So I create this again. I get the pod again. Now it's running. I get the service again. It should be running. Now we'll follow what I have written here. Now what I will do is inside this pod, Java tips svc name pod, which is this one. Inside this pod, I will run a command and get the environment variables and grep svc. So let's see this kubectl exec kubectl exec. Let me copy this. Control C, Control V. Then env. then grep in caps as we see. All right. What did I exe colon remove? Named ports. Maybe this is what I have to do. Sorry. What is this? exe port with named ports. Java tips. CTL exe. Oh, this is service. My mistake. What I'm doing, I should get the port with named ports. So this one env. So you will see that random service which I have created, environment variable for those are also appearing here. So here idea is to show you that before you create the pod, whatever services are there before that, it will start appearing in the environment variables of the pod. And if you want to access those services inside your pod, you can use those environment variables. Why do you want to access those services inside your pod? For various reasons, like based upon your, the problem which you are trying to solve. But Kubernetes give you these options. You want to get the, the IP address, the port, it's using it's creating some environment variable with certain convention, like the service underscore port. This is the service we created an underscore port, and the port number, that port number and things like this. So you can refer those inside your port. Now you can discover the service. So I will just reiterate what is service so that we are on the same page. So you have something created in the port, and let's say you have some application inside the port which is exposing the REST endpoints. Now you want to access those REST endpoints. So you have a service object created outside. Through service object, you can access those REST endpoints, and we have done some exercises for this already in the last session. You can also, so we were using cluster IP, for time being. So we are having service object, we are having pod object. Through the labels, we were tying service and pod together. And then we were having the cluster IP of the service to access the service, which in turn will invoke the pod's REST endpoint. The cluster IP, you can invoke only from within some pod in the cluster, right? So that's what we have discussed so far. You can discover the service through DNS also. So now, so Kubernetes has a pod running DNS server, core DNS in kubesystem namespace, and we'll see that. So first, let's get all the namespaces kubectl has. So kubectl get namespace. So this is the namespace we have, and if you see cube system, so I have changed this. Earlier I was running Minikube. Now I have reinstalled the Docker desktop. So I am not seeing DNS in the Docker desktop. So here default node list public. Oh, these are the namespaces. My mistake. So there's a namespace called a cube system. So now what I will do is I will try to get the ports inside this cube system. So kubectl get ports and -, namespace equal to cube system. So these are the ports which are running. And if you see, it has the core DNS also running. Actually, it has two core DNS running. Core DNS, these two ports running for core DNS. So now, so services, kubectl has kube DNS service. Check below. So if I see, kubectl get service, and in the same namespace, let's do that also. So you have the ports, and then let's check the service in the kube system namespace. So you have kube DNS service also running. So basically, these are the service and the ports which are for DNS, domain naming server, right? So why this service is needed? Because the DNS port might get restarted for new IP. See, here you have the ports in this namespace, and here you are having the service. And we discussed when we started service that why do you need service? Why can't you invoke the ports API directly? We need service because ports, to invoke the ports APIs, we need the IP address of the port. An IP address of the ports can keep getting changed because port can crash and reappear and things like this. So we don't want to rely upon the IP address of the port. That is why we need service. So same in the concept here. Even for the Kube DNS, you have the ports, but you access those ports through this service. So now, we discussed this service has same IP always. So Kubernetes configures the kubelets to tell individual containers to use DNS service IP to resolve the DNS names. So this is like normal any DNS thing. So only thing is that in here, the kubelet individual containers will be using the DNS to get the to use the service IP to resolve the DNS name. We will see example of that. How does this work, right? Now all ports are configured to use a Kubernetes DNS server port. We can see the resolve conf file of each container, and any DNS query from ports will be handled by this server. Kubernetes DNS server knows all the services running in the cluster, correct? So the whatever DNS server we are talking about, so this is DNS service which is tying to the DNS ports. So they know all the services which are running in the Kubernetes cluster. So so this is the YAML we'll use. So we'll create some service which we already did, and it has some port which we already have. So these are the ports we are getting, and these are service we're getting. Now what we'll do is we'll go inside inside this port. So let's just follow I will just follow the PPT here. We'll see how this resolution to the service via DNS works. So what I will do is kubectl exec -it. Then okay, I have to get the ports. Kubectl get ports first. So now kubectl exec -it -dash. So we are inside this port now. Now we'll install BusyBox. While we install BusyBox, we'll come to that later. You will see why we're installing apt-get update apt install BusyBox. Install BusyBox. Okay, installed. Now we'll see the resolve. We'll see here in this slide we say all ports are configured to use DNS server. Resolve.conf file for each container is modified. So here we are seeing what is that resolve.conf. So let's see that cat etc resolve.conf. See here you have this some name server is this, some search, some default SVC cluster, local cluster, cluster.local, and things like this, right? So you have already defined things here. So here, these are the two things we'll focus on. So what we are going to do is so what is a fully qualified name of the service? See here, whatever service we have, we will put default.svc. Cluster.local after that. So let's see the services which we have. Check that here. kubectl will get svc. Okay, so we'll use this. We can use random also. So I will use random in that example. So I will use the same thing here. So what we are going to do is we are going to say BusyBox. BusyBox in help is in NS lookup, and then this. Then after that, default SVC cluster local, which was default SVC cluster local. So I will do this, correct, and I think that is it. So it's it's pointing to this server. This okay. Let's see what is here. So it's the same, some server, some address, and name and address. Now what we are going to do is here, if you see the cluster IP, this address of this service, it should be same as a cluster IP in the kubectl get service, and we'll see that. So you see 124, which is appearing as the cluster IP of this of this service outside also. So idea is that, the inside the pod, when some application inside the pod is trying to use some service, the Kubernetes DNS server lookup will get triggered, and that service will get invoked. The IP address of that service get resolved that way. Now, since we are here, let's try to look for the other service also. We have this name port, right? Let's try to see if that also get resolved to this IP address or not. I did not try this earlier. I'm trying this here for the first time, but let's see. Control C. So 10.99.135.19, 10.99.135.19. So the DNS server lookup has resolved to the same IP address as here. Now, so what we have done so far is we have created a service object which is connecting to the endpoint which container inside our ports for exposing, correct? But Kubernetes does give you an extra ability to create a service object to connect to the endpoints which are not in Kubernetes cluster, which are outside Kubernetes cluster. So, so which means the service will not be pointing to pod, but to the external IP outside the cluster. So external service can take advantage of below Kubernetes service object features. Now, why would you want to do this? Because you already have a service outside. You have already a REST endpoint outside the Kubernetes cluster. So you could very well invoke it. Why do you want to create a service object inside the Kubernetes and let the request go via the service object and invoke the, invoke the external service from there? Because you might want to Kubernetes, service does provide this load balancing and service discovery features, and we saw service discovery features like, you have this, NS lookup happening, and then you have this environment variables and all those things, and it does provide load balancing features also. So you want to utilize that, then you can create a service object inside Kubernetes pointing to the endpoint outside. Now, one thing you have to remember is services do not talk to pods directly. So once you create a service, internally an endpoint resource gets created, and service points to that endpoint resource, and that endpoint resource points to the pod. So if you want to see the endpoint resource, you can see this. So let's see the endpoint resource of the service. So we have this service. So I will copy this command. Sorry, I can't copy. So kubectl get endpoints plural, yes, points, and then the service name, this one. So this is the endpoint. This so this is the endpoint, and this is the endpoint. These are endpoints which were created. So service connect to these endpoints. These endpoints connect to the REST API of our application. And so I'm trying to represent this diagrammatically also. So you have a service which connects to endpoint. All IP of matching ports are in this endpoint resource. See here, I have created only one port, for example, kubectl get port. So there is one port, but if we have multiple ports, which are matching, the service label. Let's say you created a replica set, which are 3 ports, and that the labels of those ports match to the service object. Then you will have many ports behind this endpoint resource, because this endpoint resource we did not create. Service automatically created that. So this endpoint resource will be catering to all the services. So all IP of matching ports are in the endpoint resource. Service call gets redirected to any one of these endpoints, right? There is no deterministic. Any of these ports it can get directed to. So I have not explored it further because I was trying to search for some external service or something, but I will just walk you through theoretically so that if you want to try yourself, you can try. Service endpoints can be updated independently. So you can create the service endpoint, and you can update that independently. Service can be created without the port selector. So endpoint resource one. So if you don't have the port selector, So like we have the YAML where we are going to select the label. Port selector is nothing but a label. So your service and your port, and port has a label which service is referring to. So that service will refer to that port. But if you do not have like random service will create it, there is no port selector. So in that case, endpoint for that particular a resource cannot get created, and we can check this out actually. So let's see this endpoint name port, and we have this random service also. Let's see if the endpoint gets created for this or not. There is no endpoint. Why there is no endpoint for this random service? Because if you remember the random service, it is just a service without having any pod or without having any port selector, correct? So and I think I showed you that here, somewhere here, the where did that go? The YAML file for the service. These are random service, and it has only the service. There is no pod here, so that's why there is no endpoint for this. But the other one, named pod, it has the service as well as the pod. So that's why the endpoint for this service got created, but for this service we didn't have the pod. Endpoint did not get created. Okay, so so create service and endpoint separately, so which you can do that. So external service and HTTP and HTTP service. So there's some extra work which you need. So you can create a service, you can create the endpoint separately. Then if you have HTTP and HTTP's external service to connect, there's some extra setup, and you can you can go through the setup. I was planning to go through the setup, and I didn't have time to do this. So if you create ports with the labels, same as a random service, it will start showing as an endpoint, yes, but you try this out as a homework. We'll discuss that in the next point. And I think we discussed in one of the previous session also. So there's an extra work to have this service endpoint connect to the external HTTP endpoint, which I did not do, but the documentation of that work is here. So maybe in future, if I get time, I will do it. But if you want to do it yourself, you can refer this documentation and have it working. Now, if you have an external service outside Kubernetes cluster, and you don't want to remember the IP address or something, you want to create an LES. So very well, you can do that. So instead of service endpoints, we can create an external service by a fully qualified domain name also, right? Ports can connect to service using external service.default, whatever, right? So this is how you create. You have the service object, and then in the spec, you say type is external name. And there you give the external name, like some domain, there's a real domain, like I should be able to connect to this on this port. So now what you do is it hides the actual service and location from this. Now I'm just trying to see. So you have this service, name is external service, spec is type is external name, type is external name, and external name is this, and port is this. So it hides the actual service name and location from consuming port, implemented at DNS level. A simple CNAME DNS record is created for this service. Hence, clients connecting will bypass the service proxy. Yes, a CNAME record points to a fully qualified domain name instead of a numeric IP address. So this is how you can connect to the fully qualified name of the of the actual service. Now, so we have discussed so far. You create a port, you create a service, service has client IP address. You can use client IP from within any pod in the cluster. Client IP cannot be used outside the cluster. The service service information is available via environment variables. You can create a service to connect to external client also. What we have not discussed so far is whatever service we are creating in Kubernetes cluster, within Kubernetes cluster, how to access that service from outside the cluster. Client IP you can access from within the cluster, but I want to access outside the cluster, Kubernetes cluster. So there are three ways. One is a node port, second is load balancer, and third is ingress. So this is your Kubernetes cluster, this is service, and these are the ports. So external IP is connecting to service, and then service internally will route the request to one of these ports, right? So now how to have that happen? So what are these three? Node port, load balancer, and ingress resource. So what node port does is each node on the cluster opens a port on the node itself. So I will read it again. Each node on the cluster opens a port on the node itself. It's not container, it's not pod, it's a node on the cluster. Like cluster consists of some worker nodes, right? So those nodes, and it redirects traffic received on that port to the underlying service. So basically, the external service will be using that port on the node, and once the node receives that request from that port, it will redirect to service, and then service will redirect to some container on some port. So that's how node port works, and we'll see example of that. Load balancer. So it's extension or node port type. Make service accessible via dedicated load balancer. So load balancer redirects traffic to node ports. So, and we'll see example of that. So load balancer redirects traffic to node ports across all nodes. Client connects to service via load balancer IP. So client, so in above node port, client was connecting to port on the node in the load balance, and then that port on the node will directing to send routing the request to service, and the service will route to the some container. In the load balancer, client will know only the client will know the IP address of the load balancer. Client did not know the node port IP. They will know the IP address of the load balancer, and they will invoke the load balancer. Node balancer internally will invoke the node port, and node port then will route to the service, and service will go to the some container on some port. Ingress resource, it exposes multiple services through single IP address. And we'll see the difference between ingress resource and load balancer, but this is one of the important difference. First one, it exposes multiple services through single IP address. Here you have to have one service on one load balancer, and ingress resource reports at the HTTP level. Now trying to represent this in the diagram. So let's say you have this Kubernetes cluster, this boundary, and you have node 1 and you have node 2. There is a port 32333 on both of these node open, and then you have inside this node you have multiple ports. Here also you can have one or more ports, and this is service object which got created. Correct. Now what external client will do is it will connect to the the node port 3233 address on any of this node or this node, right? And what these nodes will do is when request is received at 3233, this is a node port, correct? This is a node port for this node, this node port for this node. They will route it to the service object. Then service object will route it to the pod or something like 8080 on pod 1 or something. So that's how it works. Now the port range for node port is 30,000 to 32,767. If you give any other port, you will get this error. So I try to give when I was trying, I give some 33333. So it says not in the valid range. It should be in this valid range. So forward incoming connection to that port, which are part of this service. So this I already explained. So we'll try to do that. So I have this port node port service. Let's see that. So let me come out of it. Cat. What is the name? Port node port service YAML. So what I'm trying to do is trying to create a port, and the label is node port service. This is the same container. So I create this port. Then I will create a node. I could have I have service which is of type node port. So I will create this service also, and so if you see the it's a name port selector node port service here I'm using, and going back previously, and the label here node port service I'm using. So this is one YAML. So let me do one thing. Let me get this. Let's see kubectl get port. I'll delete those ports and service. Kubectl delete port, so that I have only the ports which I need for that particular topic which I am discussing. Control C, Control V. Kubectl get svc. Kubectl delete svc. Sorry. Okay, so I might not have custom svc created and no code also. So now what I'm going to do is, so this is one, and I just want to know there's a port node port service. This is what I created, and there's a node port service. So I just want to know the XML for this. So grep grep-ir, and I want test-node port where I would have specified node NODPO. Okay, my mistake. So this is node port service symbol. Okay, cat. So this is a service which has same level as this. Let me do this here also. So if you see, it has node service here as label, and this has selector as node service, and this is a type service which has this is a service object which of type node port, right? So now let's create that, and what I will do is I will create the sorry, why I have 2 times cat. So I will create this node port service first. kubectl create SNF node port service. So one service got created. Now I want to create the what is that? Where is a pod? Where is the pod? Sorry, pod got created. So now I want to create this service. This one. kubectl create -f. So now I got the pod and the service. So kubectl get pod get created, service got created, correct? Now if you see, I have given this 32333 in the service. So somewhere I have given this node port. So the service of type node port, then the node port is 32333, correct? So this you are seeing in the service that it is 32333, correct? Now, so 323 is a port on the node. The service will be accessible through port 3013 or whatever. So actually 3233 of your cluster nodes. 80 port of the service, and this you know, right? 80 is the port of the service internal IP, and just refer to this example, right? So it goes to 32333, then service is exposed on port 80. It will get to port 80. Then my container service is exposed on 8080. So it from 323 of the node to 80 of service to 80 of the 8080 of the container. That's how it works, correct? And so this is what I have done. So now what I will do is I will try to so I have this kubectl get ports, kubectl get service. Now what I'm going to do is I will try to, I have not tried this, so I'm trying this for the first time. Let's see if this works. So because I am the node, so local host, sorry, local host colon 32333/tips. So it works. So because my the node, the laptop is a node, and on that node I have exposed 32333. So I have an access on localhost 323/tips. I will just reiterate for the 4th or 5th time. It goes to 3233 of the port, then that gets rerouted to the service 80 port. Then service will redirect, route it to the 8080 of the service, and that 8080 of my service is returning this response. So that's how it works, correct? So this is the last topic which requires spend 2-3 more minutes, and then we'll cover, this will complete the service itself. So now service exposing to the external client using load balancer. So what we discuss is a node port. Now we're discussing the load balancer. So Kubernetes running on clouds usually support auto provision of the load balancer. A load balancer is outside the Kubernetes cluster. Load balancer will have its own public IP address. Load balancer will redirect all connections to your service. Will create a node port on each node. So this is how the flow works. Your external client, this is a load balancer of any cloud, like on AWS or Azure, on Google Cloud. So some load balancer will be there. So client will always talk to the load balancer. What this load balancer will do is it will send a request to the node's port, like the node, like node port. Now this node port will send to the service, and this service is sent to the individual pods, right? So that's how it works. I do not have any, because I do not have any personal account in any of the AWS or Azure or Google. So I will not show the demo for this, but you can read this article. If you have any you have an account on cloud, less on Google Cloud, you can follow this article and do this. But if you had to, the YAML of this look like this, you have again kind of service. In the previous, we had type as not pod. Here we are defining the type as load balancer. Pods 8080 target. I think this is the standard service convention. So if you follow this and you have an account on any cloud, you can try that yourself. So, but remember, the node port and load balancer, these are the two things we covered. So the last one is ingress resource, and this is most important. Now each load balancer service needs its own one IP address, correct? So ingress needs only one IP while providing many services. So this is interesting because each service so far what we have discussed is, whether it's cluster IP or whether it is, other options, each service is supposed to have their own IP address. But ingress resource, they're saying no, ingress resource will have only one IP address, but it can serve many services. Now how? So let's see that that I mentioned here. So ingress needs only one IP while providing many services. Host and path determines which service needs to be invoked. For example, /tips, /user info, /top 10. Each of these service can, this is a context. So this service will be for this path, this service will be for this path, this service will be this path. That's how it works. And this service connected to this port, this service connected to these other ports, and so on. So it operates at the application layer of HTTP network. It provides features like cookie, which other options of the services can't provide, right? If you want to try this out, ingress resource, you have to enable the ingress controller. By default, it is not enabled. So if you are using Docker desktop, you follow this link and you can enable the ingress controller there. There is little more setup which we need to do, which I have not done that. There's some certificate issue I'm running into. So it's taking time I don't have that much time to, figure that out. But if I get to work, then I will, explain you again. So, but let's go through this. So ingress controller needs to run in the cluster, and ingress controller needs to be enabled for ingress to work. So by default, it is disabled. So because I have Docker desktops, I follow this instruction. If you have Minikube, then follow the instructions which I have given in this PPT. Ingress controller needs to run in the cluster. We discussed that. It needs to be enabled. Now, different Kubernetes environment provide different ingress controller implementation. Google Cloud provide HTTP load balancing feature of this. AWS use application load balancer, and you can see the example of this. A Kubernetes ingress, AWS ELB ingress controller. Minikube add-on. You can use Nginx as ingress controller for Docker desktop, and this is the instructions you can follow. Right. So, so this sort of covers, the accessing the services outside the from outside the cluster. So, what are the things we discussed? Node port, load balancer, and ingress controller. Node port directly connects to the port on the node, then goes to service and the port. Ingress controller, load balancer, client connects to load balancer, internally it connects to node port and the service, and then the ports. The ingress controller, basically, yeah. So ingress controller looks like, API gateway. Absolutely, yes. So, so ingress controller, you have to enable it, make it work. You can have, ingress controller enabled on your cloud with their own implementation of application load balancer type of things, or you can have Nginx also as, as your ingress controller. I have not done it. I have not done that setup. It was a huge setup, so I have not done it. But these are the options. Generally, in your company, there will be a Kubernetes admin. They will be setting this up. So as an application developer, you will be just using it. So, but at least, this is how it works internally. What we'll do is, what we'll do now is, where did that go? We'll, finish the, the last topic, which is readiness probe. What is readiness probe? So pod may not be available to access requests while starting. So pod might be ready, but still loading configs and etc. So readiness probe checks whether pod is ready to accept the connections or not. So how container returns success to the readiness probe is developer's responsibility, right? We have discussed the liveness probe. Liveness probe tells whether your service is live or not. Now we're discussing the live readiness probe, whether, let's say, pod is getting started. Once pod is getting started, you don't want to send the request to the pod till the pod, and it takes some time to start up, right? Pod might not be ready yet. It's starting, it's loading some configuration, connecting to database and things like this is doing. So it's not ready. So till it is ready, you don't want to send the request to the pod. So how do you check whether it is ready? For that, you use the readiness probe. Readiness probe. So how container returns success to readiness probe is developer's responsibility. We'll discuss that. So what are the type of readiness probe? Like in liveness probe, these are types of readiness probe. You can have EXEC, like process is executed. Process exit status code determines the status of the pod, whether it is still getting ready or it is ready. You can have an HTTP GET on your pod, some HTTP GET, which will tell if it is 200, that means your pod is ready. Otherwise, your pod is not yet ready. Or you can have TCP socket probe also. So since it is very similar to liveness probe, please refer liveness sections for how to run. So I have not given I have given example of HTTP GET in the liveness probe. If you go and look back the recording, you will see how to get this HTTP GET to work. But instead of giving that as a liveness, you give this a readiness, and Kubernetes is invoke that to check if pod is ready. Let's say I have used the HTTP GET in your application. If you're using HTTP GET, and Kubernetes will invoke it as a and define that in the readiness probe. So Kubernetes will invoke that. If it is not returning anything or timing out or returning some other response, it will consider your pod is not ready. But if it's returning 200, it will consider pod is ready. So what is the difference between readiness probe and the liveness probe? So if the probe fails in the readiness probe, no request is sent to this pod. Pod is not killed. A pod will be removed from the service till the time pod becomes healthy. Once the pod is healthy, it will get added to the service again. Okay? So it is just to tell that sometimes pod is starting up, or pod is started up, but some other errors have some temporary error has happened in your pod, and it's not ready to accept connections. Maybe it has already, any REST endpoint you expose, there's a number of limit of connection you can accept. One possibility that those connections get exhausted, so it's not ready. So at that time also it will be taken out of service. But once the connections are available in the pod again, it will get added back to the service again. In the liveness probes, if the liveness probe fails, then pod will be killed, and Kubernetes will start a new pod for that. And that's the difference between readiness probe and the liveness probe. You can see more of both services on this link. So I think that's about it. Hello everyone. Today we are going to discuss Kubernetes config map and secrets objects. So we'll discuss what are these objects, what are they used for, what problem they solve, and how do we use these objects in Kubernetes. So we have our applications, whatever application we develop. Most of the application we need to pass some configurations. What are those configurations? For example, you want to pass database URL because it will be different in dev and in queue and production, or user ID or password or some certificates or things like this. So there will always be need, most of the time there will need to pass such configurations to the applications because you don't want to hard code these things in your code. And as I already explained, some of these configurations will be varying based on the environment, dev environment, QA environment, and production environment. Now, how do you pass these configurations to the applications? One way is you can pass it as an environment variable, and your application can read that environment variable. So in dev, production, QA, etc., the value of this environment variables will be different, and accordingly the application will work. Other options is you can hard code, but it has own problem. Something changes, then you have to change the code, rebuild the code, redeploy the code, and things like this. The third option is you can have a configuration file. For example, in Java, you can have a properties file, and you can change the properties file. But then properties file is also part of your code or deployment. So if you want to change the properties file, you have to change the properties file first, redeploy the code, rebuild the code, redeploy the code. So you have to go through the whole cycle. But these are the few of the options wherein which we can use to pass the configuration. We discuss about Git repo volume. You can have the configuration in Git repo, attach it as a volume, and your application can read from there. But Kubernetes provides you a one object or one way to store this configuration. So store this configuration in a Kubernetes resource, and that resource which saves the configuration is called config map. Now there are certain configurations which are secrets. For example, the passwords, encryption keys, the private keys, for example. So you can save, Kubernetes provides you a resource called secrets. You can store such informations inside the secrets resources, secrets Kubernetes resources. Now, stepping back a little bit, how do you pass arguments to the application? Let's say you have a Maven Spring Boot application. So we'll work, under that assumption. So one way is you can pass using, command line. Second is you can pass, or maybe it's a normal Java, application also. So you can pass using command line, environment variable, config files. You can mount external files, or if you say Dockerized, if you're building a Docker image out of it, then you have a Docker entry and command. We'll discuss about this as well. So these are some ways to pass configuration to the app. Now, what is Docker entry point? So you would have seen in the Docker intro also. This entry point is it defines the executable files to be executed during container starting. So when container is starting, this is shell script or whatever. It's Windows, possibly it could be exe also, but mostly for Linux it could be shell script. So that needs to be executed while container is starting. Now the CMD option in the Docker file is it indicates the arguments to be passed to the entry point, because this entry point might need to take some arguments. So you can pass that argument in the CMD, and you can define the default arguments here. Once you use a Docker run and pass the image name, it will use the default arguments which you have passed in the CMD. But if you use Docker run image and pass the arguments, then it will override the arguments which you have passed in the CMD option in the Docker file. This is just a refresher of your Docker file entry point and CMD. Now, Kubernetes can override the Docker command. So Docker Docker has entry point. In Kubernetes, equivalent is command. Docker has CMD, equivalent in Kubernetes ARGS, and we'll see example of that. So let's take this, application. This application is hosted here, and it has some controller. In this controller, it's a Spring Boot application, and this is the the DB URL, and we want to. This is a configuration which you want to take, and once you invoke this method, /tips, it will pass tips, and it passes the value of this DB URL. If you do not set any value, then the default value will be default host. So we will see how to set this value of DB URL using the configuration. So this is a sample example which we'll be using without Kubernetes. So if you run this application mbn spring boot :run, and so -d spring boot run arguments and pass this arguments DB URL, whatever. And what is this DB URL? This is the DB-URL which you have given name here. The same name should appear here, DB_URL, and you can pass this. Once you run with this parameter, and this is without Kubernetes, as I said, and you get this wget Spring Boot application is started, and use wget to get the tips, and you can see it's passing this the DB URL is MySQL or something. So tips MySQL. It's not giving the default host anymore. It's giving the host which we have passed from here. Correct? Don't go by the syntax of JSON or something. The idea was to showcase how do you pass the arguments to Spring Boot application outside Kubernetes. And we'll run this example. Now in Kubernetes, we'll do the similar thing, but with Kubernetes. So this is a file, and it has a pod. It has just some metadata, and label has I'm assigning some purpose also to this. Resources, I'm limiting to 1 CPU, whatever. This is what I want to focus on. This is a command which I want to run, correct? And while running this command, I want to pass these arguments. So these arguments are similar to what I passed outside Kubernetes. So when Kubernetes runs, I want to pass these arguments also. And once it runs Kubernetes, we'll go to the Kubernetes, and from inside container, we'll say wget we'll try to get this we'll try to invoke the same URL in the controller. It should be /tips, and we'll see the output. Correct? If you don't want to go from inside the container, you want to expose from outside the container, you can use port forwarding, and we have done this port forwarding in the previous videos, so you can follow that. Once this port forwarding is 8888 on local, will be forwarded to 8080 on this particular port. So, and then you say localhost :888/tips, it will return you the same result which we are getting from inside by using this command from inside the container. So let's just run this. Let's just run this example, and we'll see. We'll start from here. So this is the application tips controller, and it's inside this path. Tips, whatever code tips. So like go inside, I will go inside this. So I will say this is where the project is, and I will run the same arguments. So if I do this, sorry, let me exit this mode, and let me run this. So let's see what happens. Okay, allow. Done. So this is outside Kubernetes. I'm reiterating that again, and I will just run this command which I've given here, and let's see what it does. Okay, I can't copy this because an image wget localhost 8080. So let's do that here. Let me go to some temp directory. emp wget localhost /tips. So it returns some tips file to me. So let's see what is there in the tips file. And it is returning this MySQL, whatever this app which I passed as a parameter while running the Spring Boot application, right? So the setting is down. This is the parameter which I passed, and this is what is appearing here, correct? And how it's appearing here, because when I return in /tips, I say tips : DB URL, which is this URL, and I'm passing this as a parameter from as a configuration. The configuration, if it If it would not have taken that configuration, it would have passed a default URL to me. But it had taken the configuration, so it's passing the DB URL, which is passed to it. And then, of course, the first tick or whatever. Okay? Now, moving on. Let me put in slideshow again. And now, what we'll do is we'll run this command create ports args. Right. So, clear this out. kubectl. Let's see how many ports we are running now. kubectl get ports. No ports, good. kubectl create -f and then create ports args. Create ports args. It created. Let's see what is there inside this. Right, by the way, cat. It's the same thing, right? I'm running this this image, right, and then passing this command, and well, here in the command itself, I'm passing everything. Honestly, here I split it into commands in args. So here I'm passing everything in the commands. Let's see how this works. So whether I'm able to get this or not. Let's see. Yes, it will get ports. So you will go inside this port. I don't want to do port forwarding or anything. exec -it java docker ch -f bash. Correct. So now I say wget. I don't know wget works here or not. Let's say curl localhost :8080/tips. So it gives me the same thing which I have passed. So whether you use whether you use this commands and arguments separately, or you use this one file which has everything in the command, both will yield the same result. So I tried this. Maybe as a homework, you can try this as well. Now moving on from here, this is what we did. Kubernetes lets you specify environment variables also for each container in the pod. Defining environment variables at the pod level to be inherited by the containers. Is it possible? What I'm trying to say here is that, is it possible to define some environment variable at the pod level which any container inside that pod inherit? So it's not possible. So environment variables cannot be updated after pod is created. So now what we'll do is let's go through this. So you have this YAML file. It's kind of pod. It uses the same image, and these are the environment variables which I'm passing. And so we will create this YAML. We'll get the pods. We'll get the logs. We'll see what is in the logs, and we'll go inside the pod. We will not use pod forwarding. We'll just go inside the pod and use the curl command to get the thing, and we'll see whatever we have passed as an environment variable, does it get picked by the Spring Boot application and passed into this variable. So that's what we'll validate. Okay. So let's start. This we have done. So let's kill whatever pod we have already. So let me exit out of this and kubectl get pods. Oh, what is this? kubectl get pod. So I'll delete this kubectl kubectl delete pod. So I delete this pod. Now I should not be having any pod running, and I will use this create pods -env YAML file to create new pod. Let's see that file first. Cat k8 -pod, then -pods -e. So this is the same thing, right? Pod. Then this is the environment I'm setting. This is the environment variable name, and this is the environmental value, and that's what things are same. Liveliness and everything we have discussed in the past. So what I'm going to do now is I'm going to create this. Sorry. kubectl create -f. Now let's see how many pods we have. This pod is running. So let's go inside this pool, inside this pod. CTL-EX. Okay, so we are inside this code, and let's see what's the value. I never checked this, by the way, but I am checking this now. Kubernetes is okay, host name, whatever language, Kubernetes for DB URL. This is the environment variable we have set here in this environment, and that's what is appearing here. But now let's see this environment. If you set an environment variable, this key and value, Spring Boot will automatically pick that up. But let's validate that. Curl URL wget localhost /. And you can see this value is appearing. It gets injected by the Spring Boot application automatically. Right? I don't know why it's terminated, but let's see this kubectl get code still running. So kubectl, and let's follow this. So we'll see get codes. Let's see logs. Logs anyway will tell you, what are the logs created while starting this pod. Java Docker sh. We can see running logs also, and let's see. Can I give pod and see the logs? So it shows the logs which pod created. Container inside the pod created while running. So now we have seen how do we pass this environment variable using Kubernetes to a Spring Boot application. Spring Boot application by default has, if you set this property in the Spring Boot application like this, if the environment variable, if there's any environment variable with this name, Spring Boot will automatically pick that up. So all we did was using Kubernetes, we set up one environment variable whose name is this and value is what we wanted to set. Right? So Spring Boot picked that up. And we validated using curl command that we are getting this value which we had set. Okay. Now we did all of that, but if you see pod YAML is also like a code, right? Because you will be running this same YAML again and again, right? So if the environment variable or value you want to change, you have to change the YAML, which is fine. You can change that, but this is also a code. This also needs to be changed, and the general preference is you want to keep the configuration outside the code. That's where config map comes in. It's a separate object in Kubernetes for the configurations. All it is a map. You can see the name itself, a config map. It's a map containing some key value pair. Now the application which will develop, it need not know that where a config map even exists or not. It did not know that, and I will show you how. It just need to work with the configuration like it was, it would work without Kubernetes in place. Now this second line tells you how this gets achieved. So config map data is passed to the containers as either of the below. You can create the config map, put some key value pair, and then arrange to have those key values either available as an environment variable. Once it's available as an environment variable, we saw just now that Spring Boot will automatically pick that up, and similar should be the case with other frameworks also. Or you can pass this config maps as a files in a volume. If your application is picking the configuration file from a file, then you can do the config, create a config map, make the key value pair of config map available in a file on a volume. Or you can pass this as a config map value as a command line arguments as also. Application can read config map from the see any object you create in Kubernetes, you can always read that object information from REST endpoint as well. Same is the case with config map. You can always have your application invoke the Kubernetes REST endpoint and read and pass this config map name and read the values. But then again, you are tying your application to Kubernetes. What if tomorrow you don't want to run it on Kubernetes, you want to run outside Kubernetes? So it won't work because you had made a tight coupling already. So we should avoid such tight couplings, right? So app accesses configurations by name, hence can use it to keep settings for different environment variables. So it's obvious, like any other application development, you always like db_URL, and that's the name. Whether this application runs in dev environment, QA environment, or in production environment, your application is always concerned, will always get the, will refer to DB underscore URL name. The value of it will be set differently in each environment, either using environment variable or just picking up from files or whatever, correct? So the how do you create config map? You can create config map using command line. Using kubectl, I have given an example. Oh, I forgot to put something after F. So you can create any YAML also. You can create using just create a config map. So if you use kubectl create config map, this is the command you can use. Kubectl create config map, env config. Now it's env config is your configuration name, and you are taking this configuration from literal, which means the value of this the key value will be passed in the command line itself. So this is one value in this config map. So config map has a name, and this is a name, and this map, consider this a map name. This map is going to supposed to a key value pair, and these key value pairs are coming from this command line only. That's what from literal means. And what is the first key? JDBC URL. What is the first value? This is the value of this URL. So this map is going to contain this key, and this key is going to have this value. It can have many other from literals also. Like here, I am giving another example. You can have two key value pair in this environment configs. One is one is this key is this, value is this. For second, key is this, and value is this. And there are certain conventions. The names, these names should be lower cases, hyphen, dot, and it should start with alphanumeric. So let's see. We'll create some config and we'll inspect that config also. So let's remove it from this. Let me create one config map. I will use this. I will just copy paste this. I will go here. Create config map. It got created. Let me create another one also. It was environment config, and this is environment configs plural. So let me do this as well. Now what we're going to do is we're going to inspect this one by one. Kubectl get config map. Let's see the first one. This is a YAML. We are telling you the YAML. If you have to create YAML, using, I was showing you this option, right? Create -f. You can create a YAML like this, and then it's kind config map at version 1 and give this information. Data inside this config map will be this value. You can skip that if you want. These are only 3 things you can put in the YAML. It will get created for you. So you can see in the first, we have passed in the literal key and value, and same key and values appearing here in the YAML with data and everything. Right? Now let's see the other config map with plural environment configs. Here we have set 2 config, 2 key value pairs. So same thing here. Data is first key, first value, second key, second value, type config map. So this is how it gets created. From the how config map creates it in the using the command line. Now config map consumption. So how does applications, or how do applications consume the config map, right? So you have created this config map with some key value pairs, which is appearing here. Now you want applications to consume it. You can set as an environment variable, or you can set it as a volume. Applications can read some key value keys from the environment variable. It can also read some certain other keys values from the volume as well. Here we'll see another example. So here what we are going to do is we are creating another variable here, and we are passing another system URL. It's another variable, and then we'll change the tips. Let me see if I already have it here. Another system URL where I'm using this Control F, Control V. Okay, I'm using tips all. Okay, let me do one thing. I will need to create the image and everything. So what I will do is I will call tips all, and we'll see the value of DB URL and another image URL, whether it is getting passed, correct? So it's a little different from what I'm showing here. So what I'm going to do now is I'm going to create this config map, and I'm going to show this config map. Then This is the config map which I'll create, which will have, and then this config specs will be created. Config map from, there's a YAML also, by the way, so I will see that YAML from the command line. And okay, so this is how it will look like. It's a type pod. We'll create the pod which will have this image, and these are the environment variables. These are environment variables. This is a name. The value of this is coming from config map reference key. Now, what is the name of the config map? This is the app-config. You see that name here. That name is, this is the name of the map. From this map, what is the value which we are putting into the environment variable? Correct. This environment variable name is dbu_url. The value is coming from config map. The name of the config map is app_config. The inside this config map, there are key value pairs. We want to get the value of this key, dev-jdbc-url, which we have created here, dev-jdbc-url, and that's the value which will come from. And we'll see, let's see, we'll see whether this value gets populated or not. So, okay, so let's run this, and we'll go to the other example after this. Okay, now we are here. So, kubectl, we are getting config map, and I just want to make sure the app, the name is app-config here, app-config, and dev-jdbc-url. It should be dev-jdbc-url. I give underscore here, so here, but in this slide I have given -jdbc_url. So I will change this to -jdbc_url and then create this. Let's see what happens. Here, clear this out. Okay. What we said is we'll use hyphen and not underscores. So let's use hyphen, dev-jdbc-url. Let's see. Config map created, app-config map got created. Now, so this is a file. Kf config map env from, let's see what is there. Cat kat config map env from, and this is command line, right? Command line. Let's see what is here. So it's looking for this app config, which is this. It's looking for this dev-jdbc_url, which is this dev-jdbc_url. So we'll see this pod should have the, and then we'll see this pod created should have this environment variable created, whose value is coming from config map, from this config map with this key name, and it should populate into the Spring Boot application. So we'll see that getting populated. I'll repeat that cycle, repeat this flow again after I show you that it's working. So let's see if we have any pod running, get pod. We have pod running, so let's delete it. kubectl delete pod. So we deleted that pod. Now, what we are going to do is we are going to create this pod. kubectl create -f. So my mistake. This one, YAML pod got created. Let's see kubectl get pod. Pod is running. kubectl exe. Let's go inside this pod. Curl localhost :8080. We have set only one DB only, so I'll invoke only tips, and this value gets populated. So let me explain again what happened. First, we created a config map using this. Now, what is involved in creating this config map? This config map involves two things. One's a map name, which will have key value pairs. So this is the map name. And these key value pairs are coming from literal, which is command line only. This is the first key, and this is the value of this key. Correct, value of this key. This is the second key. This is the second key, and this is the value of this key. Right? That's how it's this how we are able to create, and you see this. Okay, now we created a config map with the name and the key value pair. Now we create a pod. Inside pod, we are saying we want to create an environment variable. The environment variable name will be db underscore URL, and it's the same name which you are seeing here, db underscore URL, so that Spring Boot can inject that environment variable automatically into this variable. So this is db URL. Now, where is the value of this environment variable will come from? The value of this environment variable will come from a config map, and that config map name is the app config, which is this. And in that app config, there is a key called dev-jdbc underscore URL, which is this. The value of this key in this config map will be the value of this environment variable. Right? The environment variable name is this. The value of this will be this value, value of this key in this config map. And then Spring Boot will automatically inject this, and the value of this key in this config map is this JDBC, whatever another test 306, and it will become as an environment variable value of db underscore URL. db underscore URL is Spring Boot in the, it's defined as here. So Spring Boot will automatically take it from the environment variable and set the value of this variable as this. Correct? So that's how it works. Hope it is clear. Now let's go back to our documentation. So now I'll create another. Okay, let's see. I create config map with 2, and I have said config map environment variable from command line. So this we have done. Now here I'm creating 2 key value pairs, but I'm defining only one in this YAML file. Maybe as a homework for you, you can define another system URL also in the environment variable, which will get injected into this another system URL, right? Another system URL. Make sure in the YAML file, the name of the variable of the environment variable is this another system URL. Like I had the name of environment variable, sorry, here in this environment variable. So you can have multiple environment variables. So one will remain this. Second, you can create whose name is this another system URL, and whose value will come from config map key. Config map will be app config only, and the key name will be this another system URL. So try that out and see if it's working. And after you do this, create this pod and invoke tips all method, and you'll see the db URL and the system URL should be populated with whatever you have created in your config map. Okay, moving on. So this is what I explained. The config map on CLI. YAML takes the CLI from CLI config map. Pod creates apply sets to the app. This is what I just explained. This is what we just config map got created, and you can see the config. You can see this config map. We saw that also, right? Data with key value pair. We saw all of that. So you can get this config map. The map you created using YAML, or you can create config map using YAML only. In this YAML, you can pass only this information. Other metadata will be created by Kubernetes automatically. Right? Now, if you want to create a Kubernetes config map contents from a file, correct? So, so we will create Kubernetes config map from contents of a file. So here is how you do it. So kubectl create config map. Again, the config map name is a map name. From file, you give file name. So this file, whatever is the key value pair in the file, will automatically be populated into this map. How does this work? This command will look for file, a config file like this file, a config file.conf, in the same directory where from the command is being run, and save the contents. Once it finds that file, whatever is in this a config file.conf, it will save the contents of this file under key. In this map, my config, there will be a key created with the key name will be the same name as the file name. The file name is used as a map key. We can also specify the custom key. So if you don't want the file name to be given as map key, so you can create an environment config from file, and here you can give your own key. In that case, it will not create the file name as a key, but it will take the contents of the file and put as a value from this. It will store the a config file contents under this key, right? You can use from file multiple times. You can use from file from a directory to directory also. Once you once you use this from file and give the directory name instead of file name, all files config under the directory will be stored. File names will be used as the config keys, config key for each one. There will be multiple key value pairs. One key will be for one. Each file will have file name will be the key. Like say file 1, file 2, file 3. So file 1 will be the key, file 2 will be another key, file 3 will be the third key, and the content inside file will become the file 1 key values. Same with the file 2 and file 3. Right? File names with invalid config key will be ignored. So let's see how this works. So I'll delete all of this. Then so this is here. I'm just going through this. I'm deleting the existing pod. I'm deleting the all the config maps I created. Then there's a file which I created. Let's see if this file, there's a file cat db URL. This file has this content. So I'll create a config map. The map name will be my properties. It is creating from a file db URL because the file name itself is db URL. So it will get created. Then I'll be creating a pod. It's the same pod which is referring this, this pod. This config map environment from file content instead of command line, it will be coming from file content, and this is the pod. So environment from config file, and we are saying it just come from my properties. Config map is my props here, which is the same name here. This and this is same. And once I create it, then I can and this is the value db URL. This is a value from db URL file host whatever. So this should get injected into the Spring Boot application. Let me run through this. I will explain the process, what is happening here again. So what we'll do is we will just run through this example. So let's see how many config maps we have. So we'll exit this out. kubectl get on config. So I'll delete all of this. kubectl delete config map. This one config map. I don't know. App config did we create? I think we only created. This is created by Kubernetes, so we won't delete this. Config map deleted. Now let's see how many config maps here. Only one created by Kubernetes. Now we'll create our this thing. Let's see if I have the db URL file still or not. I have it. So this is the content of the db URL file. Good. Now I'm going to create this my props config map. So kubectl create config map my props config map my props from file -f from file from file equal to, and this is db underscore only, yes, db underscore URL, and that's it. So my props got created, so you can see that. And one more thing that you wanted to show was this. Where did that go? This one. I want to see get config map into this thing also, my props. I want to see the YAML file. So it has kind of config. This is the key and this is the value, correct? So it created that config map with this key value. Now let's look at this file. Create config map from file content. Cat create config map from config map env from, and this is file content. F is small, file content. Let's see what is here. So it's referring to the same my props, which is this one. Config map means my props, right? And I might have specified, it might show the name here, my props. Right? This is what I will be referring into my pod YAML. Right? My props and this becomes, this becomes inside this container, this environment values, environment variable values are coming from this config map whose name is myprops. Correct? Now let's run this kubectl create openness. Okay, I already have port from the previous thing, so let me delete that port. Apparently, I'm keeping the port name same in different ports. So YAMLs, I should have changed it, but let me delete the existing port. kubectl delete port deleted. Get port. Now there's nothing. Now let me create that. Port created. Now I get this port. I see this port. Now if I now just reiterating that there is an environment variable. Now there are environment variable set from this config map my properties, and this my properties uh, we created from a file, and whose content was I showed somewhere, whose content was somewhere. Where did I show that? This one, whose content is this. So this file has this content. From this file, I created a config map called my properties. And when I check this my config map, my properties, I see this is the key and this is the value. And from this key, from this config map key and from this config map value, I am creating a pod whose whose environment variables are coming from this from this config map my props. Now this pod has this image, this image which has this code, which is taking the value of this DB URL from environment variable. So let's see how this whole thing played out. Correct. So now we have this pod. So we will go inside this pod, kubectl exec, then wget, sorry, curl localhost colon 0 fresh tips. So it shows this value db from db URL file host, right? And this is what I was showing you, the db URL content somewhere, and it's not easy to find this. No. There's a db URL cat. This one. This is the one, and this value has come from that file. Somewhere that file is there. I showed the cat, and you could see the cat also. So this is how the value of this environment variable got populated. We created a config map whose content got populated from a file. File just has a one line. The name of the file is the key. So Kubernetes config map has that key db underscore URL and value as this. Then we created a pod. That pod created an environment variables from this same config map, and that environment variable, one of the environment variable had the key as db underscore URL. So it got injected, the value of that got injected by Spring Boot automatically into that variable, and we in the controller class, and we got that thing, and we saw the value getting populated there. So that's from the file. So let's move on. I will just reiterate what I said. DB URL has below one line as a content. A config map with the name my properties created. From file option is used to create this file. We'll put from file option is used to refer this file, actually not create this file, to refer this DB URL file. What it will do is it will put the content of the file under DB URL key in this my props key map. Config map contents are created and can be checked with this. We did that. You can describe the ports also. So actually let's check let's describe these ports as well. So let's see. It's a good idea. So let me come out of this port first. kubectl get port. This is the port. kubectl describe this describ port. This port, and this is the volume, this is the conditions, environment variables from. It has taken an environment variable from this my property map. Right? This is what we had told in the YAML file, right? If you saw the YAML file above, which I had shown somewhere, this one. So it's from the my props config map, and this is what it is showing. here my environment variables from my this config map, correct? This one, correct? And now let's go back to the slide, correct? So we can specify all options together. We discuss many options, right? There are many. Okay. Just thinking. Huh. So you can see here. You can see from file we are creating one. Apparently this file can have one key value. This file can have another key value. This file can have third key value, and this from literal can have another key and another value. So you can combine multiple options to create config map, right? So that's one. This I'm showing from the command line. You could always do it in the YAML file also. Once you create this config map, you can say config map kubectl config map get env config -YAML. It will show you the YAML which you could have used to create such environment variables instead of creating this from command lines. You could have used to create this config map from the YAML file instead of creating this config map content from the command line. Okay, I think I will stop here. Maybe we'll discuss this in detail in the next session. And this will be a homework. I have not done this example of all the options. And yeah, so we'll go through this environment variable. We'll discuss as volume also, how to create from volume. We'll see how to expose only few key values from config map, from the volume, how to mount the existing directory permissions of the volume. Then you want to update the configurations, and then secrets. So let's see how much you can cover in the next meeting. Thank you very much for joining. We'll meet in the next session. Thank you. Hello everyone. Today we'll discuss other ways also to send the configuration to the application deployed using Kubernetes. The first example we'll cover is if you get the contents from a file, and at very high level, what this means is we'll have a file which will have the configurations or properties. And using Kubernetes, we will have the configuration or properties inside this file created as environment variable, and our application will be able to take those environment variables and as environment variables and use that as configurations. So we'll go step by step. If you have not deleted your pods, delete those. Let me check if I have any pod running. kubectl get pod. I think I have. I was trying something. Okay, so let me try to delete this. kubectl delete /, this, and this. And let me see if the ports can get started. Yeah, these are controlled by stateful sets. I will delete those stateful sets later. So let those ports be there. Now what I'm going to do is I'm going to create a config map, and this will be the name of the config map. And this config map will be created from this file, myprops.properties. So let's see what is inside this file. So cat myprops.properties. So it has only one key, DB URL, and the value. So I deliberately changed the URL to from file content _ host because I want to see this is a unique value. If this value gets populated in the application, and if I can retrieve that. So this is the content of the file. Now what I'm going to do is I'm going to create this config map. So let's see. kubectl create config map, and now instead of saying from file, I say from. This is my props remain same, from env file, from env file equal to, and I give the file name myprops.properties. Oh, it already exists. Okay. kubectl get config maps. Okay. I will say I will do that later. These are two config maps. Let me delete this kubectl delete config map slash my props. This config map deleted. Now I should be able to create this. So this got created. And you can see this config map kubectl ctl get config map and my arrow ps hyphen o yaml. So you can see this is the data db url, whatever I passed from the file. So this gets created. This is the same data which is in the file. Okay. Now my config map got created. The next step is I'm going to create a pod which is going to use this config map, which I just created, my props, and populate this in environment variable. Now on the other side, I have an application which populates the class variable, certain class variable from the value of this environment variable. So I will show you that as well. So let's say, so they have this file k8 config map env from file content. So let me see that k8, this is the file, and you can see that it's using the, so it's same, it's a pod, and this is the name of the pod, and this is a container, and container is taking environment variables from a config map reference, and the name of that reference is my props, which I just created. Okay, this is what you just saw, right? The my props, correct? So so let's see this. So as the cubes it will create now. Create -f. So this pod got created. Now I can log inside the pod, and I don't have the pod forwarding, so I will log in inside the pod and then try to use curl on wget. And let me see what is inside this pod, how it's coming. So in case you forgot, so this is the DB URL. See, if you see the code, this image, the container has this image, which has this code tips controller. This is a Spring Boot application, as you are aware, and it has a variable called DB URL. And this variable is getting populated from this environment variables value, DB, capital DB underscore capital URL. If it doesn't find any environment variable with this name, then DB underscore URL variable will have the value called default host. So now we will be setting this up. This pod has set this up as an environment variable. So this Spring Boot application should be populating itself, populating this variable from the environment variable value, which is this. So the DB URL was from the properties file. We created a config map using that properties file. So config map is called my props, and we are using that my props in the pod. So my props will have DB underscore URL value, which will get set as an environment variable, and this environment variable will be used by the Spring Boot application to populate this variable inside the controller. Now we have this get method. So tips. So if you see tips, it will pass a DB URL. So if we get this DB URL, it's a tip colon DB URL colon whatever. If we get this, the value of DB URL which we had set here, that means our whole end-to-end flow is working fine. So what I'm going to do is kubectl get ports. It's running. So kubectl exec -it port name -fn bash. So I'm inside this. So let's see curl localhost colon 8080/tips. So this was the path, URL path. So this is the value which I got, and this was the value which I set into in the file also, correct? Somewhere we saw this is a file, correct? So it got populated by the by the Kubernetes into the application. The come out of this, let's see the subsequent steps. This is just an explanation. I will just reiterate one more time. My props.properties as below one line as content, which I just saw. So a config map with the name my props is created. Now, while creating the config map, from env file option is used to create to use this file. It will put db URL as environment variable, which Spring Boot app will inject. Spring Boot app will inject into this controller variable, correct? Config map, the contents created can be checked with, which we did. And we can see cubes, it will describe pods, and we can see the pod, and it shows the environment variable from this config map, and that I will leave it up to you to run this command and check it out. And as I showed you, environment variables will be applied. This is the environment variable. It will be injected into this variable, and this variable will be returned as part of this get call /tips get call. Now the next step, config map as file via config map volume. This is the another way of passing the configuration. So config map volume helps exposing config file to container. So read this. It exposes config file to container. The volume will expose each entry of config map as file. If config map has 10 entries, then how many files will be created? 10. Container application can read the file and get the config values, right? Because each config map entry is coming as a config file, as a file. So container can read that, the application can read that and populate itself, populate its variables. It is generally used for large config data, and we'll see example of that. So config map as file via config map volume example. This is an example. So what will happen is a config map will have its data appear as directory inside the create container. So we'll create a config map first. So there is a YAML file which I have created. So I will show you that. Cat my config map YAML. So this is the YAML file. So it creates a config map. This is the name of the config map, custom config. It has these key values: DB URL, the system URL, debug value, max connection, output directory, Kafka topic, just some random key value pairs I have put here. Now coming back here, so I will create this kubectl apply -f. I could use create also, apply also, doesn't matter. Kubectl apply -f, then my config YAML. So it got created. Now create a pod using above config map. So we are going to create pod using this YAML. So this is the name of the pod. And here, if you see in the containers, there is a volumes, and volume name is my config. And this volume is getting populated from config map, and the config map name is custom config, which we just created here, right? This is the name of the config. So we give this name and use that to have a volume inside pod, and the volume name is my config. Now this volume is mounted. So there's a volume mount. It's mounted. This my config. So this name is same as this name. So which means this volume is getting mounted inside the pod and is getting mounted in this directory /etc/my config directory. So this is a file. This definition is in this file create config map entries. Let's see that. Cat create config m small entries as file in one volume .yaml. So this is the file. This is exactly what I showed you. Now I'll create this. Let me copy paste. Oh, I don't need to copy paste. I can run this command and change cat to kubectl create kubectl create -f. So this pod got created. If I say kubectl get pods, this is another pod. So I can log into this pod kubectl exe -it -hyphen bash. So I'm inside that pod. Now, as I said, it will create, it will mount this volume. So let's check that. And what I have said is it will mount under etc config directory. So let's check that ls/etc. What's the name? My config directory. My config dir. So it has created that. Now you see each value which I had given in the config map, it gets created as a file, correct? DB URL, another system URL. So you will see DB URL is file, another system URL is a file. Let's check what is in DB URL. DB URL, why it's not showing? Oh, I am not inside the directory. First, I have to cd to the directory. See this DB URL. It is showing the value here from another whatever, which I had created here from file, other system file, right? So sorry, from config file URL. From config file URL. This is what it shows. Now, if I take any other random, let's say I say output directory, I cat the output directory, I say cat output dir, it will have the value my output dir from file, which is what I had populated here, my 2dir from file. So it created that, it created those, it created under the mount of directory, it created many files. On each file, name is same as the config map key, and the content, the file has only one line, and that one line is that one line has the same value as is the config map value for that particular key. So this is about exposing the, now your application can read from this directory, and for each file, each file name is the key name of the config map, and the value content of the file is the value of that config map value, config map key value. So your application can read it from this directory for each configuration. Now, if you want to expose only few key values, we don't want to, have all the key values which have populated into this, config map, for example. So in this config, where did the config map go? Here, I want to expose only few key values. So how to do that? So, so there is, so what we are going to do is, it's the same pod, similar thing. So you are going to have volume and volume mounts. Only thing which you are going to do is, you are going to mention the items here in the volumes that I want to expose only DB URL and debug value. I don't want to expose any other config map entry in the volume. So let's see that also. So this is file, few keys. So I will show you that. Let me exit out of this pod first. So one volume, and what's the name of the file? Underscore few keys. Few keys. Oh, not create. I should use cat first. So this is where the items, only these two items will be created in the directory, in the volume in this directory, etc my config dir. So what I'm going to do is I try to create this a. So let's port. So I have to delete this port. I have given the same port apparently here also. So kubectl delete port, and I'll deleted that. So now what I'm going to do is I'm going to run this, and it got created. So I'm going to log into the port kubectl exec. So I'm going to log in, and I'm going to check for cd/etc my config dir, and I say ls. It's only the two config map entries. The config map is a key value pair. The key for each entry becomes a file name. The value for that particular key is the content inside that file. For example, cat this, cat this. So you can see the first db URL this value, debug value file name is info, right? So that's the way you can expose only few key values here. Now, if you, so some question, you might ask this question, what will happen if the volume is mounted at etc directory? Etc directory is already existing. So if you do that, if you don't give etc/myconfig dir, you just mount it at etc, then whatever is there in the etc folder will become inaccessible. And whatever you will mount under etc, only that will be accessible. You don't want to do that because etc has many important files and the subfolders also. What if you want to see old and new data? Mount as a file subpath is the key. So there is another way. So what another way is, see, you are taking the custom config, so there is no problem here. So during volume mounts, you can have the same my config, and the mount path you can give this /etc myconfig dir and myfile.conf, and the subpath is debug value. So what would happen is, so it will be mounted as this file, and the subpath is the value of this key, which the debug value here. The subpath is a key, right? The config map key. So debug value is the key in the config map. So the value of the debug value will be set in the mount path file. We'll see example of this. So what I'm going to do is, do I need to delete? No, I don't need to delete pod. So I need to create this pod. And what is the file name? What is the file? The YAML file name? Files in volume. Let's check that. Let's exit out of it. I forgot the file name. So what I want to check is files in volume, files in UL. Okay. As one file volume. Permissions, will do this later. As which one is this? Okay, let me check one thing. Subpath, let me grab for subpath instead of this. Sub and P is capital. Okay. This is the file which I want to run. So cat k8 config map entries as one config file.yaml. So this is the subpath, which will the debug value. The value of this key in the config map will be populated in the file. So let's run that. Okay, I think I need to delete the ports. So kubectl get pod. We should have given the different name for each YAML, but nevertheless, kubectl delete pod. Done. Now kubectl create -f. It got created. Now let's see the pod. ctl get pod. This is the pod. kubectl. It's this is the pod which got created. So I will go inside this pod. kubectl exec. I think this is the pod. Now I go into etc. What is the directory name here? etc myconfig. etc my. So now let's see what is there in this file. You see the file inside this is only one value, which is info. So that is another way to populate the configuration inside the Kubernetes image. And this is what I showed. The last step is the volume file permissions. Files in config map volumes are given default permission, which is 644. 644 is read, write, read, and read. You can change the permission. It can be changed by default mode properties in the volume. And we'll see example of that, right? So remember, the 644 is read, write, and 4 is read, and 4 is read. So what we are going to, let's see this file, config map entries. I think this is what we saw as one conf file. Let's check that one more time. Get config map entries as one conf file. So it is already got created, and we were already inside that. If you see this was the permission. Actually, we should have seen that permission inside this, but anyway, let's see. 1 minute. Let's go inside this again. kubectl exec. Let's go and go inside etc my config dir, and this file will have ls minus ltr. This is the permission it has, right? Now what we are going to do is we are going to have another YAML file. Before I delete this pod, let me show you another YAML file, and this YAML file is create config map entries, config map entries, and then okay, as fun config conf file hyphen file permissions, correct? So it is same as the previous YAML file, pod YAML file I showed you. The only thing is we are changing the default mode in the volumes. We are changing the default mode to 044. So instead of becoming 644, which was the default thing, now it will become 044, and we'll see that. But before that, I think I have given the same pod name, so I have to delete that pod. Cube ctl delete, it got deleted. Now I'm going to create it. Cube ctl create hyphen f. Okay, spelling was wrong. Cube ctl create hyphen f. This got created. Now I will go inside this cube ctl exec. Go inside this etc my config directory. Use the difference. It had read it earlier, it had now only write, because we give the default mode as 444. Right? So that's how you can change the file permissions. And this is what I showed you, correct? So I'll pause it here. Next time in the next session, we'll cover, how to update the configs and, and update config, various ways of updating the config, and then we'll move to secrets also. So thank you very much. We'll meet in the next session. Hello, everyone. In this session, we'll discuss how to update the config of a config map. In the previous session, we discussed, how to create config map, and there are various ways to have the configuration passed to your application. Now, if you want to update the configuration in the config map, there are, you can update it without restarting your application or restarting any other component. So what we'll do is we will update the configuration using kubectl command, but there are other ways also to update. You can update in the YAML file also. So what we'll do is we'll create a config map, or we will reuse it. We'll see. We'll create a pod which is using the above config map. We'll validate the config map. How will we validate? For example, we'll check the values of the config map, where they're getting reflected in the pod or not. Then we'll update the config map using kubectl, and then we'll revalidate that updated value is being reflected inside the pod. So this is the config map which I'm using. Let me see if I have already created this. So if it's created, I will delete it. So kubectl QCTL get config map. I will get all the config maps. Now this config map I have not created, to be updated config. So I can create now. So there is a YAML file to be updated config. So let's see that YAML file. So in this YAML file, all I'm doing is creating a config map with this name, and this config map has these key value pairs. So first is DB URL key, and this is the value. Second is another system URL. This is the value. So I'll be creating this config map, and what I'll be doing is let me open IntelliJ also on the side, so that I can show you the code where it is getting used. But while that is opening, let me come back here. So let me create this first. kubectl create -f, then to be updated config. So now it got created, and I can see that it appearing here. So 1, 2, 3, 4, 5, 6. It has 6 key value pairs. It's showing that here also. So now what we are going to do is, next step, we're going to create a pod which uses above config map, and this pod is cat config map entries. So let's see that cat config map entries as one file, conf file, as file in one volume, as file in one volume, then update test. So let's see this. So this is a pod, and this is the name of the pod, and it is creating a volume, and it is mounting this volume. So this volume with my config name is created, which is this volume has config map. So you will see the config map entries, and you would have seen in the previous session we have done this already. And I'm using this config map which we just created, and this volume is getting mounted in this directory under etc my config dir1. So let's see that. Let's create that. Hopefully we do not have a pod with this name. So let's see kubectl delete pod. If it is there, it will delete. It was there. So now I am going to create this pod. kubectl create -f. So this pod got created. So I will see the existing pods, get pods. So this is a pod config map as file. This is what I created. Now I can log in inside the pod. So I think in this example, I'm running some command from I am logging in actually, and let's see what is inside this. So remember, we are mounting the volume from the config map in this folder. So let's see what is there inside that folder. kubectl exec-it, then this -f1 bash. So after -f1, whatever you're giving is the command to the operating system. So we'll go inside etc and my config dir1. So we can do ls-l here. Let's see. So you can see. So these are the things which created output directory max, max connections. And this is what we have given. Remember DB URL, the system URL. And this is what we had given here. DB URL, the system URL, debug value max connections. And you can see debug value max connections. Then what else was there? Output directory, Kafka topic name, output directory, and Kafka topic name. Let's see, one of these values. I think I will be updating the DB URL, and we can see that cat db, etc 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 my config dir1 db url. This is the value from config file url underscore initial, because this is what we had given from config file url underscore initial, this one. So this is the same value. You can check value for others. Let's say, I want to check the value of max connection and output directory. Remember, this max connection is 0, output directory is my output directory from file initial. So let's say max connections 0. You see 0. There's no new line character. That's why it's coming in the same line. And what was the other one? Other one was, we wanted to check was output dir. Output dir, and this is the name. My output dir from file underscore initial. You can check this, you can run this command. Let's see if this works. This works. ls/etc/ my config dir1. Sorry, what did I do? ls/etc/ my config dir1, and we don't have to make it interactive anymore because we want to see the output here only. And this is what it will give you without logging in, without going into that machine from outside only. You can tell this command, operating system command. And if I want to check something, I can say cat then /db underscore url. It will show up with this value. Okay, now let's edit that. Now we'll be using kubectl command, and this is the command kubectl edit the config map. This is the object, and this is the this is the config map. This is the object name, which is config map, and this is the config map object which will be updating. So let's see, kubectl edit config map, and I can copy the name from above, this one, and update. Now I can edit anything I want. So so I will change this from initial to underscore changed. You can change as many values as you can, but I'll be changing only one. The rest you can try yourself, and let me know in the comment section how did that work. Were you able to change it or not? So I'll save it. This is normal VI editor. Save this. Now once I have changed this, what I'm going to do is I'm going to validate this. Correct? How do you validate? So you can use describe. So let's see that. kubectl describe, and instead of describing any pod, I will describe same thing. Sorry, see, I forgot. Control A, config map. Oh, I'm forgetting things. Config C. Okay. DB URL is what did I change? Did I change? Because this seems to be changed. Instead of changing DB URL, I changed from config file URL. Let's see that. I thought I changed the DB URL. Everything else is same. From config file URL changed, and everything is initial. Let's see. This is the value of DB URL from config file URL change. My mistake. So now we want to see whether it has been reflected in the volume or not. So let's see. Yes. So I just issue the command cat, and you can see the value is changed. We did not restart anything. We did not restart the application. We did not do anything else. We just edited the config map using the kubectl, and it was automatically getting reflected in the volume, which application might be referring for the configuration. So this is how you change the existing config in the config map. These are the Kubernetes documentation. You can go through in detail. It has a lot more information than I have described here. Please go through that. Now we'll be starting with the secrets. So there are scenarios in the application where you have to use credentials, which is a password, for example, or private certificates, which should not be stored in the plain text or should not be known to anyone else. For that, Kubernetes provides a secret object, which is separate object. It is very much similar to config map, but you will see some differences. When you see the config map, you see the value appearing. When you describe a config map, you see the value appearing as is. But in the secret, it will not show the value in the plain text format. So like in config map, you can pass the value as environment variables or files in volume, like we did in config map. Secrets are passed to only those nodes which need them. And on such nodes also, secrets are stored in the memory only. These secrets are, Kubernetes does not write those secrets anywhere on the file or anywhere else. So it will be stored only in the memory and it will be sent only to those nodes which have the pods running, which needs those secrets. So we can see, let's see the existing secrets. kubectl get secrets. So the one secret which is already running. Now, what is the secret? It represents a token. Now, this is used between, remember the Kubernetes architecture. You had a control plane, which are more or less, masters, nodes, and you have the worker nodes, which were various nodes in the cluster. Now, these nodes need to interact with the, API server in the master node. For that, there needs to be communication needed. Now, how do you communicate? Generally, any API on the production environment should be protected. So likewise, API server APIs are also protected, and you need a token to communicate. So nodes also need token to communicate to the API server. So this token is already created beforehand, so that it is created by Kubernetes, so that nodes can talk to the API server on the control plane. You can read more about this. This is a nice article about explaining this. So I Google searched it and found this out. So you can read more about this, how the, what you need to know about securing API with mutual certificates between, so this is the API to mutual certificates, and same concept is used between the API server and the nodes. You can describe this, you can describe the secret, and this is the name. Now I can describe the secret also. So this is the FII, this secret already exists, and it has this data, CACRT and namespace and token and everything. Now we'll be creating the secret. We'll be, before we create the secret, let's understand, what are the type of secrets we can create. So you can issue the command kubectl create secret -fn help. Let me create that here also. kubectl create secret -fn help. And you can see, right, there are 3 types of secrets available commands I can do. So same thing here. I can create Docker registry secrets. It creates a secret for use with the Docker registry. A generic secret, create a secret from the local file directory or literal value. TLS, create TLS secret. TLS is, like SSL, right? So we'll be using the generic secret and that too from literal value to explain the concepts, but you can use any of these three secrets. You can create any of these three secrets. Now, what I've done is here you can create a generic secret. So I'll be creating generic secret, and I use this command kubectl create secret generic -fn help. It is very nice documentation. It gives you various options, various type of generic, various ways of creating the generic secret. And you can also, get the same documentation by issuing this command. I'll just read it out loud. So it creates a secret based upon a file directory or specified literal value. A single secret may package one or more key value pair. Like config map, you have one config map, many one or many key value pairs could be there. Same is the case with secret. Remember, secret you can create based on a file directory or from a literal also. When creating a secret based upon a file, the key will be default to the base name of the file, and the value will default to the file content. It's obvious. If the base name is an invalid key or you wish to choose your own, you may specify an alternate key. When creating a secret based on a directory, each file whose base name is a valid key in the directory will be packaged into the secret. Any directory entries except regular files are ignored. If you have subdirectories or things like this, those will be ignored. Only the files inside the directory will be packaged into secret. And you can try this out. And these are the commands, you can, the generic secret you're creating, this is the name of the secret, which is sort of a map. It will have many key values pair from this you're creating from a file. So the content of the file, the file name will become the key and the content will become the value. You can create the generic secret from file, and this is the file, and you can. So here is what he's trying to show is that because secret can contain multiple key value pairs, first key value pair is coming from this file, second key value pair is coming from this file. You can use as many from files options while creating the generic file secret. This in this still is creating the generic, and the my secret is the name of the secret, a generic secret with the my secret name. And this is creating from the literal, not from the file, not from the directory, but literal. So now because the my secret has to have key value pair and you are passing literal. So this is key one and this is the value of this key one. This is key two, this is value of this key two. Both of these key value pairs will be stored inside the my secret secret. Create a new secret, name my secret using a combination of file and a literal. So you can use, you can use from a file. You can create my secret whose content can come from a file. One key value pair is coming from here, another is coming from here. You can create a new secret, name my secret from env files, like in config map, of course. So you can create a secret and from the env file. And so you can give multiple env files options also. So you can see this command and you can take help of this command and see these options yourself also. So what we are doing is we're going to create generic secrets from literals. So and what we'll do is we'll create the secrets and we'll pass the secrets to our Spring Boot application, and we'll see Spring Boot application has taken those secrets. So we'll be creating secrets from Kubernetes, and we'll be seeing mechanism that these secrets are injected into the Spring Boot application. I think I opened the Spring Boot application. So so this is what we'll do. kubectl create secret generic, and my secrets only I'm using. From literal, this is the key, this is the value. Again from literal, this is the key and this is the value. So let's try to create that. Okay, close this. And the reason I am, so let me open, this is Spring Boot application we'll be using. I want to check one more thing here is application properties. So I'll explain the flow, how this goes into the Spring Boot application. So let's create the secret. kubectl create secret generic. kubectl create secret generic, and then ---- from literal. And by the way, if you are watching this video, please try all of these commands yourself. Watching will give you some information, but when you try yourself, you learn more. Make mistake, look into the documentation of command, watch this video again. That way you will learn more and remember for a longer time. So this is the key and this is the value. dbpw is equal to the password, right? Remember there are two equal signs here from literal. Okay? From literal equal to ESW ORD. Then again from literal equal to, and what's the key? Client secret. Client secret equal to the client password. Okay. Maybe I misspelled literal somewhere, which is here. Okay. What is exactly one name is required? Okay, I have not given the name to the secret. Sorry. See here, you have to give the name. After generic, you have to give the name, which I had not given it. So I will say my secret. Same name. You can give any name. Actually, I should have used different name, but I use my secret only. And you can describe this. kubectl describe DSL IV secret, my secret. So you can see this is my secret. It has this key, another key. The value it is not showing here. Now what we are going to do is, you can see this value using hyphen in the YAML format also. Let's see hyphen O YAML. Not describe, it should be get. Yes, get. So this is, if you can generate secret, using the YAML file also, this is a type of YAML file you use. But because the secrets are already created, we got the YAML file from Kubernetes. So it's, this is the key, this is the first key, this is the value, and this is not the plain text value. This is another key, this is another value. And again, this is not the plain text value. So now what we'll do is how to use this secret in the Spring Boot app. This is the flow which I am using. I will give you one option. You can try it out yourself if this works or not. See, this we have already done. So this is the create secret. We did using kubectl. K should be smaller here. Kubectl create secret. This is the command we just ran. Now we'll be creating a pod which will be referencing. This is on slide 57 now. So which will be referencing these secrets. In the pod, you will have a section called env. And this environment variable will be created with this name, and the value of this environment variable will come from this secret called my secret. The DB in this secret, the key DB PW, this keys value in the my secret object will be populated as DB underscore password value. So in reality, you will have DB when this all is done. You will have an environment with DB underscore password name and the value, which is DPW. The value will be the password. So same thing I will be using. This is something below also. And now, which here something below will be using, I think this key and this value. So you will see. I will show you that here as I will show you the pod YAML. Now what will happen is, so secret we created from pod got this secret from this from the secret object and populated in its environment section, which will be created as environment variables at the pod. Now in the application.properties, I have given DB underscore password as this $DBPW, which is the same name. I think this will not be used. This DB underscore password, because this is the environment variable we are creating. So sorry, you can ignore this. This is the environment variable DB underscore password we are creating from the pod, and will get injected here. And this is the below I will show you. We are creating client underscore secret in the pod itself as an environment variable. Spring Boot will inject that into this variable. These variables appear in the controller. So let me show you that. My mistake, I should not have mentioned this. So please ignore this part. So let's see this controller. Where is so this is the DB password and this is a client secret. So DB underscore password and the client secret is client underscore secret. This after caller in the Spring Boot application, if you are saying this value will be this variable will populate the value from this environment variable. But if this environment variable is not defined, then the default value will be this for this variable, and this default value will be for this variable if client secret environment variable is not defined in this client secret scenario. So what we are going to do is this I just explained you, and we are getting this value from the info. So if you see DB password and the client secret, how will you validate it has been properly populated? Generally, you should never do this in production. because client secret and client DB password or any secret or any password should not be exposed via REST endpoint. They should be used in the application while connecting to the servers or connecting to, to any external system. But just for our testing, we have this info, context, and we'll be getting this DB password and client secret just to validate whatever we have said is properly set. Never ever try this in your dev also, in your local also. This is just to make the concept clear. Whenever you're testing in local for your application, don't do this. I'm warning this, don't do this, because sometime or other you will forget it and it will go to production and then hell will break loose. Your system will get compromised. So just a severe warning. This is just, I am doing it to prove to you that I am able to populate the password and client secret using the kubectl secret object. Once you can write this separate code to validate this yourself, but in any of your application, don't expose secret or password using the REST endpoint or any other mechanism. No one else should be knowing that. As we saw, the secret etc. The Kubernetes secrets are stored in the memory only. They never write it. So this is I'm doing to prove a point. I should have used this to connect to a database or connect to a some OAuth to a server or something. But since I didn't want to do that elaborate arrangement, so I just took a shortcut, being lazy, to prove you that. But as I mentioned, never ever do this. If you ever do this in your dev testing also, take it from me, your system will get compromised. You will forget sometime or that will go to production, or in the non-production environment also, if you get compromised there, it's a serious issue. So please never try this. Okay. Now what we are going to do is, this is our YAML file, create secret little inject in Spring Boot. Let's see that. Cat create secret, create secrets little. So what I'm going to do is I'm going to create this environment. So this is a pod, and this is the name of the pod. Sorry, this is the name of the pod. I'm sorry. It's using this image, and it's creating this environment variable. It's taking the value of this environment variable from my secret, from dbw key from my secret object. It's creating another environment variable whose value is getting taken from the client secret key of my secret object, and we just created that. These two, we just created that. If you see from literal issue, this is the command we used. Correct. Remember the password for dbw and the client secret, the client password. Right. So we'll validate if these are going into the Spring Boot application or not. So let's do one thing. Let's create a pod. kubectl create -f. So pod got created. So this is what we do. Now we'll use the local info object. So we can log in inside that. Now we could have used port forwarding here. I think I'm using the port forwarding, or I can, just to be, just being lazy here, I can log into this kubectl exec, because I will be logging in. So I have to give in directory mode, the pod name, and I want to run the bash. Okay. Sorry, my mistake. kubectl, I have to get the right port name. This is the pod. It's not running. Hold on a second. Why it's not running? Did I? Because seems like the image name is wrong. Oh no, image name is here. Image name. Let's see why it's not running. kubectl describe pod. Okay. It's saying my secret's not found. What did I create? It's my secret or my secrets. What see here in the pod, let's see what we created, and we check in the pod we have given my secrets. And what did we create? We create my secret. So I have to change the pod definition was wrong. So let's see, first delete this pod. kubectl delete. I deleted that. Now I will check the, I will use VIM editor, and it should be my secret, not my secrets. Whatever secret name I have given, I should be using the same here. Okay, now it will work. So let's create one more time. Create. Let's check the ports. Now it's running fine. So now we can log in. exec, where is that? Secrets injected bash. So we logged in inside this. Now we'll use it in wget, the localhost info. So wget localhost 8080 Spring Boot transfer 800 and say info. So wget is not there. I can use curl. Come on. Okay, so this is the the password we had set and the client password. This is a DB password. If you see info, I'm passing the DB password, and DB password default value was default DB PW, which is not the which is not as this. This is the value which has been taken from what the secret object which we had created from literal. Remember, I showed you this one, the password, right? So this the password is what appears here, and the info2 is a client secret. This is the client secret, which is taking the client underscore secret environment variable value, and this client underscore secret value which we had created was the client password. So now you see the client password here. So Spring Boot is able to inject this. Now, how did we? I'll just reiterate. How did we do this? We did this by creating a secret object. From literal we did, but you could very well create from file directory or from EME file. Then we created a pod. In the pod we created so you can see this pod. Instead of me explaining, I can show you the pod here. So in the pod I created the environment section. Use the environment section. There I created an environment variable called db underscore password, whose value is taken from the my secret. It should be plural, singular. So my secret object, the key dbw key of my secret object, the value of that is getting populated as the value of this environment variable. Same is the case with client secret. And Spring Boot, if you set an environment variable and you do this in the Spring Boot application, Spring Boot will automatically inject the value into this variable, and we validate it by getting the info, and we saw that it's there. Again, as a caution, never ever do this. No password or secret should be exposed via any REST endpoint. We shouldn't even log it. No, the password or secret must never be logged. It should be just used, taken from memory, used it to connect to the to the external systems, for example, and and then that's it. Don't log it. Don't expose it anywhere. So coming back, I think what we'll do is, so you can create from the generic file also. I think we'll cover only this topic more, and then we'll call it a day. Let me put in the slideshow. So so there is a file which I created, secrets, and it's called db secret. Let me go there. Let me exit out of this. Then cat secrets and db secret. This is the db password value. I have created this in a file, so I can create this kubectl from file also, and we'll see how and this is the name, the secret, generic secret, and this is the name of the secret from one file, and this is the from file name. I'm giving the file name here. So let's run that command. Kubectl create secret generic. Kubectl create secret generic. Then secret from one file. This is the name. You can give any name. One file. Then hyphen form file. And you can give secrets. C then db secret. Let's see, this got created. And you can describe the secret. Describe kubectl describe secret. kubectl describe and this you can see, it has the data DB secret. It is not showing the value here. And there are various other options. Let's discuss this during the next session. So thanks for watching this video. Do practice whatever I explained here. Do like the video. Tell me how it is by through your comments. And again, the caution: never expose your secrets, the passwords, the certificates, or any such things via any restaurant points. Never log this. Thank you very much for watching. Let's meet in the next session. Hello, everyone. In this session, we'll continue the, creating the secret and dealing with the secret object which Kubernetes provides. First, what we'll do is, in the last session, we had created generic secret from the command line itself. This session will start with creating a generic secret from a file. So I will go through this slide and then I will show the demo also. So I have a file in this folder, secrets folder, and this file is called DB secret. It has this value. So let's see that. Cat. So I am in that folder already. So secret, and then DB secret. And this has this value, DB password value, and which you can see here. Now, what we are going to do is we are going to create a secret object from this file. And how do you do that? You run the this command, kubectl create secret. It's generic secret only. And this is the name of the secret. And here I am giving option from file, and this is the file location. So let's try that. kubectl create secret, then generic, and I can give any name. Generic, let's say file secret, then hyphen from file, and give the file location not equal secret, and then DB part. It's DB secret, yes. Oh, I should give hyphen mistake. So this secret got created. I can see this secret by describing this. So I can say kubectl describe secret / file secret. And you can see this is the secret, and the data, it has the key, the DB secret. And the key of this secret will be the value of the secret will be the DB password value. So this is how you create the secret from a file. You can create secret from a file by passing the key as well. Wherein here, if you see, right, the key name is the file name itself. What if we do not want the file name as the key name? We want to give our own key name. So in this folder itself, I have another file called, a file with secrets. So let's see that. Cat secrets, a file with secret, and it has this value, my password. So what we are going to do is we are going to pass our own key name in the Kubernetes secret. And this is the command, kubectl create secret generic. This is any name you can give. And from file we had given earlier. So we'll give that option. Now here we are passing the custom key. So in this case, the file name will not be the key, rather this key pass will be the key, and create the secret from the content of this file. Let's try that. So let's run the previous command and we'll change it. And from file equal to, and you have to give anything. So I'll give ABC key, for example, and then equal to. Okay, this is ABC key and the file. So from file, I forgot to put E up in the file. File secret already exists. Oh, I have to change this. File secret, I don't know, just give one for example. So it got created. So I can say kubectl describe describe secret and file secret one. And you see the key created is what we had provided. Now you can create secrets from a directory. A directory can have multiple files. Like in this case, the directory secret. Secret has multiple files, and this is first file and this is second file. Now the content of this file, the name of this file can become key, and the content of this file can become the value of that individual key. In the file, we were able to provide our own key name also, but in the directory, you can't provide the key name because directory might have many files. You can't provide the key names. So that's how it is. So what I'm going to do is I'm going to create a secret from the directory, and I will pass my custom key, and I will see the error happening, and then I will remove the custom key and just pass the folder name, and I will see the secrets getting created. Before that, let's delete all the secrets which we have already. kubectl get secrets. Let's delete by one. kubectl delete secret, file secret, then secret, file secret 1, then secret, my secret, and then secret, let this be there. I will delete this. Let's see the secrets. You will have only, actually I can delete this also. Okay, let this be there. Then okay, let's delete this as well anyway. kubectl delete secret, my registry secret. Okay, now we'll have only one secret which was created by Kubernetes. And now let's run this command and try to create secret from the directory. So kubectl create secret, generic secret only, generic secret, and the name I can give anything, secret, my dir secret, for example, and I can say --- from file. Although I'm saying from file here, but in reality it will be the directory location. And if I give any key, it will error out. Let's see that error. See, oh, I have to give the. Oh, sorry, my mistake. I should remove secret from here. Syntax was wrong. kubectl create secret, generic secret, kubectl. Oh, I remove the secret from here. Create secret, and generic should be here. So here is the error. Cannot give a key name for a directory path. Now I will run the same command, but I will remove my custom key name, and it will create. Now if I see kubectl get secrets, and I can see the secret which I just created. Now we have created all these secrets, and we have seen in the previous session how to load these secrets. How to have these secrets at environment variable, which Spring Boot application can inject. But what if you are not using Spring Boot application, or you want to read these secrets yourself from the application. So for that, you can use the volume mount. So in your, so you have created this secret, let's say secret from directory you have created. And in your port definition, you can have the volumes, which can refer to the, so volume name will be any name you give. There will be secret property in the volumes, and the secret name will refer to the secret which you just created. And this volume, the secrets, can be mounted on any path. I think we have seen that as well. But if you mount the secrets you created in the path, now your application can read the secrets from this path also. And these secrets are created by secret object of Kubernetes. What we'll do now is, as we saw, right, there are three types of secret: generic, TLS, and Docker registry. What is TLS? Where it is used, why it is used, is beyond the scope of this session. But there is a link which I have given in the next slide. You can read, you can do Google search and read about TLS, or TLS. You know what we there is a public-private key pair in the TLS. Will be generating that using the Kubernetes TLS secrets, and how to use all of these things, how to use that secret in the REST endpoint, public private secret. You can read from this article. So let's see the help. Kubectl create secret TLS. Kubectl create secret TLS help, and you can see all of this, all the options. So what is involved in creating the TLS secret? So you can I will just read it out, and more details you can read from some proper TLS documentation. So it creates a TLS secret from given public private key pair. So you have to have public private key pair. The public private key pair must exist beforehand. The public key certificate must be in .pm encoded and match the given private key. So generally, when you create the public key private key, it gets created in a pair. And I will show you one command to do that. And they have given the command, once you have this, public key private key, then use this command to create the TLS secret. So what is public private key? It's cryptography, out of scope for this. It's used for digital signature, doc signing, and other things. And there's a very small overview of this. So you can generate the public key private key in one command. So what you can do is, let's say you are exposing a REST service. Now there are many clients who need to invoke that web service. One way to secure your web services through public key private key pair. So a request signed with public key, your clients will have the public key with them. So they will make the request to your REST endpoint using that public key. They will sign that request with the public key. And once that request is received by your REST server, it can be decrypted by private key only. If something changes in between, the decryption will fail. So client uses TLS SSL to send data to server. So signs with public key, server decrypts using private key. Server will also use the same while sending data to the client. It's called mutual authentication. Hence, both client and server needs to have their own private key and public keys of each other. And you can read more details in this article. So what we'll do is, I will use some self-signed certificate. Will generate, this is a command to generate the private key. So I had generated that here. Let me see if it's there. No, I can regenerate that. That's not a problem. So open SSL. So you can use open SSL command to generate this. And then, so these are, you can read about its documentation in more details. So this is a screenshot I have given: OpenSSL gen RSA out, and this is the key it's generating. So let me generate that open SSL, and then gen RSA hyphen out, then my underscore CA dot key, this 2048. So this is 2048 bit got private key got generated. Now I'm going to create a self certificate valid for 100 days. So open SSL REQ, and this is the command I just sent 509 new nodes days 100 new node 100 key my this is a key which I created, my CA key, and this is a certificate and whatever it needs this parameter also I pass that, and so it got generated. Now you can use this above key and certificate in generating TLS secret. So so here if you see you can use kubectl create secret, and this you have to spy TLS type of the secret, and this name you can give anything, and the certificate which you just created, which is this, and you give the certificate and the key which you had created earlier using this command, and so you have to give that key my underscore CA dot key, and then it will create the secret and you can describe the secret. So let's try to create that. kubectl create secret TLS, then I had already created that, so I'll rerun that command. So this is the key I am giving here, and this is the certificate I am giving here. So now let's see. So the secret got created. Why do you use, once you created this TLS secret, where do you use it? I think if you're writing any program, using whatever language, you need those secrets because you need to sign your request. So you can refer this secret and sign that request. I have not given that example here, but if you are working in TLS or you have worked on TLS and you're signing your request, you would know already. If you do not know, maybe you can read some documentation and figure it out. It's similar, like whether you're writing Java or Python, the concepts are same, but the APIs and the way you do it will be a little different. But let's describe the secret anyway. kubectl describe secret my this is a secret, and you can say that this is a certificate, this is the key and name and etc. So this is how you create the TLS secret. The last section is third type of secret was Docker registry. What we are going to do is we are going to create a Docker registry secret and use that in the pod pod YAML to pull the Docker to pull a Docker image from the hub.docker.com. So now the images, the Docker images, for example, are stored in the registry. For example, hub.docker.com. Often the big companies might have their internal registry also. If you have internal registry, then the command which you'll use, it might change a little bit for your internal registry. Secrets are needed to pull images from such private repos. So if you have hub.docker.com and there is a private repo to which you have access, or you have your internal Docker repo where you need access to pull the images and you have access to one of those images, then if you want to pull those, because not everyone will have access to pull that, but you have, so you need to provide some credentials. So you will be creating Docker registry credentials and providing that in your pod YAML to pull that image. Now, how to create a Docker registry secret? What we'll do is we'll pull this image. We have seen how to publish this image into the hub in the second session. So now we'll be pulling that image using the Docker registry secret. So this is the command to create a Docker registry secret. kubectl create secret, and the secret type is Docker history, and you can give any name, and this is your Docker username, and this is your Docker password, and this is your Docker email, whatever name you had given while registering to the Docker. This is the user ID password while logging in, and this is your email, which you had given while creating an account on hub.docker.com. I had given that. I'm not going to show you my password, of course, but once I given that, then this secret got created. I had given the secret name instead of I had given my secret only. Secret got created. Now, what I'm going to do now is let's go to the next slide. I can log into Docker, or what I wanted to show you was this. So you can create a YAML, and in the YAML it's of type pod, and this is the name, and you have this container. Now container, if you see the image, I am pulling from the Docker registry, which is hub.docker.com, and image pull secrets because I need to provide the secret. I think I had made it private if I remember correctly. So I assume it's private. Then I have to provide the secret, and the secret which I have created is my secret. I already created that. So image pull secret is the name of the secret which I created, will be given here. So this is the so let me show you the this YAML file. So cat, this is the YAML file which I just showed, and I had just run. So earlier, I had just run this YAML file using kubectl command. Kubectl create -f and the YAML file. So it created the pod, and I got whenever as soon as I ran this file, I got this pod. You see, it was created 6 seconds before, immediately after running this command. And it was saying container creating, so I waited for a little longer, and then it after around 20 more seconds, it was running fine. So this is how you can create the secret and give the secret in your pod YAML to pull the records, to pull the images, or from the private repo, private Docker repo, for creating the pods. I think that is about it. You can read about the secret from Kubernetes documentation also. This is the link to create it has more information about secret. So I'll highly encourage you to go and read this documentation as well. So that's about config map and secret. So here we end our session. Thank you for watching. Please try out all the examples which I have given here yourself with your hands. Thank you. I'll see you in the next session.
Hello, everyone. Today we are going to discuss Kubernetes deployment. What deployment object is, why is it needed, what problem it solves. So let's say you have a sample service which has 3 replicas managed by a replica set. And the flow is that you have 3 pods managed by this replica set and a service object. The clients talk to service object, and service points delegates the call to one of these 3 pods. Now, deployment is needed when you want to upgrade your application to a newer version, and you want to deploy that version in the production. Now, how do you deploy so it provides deployment strategies for the new version of your application. So there are 2 ways in general, how can you upgrade your application to production? There are 2 ways at a high level. One way is you delete everything, delete the earlier version of your application, and then come up with a new version, which means that your service will be unavailable for certain time. Because once you delete older version of your application and come up with new, there'll be some gap, a second or few seconds or a minute or something. The other strategy is, start new pods or new versions and delete the old ones. Now, even within that, there are 2 ways to handle this. One is called blue-green deployment, and second is called a rolling update. And we'll see diagram of these 2 also in the coming slides. So in blue-green deployment, you spin up all new pods or all new versions and then delete the old ones. In the rolling update, you do it one by one. So spin up a new version and delete the old one by one, right? Spin up another new one. Sorry, it should be new one, and then delete the other old. So you can use rolling update when your newer version and the older version can coexist. Basically, your newer version is backward compatible. For the blue-green deployment, you can go and look into this link. What it has been explained in detail here. So basically, there are two parallel deployments. The old version is running on service A. For example, when you say old version, I mean the old pods are running under service A, and the new pods are deployed on service B. Once all ports in service B are up, then service starts pointing to B, and the ports in A can be shut down. The A is managed by version 1 of the replica set, which deals with earlier port. B is managed by version 2 of replica set, which deals with new port. And the replica sets are created automatically. So we'll see how this whole flow is automated using deployment. So blue-green deployment, the way it works is you see blue and then you see green here. So you have one replica set version 1 managing this port, services pointing to this. You come up with the new version, a new replica set with the new versions of your port, and then service starts pointing to that. And you can delete these ports. You don't delete the replica set, and we'll see why. The rolling update is one by one. So you have 3 ports managed by replica set version 1. Now you come up with replica set version 2. So let's talk about replica set version 2. What does it contain? So replica set, as mentioned, is managing the port. And there's a port template. The port definition points to the image and the version. The Docker image in our example and the version of that image. And that image is of your application. So when you add new features to your application, and then you create a new image of your application with a newer version, and you want that image to be to be used in the pods using replica sets. So this replica set version 2 has the newer version of your image. So what the older version of your the pod C is managed by replica set v1, which has the older version of your code of your application. So in first step, this pod C goes down, and the new pod C will be managed by the replica set version 2. Then pod P will go down, and in place of that new pod P will come up, which will be managed by version 2 of your replica set. And eventually all ports will be managed by the newer version of the replica set. And the replica set version 1 will remain, and we'll see the reason later. So deployment in essentially is a resource for deploying application and updating them declaratively. So when you create a deployment, it creates a replica set underneath, and that replica set creates the number of ports underneath. Now, why an extra deployment resource is needed by Kubernetes? See, if you do all of this, deployment, the version upgrade of your application in production yourself, it's quite complex process, and there's a chance of you making mistakes as well. So deployment resource from Kubernetes makes all this process easier for you, and we'll see demo of that. So it's helpful, for example, when we have 2 versions of that app running during app update. These 2 versions will be controlled by 2 different replica sets. Removing early version port and adding new version port will cause a lot of complexities if you do it yourself without using the deployment object. So deployment makes it easier. So we'll see the deployment file. So let's go through this. In this deployment file, you have in this YAML file, you have this kind defined as deployment. And then you have this spec, and then this is the name of your deployment. And you have the spec, and you are using 3 replicas. So this is a replica set sort of template. And this is the label you are giving, a tips app. And this is the port template. This port template will have the metadata, and this is the name of the port template also. Apparently, I have given the same name to the pod as well. And this is the label of your pod. This label should match this label. This is a deployment label, and this is your pod label. And this is the pod definition. We call this thing as pod temp. This containers image. And if you see, this is the version of the image. So this is part of the pod template. So now what we'll do is we'll create this deployment. And what are we expecting once we create this deployment? We'll see at very high level, a deployment object getting created. That deployment object will create a replica set. That replica set will create a pod with 3 replicas. And we'll see how this works. I had already created that. So let me delete that first. Come here. Cube CTL get deployments. So I was playing around with that. So let me delete this. Cube CTL delete delete deployment. So it got deleted. Now there's no deployment. So let's see the deployment YAML. There's the same thing which I showed you. So this is a replica set. So there's a deployment with tips app. There's a replica set which has this label, and then it has the port definition, which is using this image and this version of the image, right? Latest version of the image. So let's create it. Cube CTL create and deployments. So this deployment got created, and if you see the deployment, you will see deployment with this name got created. Now, if you see the pods, you will see the pods also got created. Now, these pods have this, some characters here. What these characters are, we'll discuss that. Now you can check the status of your deployment using this rollout status command also. So let's see this. Cube CTL rollout status deployment command. So it says the deployment tips app successfully rolled out, correct? So deployment creates a deployment object, then it creates a replica set creates ports and manage those ports. And we have seen the ports already getting created. Now what we are going to see is we're going to see the replica set. So kubectl get replica set. Now if you see one thing, this is the name of the replica set. This name has this hash. And this hash is same as the name of this characters appearing after in the ports when we say get ports. Now what this hash is the hash of the port template here. So we have defined the port template here, right? So this is the hash. Now what does this mean? The name of the image and the version of the image is part of the hash. So if we change the version of the image, then a new hash will be created. It won't be the same hash. Now, why I'm saying that, you will come to know when we upgrade the application with the newer version. So this is just I explained. So number in the name indicates the hash of the port template. So in the replica set and the ports, it's same. So when we upgrade using rolling update, you will see ports with 2 hash numbers. Now what we are going to do is, so this we have tested. When we upgrade it, I will show you how to upgrade. And you will see the 2 hashes appearing in the, there'll be 2 replica set, each one with its own hash, and there'll be ports. As and when the ports are moving from older version to new versions, you will see the hashes also getting changed for the ports. So deployment strategies, we have seen that. So for update, we have gone through that earlier, just refreshing those. For updating the app, below deployment strategies are available: recreate and rolling update. So what does recreate do? Recreate first delete all ports, then create new ports with new version. Only one version, either old or new, exists at the same time. In this case, app will be unavailable for short period of time. The other deployment strategy is rolling update, and we have seen example in the diagram of that already. It deletes old ports one by one while adding new at the same time. So apps are always available. It's a default strategy in the deployment, and we should use that as much as we can. And specifically when, and in one requirement for this is the 2 versions, the older version, the newer version, which we are trying to update to, should coexist. at the same time. Now what we want to do is we want to see when we do the rolling update, we want to see the ports getting changed one by one. To simulate that, we can see the old version port and the new version port. We're going to set some min ready seconds configuration in the deployment. Now, what this min ready? So here the reason we want to set this up is will be arbitrarily slowing down the updates so that you can see the ports with older version and new version. If you don't do it, that the Kubernetes will immediately change the ports to the newer version, and you'll immediately start seeing the newer version. So here I want to see one by one port getting upgraded to the newer version. Now, what this min ready seconds is exactly. So this seconds is an optional field which specifies the minimum number of seconds for which a newly created port should be ready without any of its container crashing for it to be considered available. So basically what it is saying is this I copied from the definition of the min ready seconds. What it is saying, and you can see that using the explain command. So you can say, deployment, spec min ready second. So when port gets upgraded, when you upgrade the port will be there, but it will not be available for 10 seconds because we have set this min ready seconds value to 10 seconds. Pod has started, but it's not available for 10 seconds. It will wait for 10 seconds if the container is not crashing. But if pod is up and before 10-second container crash, then of course it won't be available. So container should be up and code should be up, the pod should be up. So for 10 seconds, it's not available yet. After 10 seconds, it will become available. So that's what min ready seconds is. So I will set this settings. So let's see. kubectl patch. So this is the setting. So it got set. Now, if you see kubectl get ports now, and you get the replica set also. Oh, sorry, we have changed only so remember, this is the existing ports and this is the existing replica set. This hash is same as this. We have changed only the configuration of deployment. We have not started the rolling update yet. Now we'll start the rolling update here. So now let's say you have changed the code of your application to fix some bugs and added some new features as well. Now, once your code is changed, now you want to build a new image of your code. And this is a command, as you know already, to build the new image. So here we'll use the same image and change the version to latest one. And this is the command to build the image. So I had already done it. And if you see the latest one for this image already exists with me. So I'll be using that. Now, but in production, when you're during your development cycle, you need to build it yourself after adding, new features or updating your code. Now, what we are going to do is we are going to set this image. We are going to tell deployment, Kubernetes deployment object, the one which we created just now, tips app, that now the deal with this tips app container is should be the new image. Basically, what this means is that the images used in the container created by this deployment should be upgraded to this. Now, how this works? So you had the top level deployment object. Deployment creates a replica set. Replica sets create the pods, and pods are created using some containers. So let's run this command. kubectl set image, and this is what I'm doing. So what same name of the image, but the version is different. Earlier it was latest, now it is latest one. So I'm telling Kubernetes to change the image of tips app deployment to the newer version. So now it got created. Now, if you see the pods, you will see, let's see the replica set also. So now this replica set has a new pod. And if you see the pod, now there was one port with the new version. Now there are 2 ports with the new version and 2 ports with the smaller version. Why there are 4 ports, even though you're given the replica set 3, we'll discuss that later, maybe in the next session. And slowly you will see the number of ports with the newer versions are increasing and number of ports with the older version are decreasing. And eventually you will not have any port with the new version, with the old version. So all ports will be the new version managed by the new replica set, which is this replica set. Now you see there are older replica set, which doesn't have any port anymore. and the new replica set, which has the desired number of ports, which is three for us. Now, old replica set is also kept. Why Kubernetes does not delete the old replica set? Because if you want to roll back, and how do we roll back, we'll discuss in the next session. So if you want to roll back, it should have the old replica set to roll back. Now, what happens during the rolling update? So the earlier version of deployment had the version 1 of replica set. They were managing this earlier version of replica set was managing the version 1 of the pods. Once we told Kubernetes that there's a new image and pointed the deployment to the new image, so deployment ended up getting the version 2 of replica set, and which is managing the version 2 of the pods by creating those one by one, deleting this one by one and creating this one by one. Eventually, the version 1 pods will go away and the version 2 pods will exist, managed by replica set version 2, but both replica set will remain to help us in the rollback if need be. So what happens, how this rolling update gets triggered? Once we are told deployment that is a new image, the control plane controller detects that new image in the deployment. So what is control plane? You would have seen that in the Kubernetes architecture session. If not, I will recommend you go and check that video out. So in the control plane controller, the new image gets detected. Then it starts the new replica set and new ports. And you have seen the cycle and attaches the ports to the new replica set and deletes the old ports from the old replica set. Now, the replica set is created by deployment automatically. We don't, you would have seen we never ran any command to create any replica set. We just set the new image and the replica set and the associated ports with the replica set are created by Kubernetes automatically, and the old ports with the old version of replica set also got deleted by Kubernetes automatically. So this is a reiteration. Old version replica set is maintained after the update. So I'll stop this session here now. In the next session, we'll be discussing the how the rollback happens. So thank you for watching. If there's any comment or anything, then please feel free to give the feedback in the comment. Thank you. Hello everyone. Today we will discuss how to do the rollback of a deployment in Kubernetes. So we'll simulate a scenario where we will be rolling back. So what we'll be doing is, let's say we have created a new feature. We have added a new feature into our system. So here I'm using example of Spring Boot application, but it could be any application. And now let's say that new feature has a problem. It has either a bug, or it is not working the way it is expected to be working, or it's throwing some unknown exceptions. So in our example, we'll be creating a new controller, and that controller will have a method. That controller will expose an REST API with the /new feature. And if anyone invokes that, it is going to throw an exception. It does not do anything, just throw an exception to simulate a rollback scenario. And if you want to see the code, this is the code. So this controller has only one method, which is expose as a REST API, and it just throws an error. So what we are going to do now is we are going to we have deployed this application already. In the last session, you saw that we have deployed this application. Now we are going to change this to version 3. Now, once you add this feature, then you have to build that. See, deployment is deployed with an old version. Now you have to build an image of your application with the new version. When I say image, I mean Docker image. And let's say we are giving version 3. So I have built that image already. So let me show that to you. So I have built this image, Docker version 3, Docker image with version 3. I hope you remember how to build a Docker image. It's Docker space build space -t, then your image name, then :3. is a version. So that's how you build it. Because I've already built it, so I am not going to build it again. Also, you saw that this deployment tips app is already existing, so it has replica set of replica 3. So all 3 pods are up and running. So what we are going to do is we are going to upgrade this to version 3 in the existing deployment itself. So let's see that. Kubectl set deployment tips app set image deployment set image deployment, and the name of the deployment, which is tips app. So this is the name of the deployment here, tips app. Then in the in this deployment, it has image. This deployment is done using an Docker image which has this container, and for this container we are going to upgrade the Docker image to latest version. So tips app container, and then here I had latest, so I will change it to 3. So before I submit the command, so immediately after we do this, we will see the pods upgrading to the new version, and we will see the the age also of the pods. So let's see that. Update it. So kubectl get pod, and so it's still getting updated. See, 7 seconds before this came, and this is was done 9 days before. And why there, when we have given replica 3, why there are 4, we will discuss in the coming slides. Okay. So another one got created. Slowly, all this will be using the, so these 3 are created, and the last one should go away now. So there are 3 with the latest hash. You see, earlier hash was this. We discussed hash, this hash. See, earlier when we started, all 3 replicas were using this hash. Then the new image had this, the new port template has this hash. So eventually you will get all the ports with this hash. Now we'll follow the slide. So we can log on to one of these pods and try to invoke. We don't need to log on, we can invoke him from outside. Let's try that. kubectl exec, then this, correct, then hyphen bash, hyphen. Instead of doing bash, because we are not going to the bash session using interactive mode, we'll be running some command, and what that command is, curl localhost 8080 new feature. So let's see if that works. See, you curl local host colon 8080 / new feature FATU. Let's see what it gives. So it gives an error. You see, it threw an error. In production, you will be getting, you should be converting this to through error, say damn ran into error, right? So you will not send this whole stack test to the user. You will send a user-friendly error message. But here, just for a demo purpose, so this damn into error, I'm getting it here, correct? Now, so we know the new deployment has a buggy code, or the code which is not working the way it is supposed to be working. So what we'll do now is we'll be doing the rollout, rollback. Sorry, not rollout, rollback. So the command for that is kubectl rollout undo deployment tips app. So it will roll back to the previous version. So let's see. Okay. Let me do it here. kubectl undo. Sorry. kubectl rollout undo. ROLLOUT rollout undo deployment tips -app. MENT tips -app. Okay, the The spelling was wrong. So let me fix the spelling. Okay, my mistake. Okay. A kubectl. So it got rolled back. Now it got rolled back. Um, uh, so you want to check the history of the rollback, right? So this is the command kubectl rollout history. So kubectl rollout history instead of undo, we'll do history. So excuse me. So you can see the history also, right? We changed earlier it was 4, somehow we changed to 3, then it picked, and then we reverted back to 1. Right. So in this, when I was doing this, it from 3 it got reverted to 2. If you want to roll back to specific version, so the command to do that will be kubectl rollout undo deployment tipsap same, then -f to -revision. So you can let's see. So it has updated to 3. Let's say we want to update it to roll back it to version 4. Revision and equal to. I was just checking whether there's equal to sign or not. There is equal to sign. Equal to 4. Okay. Tips app. Let's check the spelling. Rollout undo deployment. Sorry, my mistake. I just check. I just use history instead of doing undo deployment. Undo deployment tips app to revision 4. Okay, current template already. So there's a template. It's the same template, right? So the current and the 4 and 1 have the same template. So what I'm going to do is I'm going to change it to 3, which was the error version. But let's see that. Now we'll see the history. Because 1 and uh, 1 and 3 had the same template. So when we roll back to 3, it's showing here same hash for the template, port template. So if there are 2 revisions which have the same template, you might get such weird behavior. But 1 is also same as 3 because of the same exactly port was exactly same. There was no difference. So although we just said to change it to revision 3, but it's going to revision 1 because 1 and 3 are same. If they are not same, then it will show 3 here, right? When I try to do this, right, it says it gave me error earlier, right? When I tried to revision, somewhere it had given me error, correct? kubectl rollback, you see the history, and I did that. Deployment tabs, skip rollback, it already matches version 4. Okay. Current template already matches version 4. And what was the current? 1 and 4 to deployment app rollback. Let's see that. Changing back to 3 as we don't have region 1. So you can see the history. Now I'm just checking the history. We'll come back to this later. Let's see the history one more time. 1, 4, 5. We had 1 earlier also, and then 3, 4. Now it's the same 1 is appearing here. So let's change it to something else again and see. To revision, I don't know, let's say 5. Skip rollback. Current template is 1 only. So let's change it to 3 one more time and see what happens. It says unable to find version 3 in the history. Oh, deployment app rollback. So what's the version it's having currently? We have done so much rollout and undo rollout. So it has 1 current is 1, and let's see, change it to 4. We tried, so it rolled back to 4 now. So let's see why it is not showing 4 here. Let's get back to this later. It should show 4. See, here it is changing. Oh, maybe I was reading it wrong. It's from top 1, 5, 6. So let's change it to 1 and see what happens. Let's see the history. It's 7. So 1 has become 7 now. So my mistake. I was trying to read from bottom to up, and in reality it should be from top to bottom. So 5, 6, 7. Now 7, I want to change it to 5. Let's see. So roll back to 5. So now I do this history. So 5 has become 8, correct? So, but only the current and the last two are maintained here. You can check that out. A replica set also act as revision history. By default, only 2, current and the previous. See, in this case, our case, it was 3, current and previous 2 were maintained. So there is a revision limit history property in the deployment YAML or in the deployment setting. You can set that if you want more previous replica sets to be maintained. So, so how the revision history works is, so you have revision 1 of replica set, revision 2 of replica set, revision 3 of replica set, which are maintained by deployments. Now, so these are the, this is the latest revision, and the replica sets port for revision 1 not applicable anymore. So replica sets, once you upgrade, then this will not be applicable anymore, correct? For this statement, only 2 current and previous are maintained. But in our case, 3 replica sets are maintained. For in our case, this will also be, this replica set will also exist with some port associated with it in case we want to roll back. If there's a fourth replica set, or sorry, 0 replica set, the very first replica set revision, let's say it was 0, so that will not exist anymore. That will not be applicable anymore. Control rate of rollout. So during rollout, a new port was created, and after the creation of one port, the older ports were deleted. So we saw that, right? So there we had 3 ports initially, and then let's see that here one more time. If I can show you that, see here. So replica number of replicas was 3, but there was 4th code created. 4th port also got created. So for some time, the 4th port also existed. So now same cycle is repeated till all ports are on the new version. Now there are some questions you might ask. So what are those questions? Does only one new port is created always before deleting one port with old version? We had replica set 3. Why could we not create 2 new ports with a new version and then delete these 2 existing ports? So after that, we'll have 2 new ports with the new version and the old port with the old version. Other question could be, can we create 2 new ports and delete one old port? How such flow is decided by Kubernetes, and that is where these settings of max search and max available come into play. So this documentation I copied pasted from this link. You can go into this link also yourself and read in more details. So this max search is a property in the deployment. It comes under spec, strategy, rolling update, and max search, and it's an optional field. It specifies the number of ports that can be created over the desired number of ports. The next is an example. The value can be absolute number, for example 5, or percentage of desired ports, for example 10%. The value cannot be 0 if max unavailable is 0. The absolute number is calculated from the percentage by rounding up. If you give percentage and the percentage results in some decimal number, that it rounds. Let's say it returns in 3.7, it will round up to 4. And the default value for this is 25% percentage of desired ports. So take an example. When this value is set to 30%, when max search is set to 30%, the new replica set can be scaled up immediately when the rolling update starts. Such that now when the new replica sets can be scaled up to what ports, what number of ports, they can be scaled. And remember, this max search is 30%. Such that the total number of ports and the total number of old and the new ports do not exceed 130% of desired ports. So now you can see an example. If we have 3 replicas and we set this value to 30%, so total will be 130% of 3 replica is 3.9 or something. So which we round it up, so it becomes 4. So the total number of ports cannot exceed more than 4 at one point of time, and those total number of ports include the old port and the new pod, old pod with the current version, and the new pod with the new version to which we are trying to update to. Once old pods have been killed, the new replica set can be scaled up further, ensuring that the total number of pods running at any time during the update is at most 130% of the desired pod. So that is during the upgrade. What is max unavailable? Max unavailable. So this is also an optional field. It specifies the maximum number of pods that can be unavailable during the update process. See, right now we discussed how much more pods you can create. So if you have replica 3 and 130% is the max search we have given, you can go up to 4, 3.9, which rounds up to 4. But there is another setting called max unavailable. If during the upgrade, the Kubernetes decide based upon your settings that it needs to, instead of 3, can it be 2 or can it be 1? So that you can decide. So how do you decide that? You decide that based on this max unavailable setting. So, so again, like in max search, this number could be absolute number or percentage of desired port. For example, 10% you want out of, whatever total number of ports are available, you can manage with 10% can be unavailable. So absolute number is calculated from the percentage by rounding down. This number cannot be 0. And the default value is 25%. Now let's see. For example, when this value is set to 30%, the old replica set can be scaled out to 70% of the desired ports. So our desired ports are 3 and 70% of 3 is 2.1. So we round it down here in this case. So you can have up to 2 ports, max unavailable ports can be up to 2 ports. Once the new ports are ready, so this is the same thing. Once new ports are ready, all replica sets can be scaled down further, followed by scaling up the new replica set, ensuring that the total number of ports available at all times during the update is at least 70% of the desired port. So 70% is the max, available at all times. So my mistake. So when you have 70%, so 70% is availability. So 70% of 3 is 2.1, which rounded down to 2. So 2 are available, 1 need not be available. Out of 3, 1 need not be available, 2 have to be available at all times. So that's so one way to explain this would be forget about max search, focus only on the max unavailable property. So if max unavailable property you have given 30% and replica number of replica is 3, sorry, you have given 70% and number of replica is 3. So which means that at any point in time, your 70% is when this value is set to 30%, the old replicas can be sold out to 70%, correct? So we are going with this example, 30% and old replica can be scaled down to 70%. So you're given this value as 30% and the old replica set can be scaled down to 70%. So if the number of replicas is 3 and you are scaling down to 70%, which is 2.1 and rounding it down, it becomes 2. So, so 2 have to be available at all time. So you can, you can do your homework. So you can write and validate the deployment with max search and max available properties. And you can read about, more about this on this blog. So this is a blog very nicely explained about these properties. So you can pass the rollout also. So what do you mean by you can pass the rollout? This is the command to pass the rollout. kubectl set image deployment name, container image. This is the image you are setting. So if you see the help of kubectl set image deployment help, you can see update existing images of resources and possible resources you can update of pod, replication controller deployment, daemon set, stateful set, cron job, replica set. And if your image has multiple containers, because that's how you created the image, then you can set the each container image separately also. So this is the help you can see from your command line. So the process to pass is kubectl rollout pass, deployment and tips app. and you can resume using this command kubectl rollout resume deployment tipsf. And why do you want to pause it? You want to pause it because uh, you want to test new version on certain few nodes first first, and then on the few ports first before you roll it out to everyone. That's one way to handle the rollout process. Or there are tools like Argo CD which can be used for this purpose. So in Argo CD, you can control the deployment. It gives you very nice, graph, and you can see what are the ports having the new version, what are the ports having the old version, and you can control all of that. And then once you're happy, then you can deploy the new feature or new image on all the ports. So Argo CD also helps you to do that. You can block the bad versions when a buggy code is pod is getting ready. Then there is a setting we discussed. Min ready seconds is a time till which the port readiness is awaited, and there's a readiness probe. So it is used to check if app is ready before the min ready second time. So let's say min ready second time is 10 seconds, and in readiness probe you have given the URL. Let's say new feature URL, and readiness probe will check that and get an exception, and that is before this min ready probe. So once that happens, then pod is not considered ready, and it won't be made live and will be rejected. But you have to set this up. There are some additional rollout config. By default, after the rollout, uh, can't make any progress in 10 minutes, it's considered as failed. So if you have done the rollout and there is no progress in the ports, because of whatever reason, the something has gone wrong, and in 10 minutes there has not been progress, the ports are not getting updated to the latest version or image, then it will be considered as failed. uh, and you can see the kubectl describe deployment command. This is command, and it will show you the progress deadline exceeded condition. That deployment has not gone through because the deadline of 10 minutes got exceeded. And you can set this progress deadline in seconds in the deployment YAML also. So if you don't want 10 minutes, you want 1 minute, 5 minutes, or 20 minutes, you can set that up. So within that time, if the pod is not getting updated, it will be considered as failure, and this happens during the rollout only. So that's about the rollout, the deployment and the rollout, and the various versions, how this get updated, how to block, how to do rollout to specific versions. So thanks for watching. Next time we will start about the stateful applications in Kubernetes. So far what we have discussed is all the application when pod crashes and new application comes. It doesn't need to maintain any state. So new application comes without any consideration about state. But what if you build stateful applications? Most of the time stateful application means you are maintaining some class level variable or some state in your application in the memory, and once your pod goes down, you lose that state. So now how to bring the new pod, how to design such applications where you take care of this state management of the pod, so that when the existing pod crashes, the new pod comes up and the state management gets taken care. So we'll discuss that in the next session. Thank you for watching. Hello everyone, welcome to this session of stateful application on Kubernetes. This is part two of stateful application. If you have not seen the part one, I will recommend you go and watch that, and then you can watch this part two. This will be the last video on the Kubernetes topic. I might add few more videos after some months, but at least for now, this will be the last video on the Kubernetes topic. So in the last video, we discussed what are the stateful sets, and if you have a stateful application, how to deploy or how to set that up on the Kubernetes. So we did discuss the mostly theoretical aspect. In this session, we'll see a demo, and for this demo, I have developed a I have developed a stateful app. It's pretty simple Spring Boot app, and walk you through. So what the way it works is, and this whole code base is in GitHub, and it's public, so you can clone this if you want. So we have this tips controller. In this tips controller, there is a stateful service which has been injected into this using AutoWired, and only thing this stateful service does is a service, and only thing it does is it has a class level variable called value, and it has two methods, set value and get value. So when you call set value and pass some value, this method will set the value of this class level variable to whatever is being passed. And when you say get value, it will just return whatever is the value of this variable. And this service is being accessed from these two methods in the controller, set stateful and get state. And if you see in the set stateful, it is exposed as a REST endpoint called with slash set state, and it passes some request parameter, and whatever request parameter is being passed, it's being taken as input data. This input data is being set as is being passed in the set value method of the service. So there's another REST endpoint called get state. This get state method returns the value of this service.getValue. So basically, what we want to see now is whatever we set it here, we should be able to get the same value back. And the way we'll do is we'll have a stateful set with two replicas, and each of this replica will have its own state. So we'll set the state of first replica, and we'll try to get that state back, and we'll set the state of second replica, and we'll get that state back of the second replica, and we'll make sure by setting the state of second replica, we have not changed the state of first replica. So this is a demo we'll do. So let's see what is involved in setting this up. So this is the Spring Boot app I have already explained you. Now, because this is if you are adding this for the first time, then you will need to build the image. This is a command to build the image: docker build -t tips-stateful, and then where docker file is. So I might already be having this. So let me quickly check that. Okay, I am not logged into Docker. Just give me 1 second. I will log into Docker and then run this command again. So I have logged into the Docker now, and I ran this command docker images. So I already have this image created, some weeks back, and you can see this image. This is the image name, and this is the version of the image, and this is what I'm creating. If you don't pass anything after colon, the name of the image, and then :, it will automatically be taken as latest here. So which is what it is showing here also. Now, to create the stateful objects, as we discussed in the last session, I will be creating persistent volumes, and excuse me. And if you do create persistence volume, if dynamic provisioning is not supported, so I'll create some persistence volume here. Then we'll create a governing service. We discussed about governing service. It's a headless service required by the stateful set, so that we can, this stateful set has some, it is accessible by some host name or something. And after that, we'll create stateful set. So first, let's see the persistence volume. And this is the YAML which I'm using to create the persistence volume. So let's see this YAML. Excuse me. The kind is persistence volume. The name is local-pv1. Remember this name. We'll be using this name further in the demo. This is a 20 GB capacity, and this is access mode. Read write once. One client can use it in read write mode, and read only many. Many clients can use it in read only mode. And persistence volume claim policy is retained. We don't delete this volume when the persistence volume claim is removed. We don't want this to be deleted. The volumes, persistence volumes, and the persistence volume claims are explained in the in a couple of videos, persistence volume part 1 and persistence volume part 2. Please, if you have not watched those, please, I request you to watch those to get more understanding about volumes. And the host path, we are giving the the local path only /temp. And let's see if there's any persistence volume already existing. If not, then we'll create one. QCTL get persistent volume. Oh, I have it created. So let me do one thing. Let me delete those. I'll create again. Delete persistence volume pv1 / I'll delete everything pv2. I had created the rest just for experimenting. I was doing some experiment about something else. P3. So those got deleted. So right now there is no persistence volume. So what I'm going to do now is I'm going to create a persistence volume, create kubectl, create -f, and then this. So it got created. Now let's see the persistence volume again. And I have this persistence volume, right? So whatever I specified here, retain is the policy here, and read write once, read only many. All those things are, access. These things are under access mode. Capacity is 20 GB. This is what I have given here. So we created the persistence volume. Now let's see the next step. We are going to create governing headless service. It's needed to provide network identity to the stateful pods. We discussed that in the last session. So this is the headless service YAML. So let's see that. Get headless service YAML. So it's same. The type is service. This is the service name. The cluster IP here is none. So once you make cluster IP none, it makes this service as a headless service. Excuse me. And selector is app equal to SFS1. I'm a stateful set one. I meant. Remember the selector because the ports with this label will be part of this service. And this is the port HTTP 8080. So let's create that actually first. kubectl create -f headless service. Oh, this service already existed. So let's delete that. kubectl. Delete. This is the name. As we see, this service got deleted. Let me create it now. So this service got created, and you can see that kubectl get svc. So this service got created just now, 11 seconds back. Now we are going to create the stateful set now. So let's review what the stateful set YAML looks like. Get stateful set YAML. So this YAML, this is YAML about stateful set. This is a type. This is the name of the stateful set, and remember this name will be seeing that in the stateful set kubectl command. This is a service name for stateful. This service name is same as the service which we just created. This is the label, match label, apps equal to sfs1. Now this is the label we have given in the stateful set. It has to match the label which we are giving the template. This template is a port template. The replica, a number of replicas for this stateful set is 2. And this is a port template. Port template has metadata labels as app sfs1. So now this matches this. And if you remember the service object, this also had the same selector. So now by giving this label in the port template, we are tying this to the service and to the stateful set also. This is the container information about the port template. It is same as we have been using. Important thing to note here is, we are using the, excuse me, we are giving the volume claim templates. And now before we go to volume claim templates, in this container, we are doing a volume mount of this volume, of this volume, local PV1. And this is the name actually, local PV1, you can see. So this mount we are doing here, and we are mounting on this path /var/data. And this is the claim template. Name is local PV1, spec whatever. And yeah, so that's about it. Now, what we are going to do is we're going to create the stateful set. Let's see if there's any step which I need to do. So one thing you realize that, I have given the same name local PV1 here. The local PV1 local -PV1 is the same name as I had given in the volume creation. Somewhere I had created the volume and I given this name also, correct? This is persistence volume, and in the persistence in the volume claim template, I am giving the same name. Now let's create this stateful set. kubectl create -f. So stateful set got created, and you can check kubectl get stateful set. So you'll see this is the tip stateful set, and this is the name we had given here, tip stateful set. So it got created. It had 2 replica, and both are ready. Now if you see the ports, it will have created 2 ports for this. Forget about this. These are running from some old, some earlier days. So, but focus on this. So this is the first replica, first port of the stateful set. This is the second port of the stateful set. Now we had created the persistence volume ourselves. We have created the, after that we created the stateful set. Stateful set automatically created the ports. These ports, it created the stateful set, of course, and these stateful sets, these ended up creating these ports also with the same name as stateful set, and then -0, -1, as we discussed in the last session. Now let's see. We had created the persistence volume. Let's see persistence volume claim also. So if you see, these are the 2 persistence volume claims got created. How those created? Got created based upon this persistence volume template. And this is the local PV1. This is for the first port. This is attached to first port. If you see -0, So it should be attached to this pod, and this is attached to this pod. These all are coming from this definitions which we are given here, correct? Now, what we are going to do now is we are going to run if the stateful sets, we are going to validate and test if stateful sets work or not. So we'll just go through this. This is a repetition of what I said, but let's go through that anyway. So kubectl describe stateful sets and the name. We'll check the details of the stateful set. Let's check that anyway. We have not checked that so far. Kubectl describe stateful set and this. So you can check this amount. You can check the status. Everything got created. Create claim. See, this claim is attached to this pod. It's already mentioned here, correct? Another claim is attached to another pod. And let's see, this is a container. The pod with this label, it has this container from this image. And this is the mount point /var/data from this local PV1. And yeah, more or less that's about it. Now, one thing to notice, when the number of replica in the stateful set is more than one, because you are trying to create the stateful applications, the second pod will be created only after first pod is up and ready. And this is done to avoid the race conditions. If both pod gets, if Kubernetes tries to create both pods at the same time, there is a possibility of race conditions happening and system becoming inconsistent. So now we'll test it. So now if you see at this moment, we have one stateful set deployed, which has 2 replicas. Each replica maintains its own state, and we are going to validate it. Now, how are we going to validate it? We are going to invoke the REST endpoint by setting some state and getting the state for each of the stateful set replica. Now, how to do that? We need to invoke the REST endpoint. So there are multiple ways of invoking the REST endpoint. We discussed about services. We discuss about port forwarding. But now we are going to use an entirely different way of invoking this web service. And what is that different way? We'll be using the proxy. So we can use the port forwarding for each pod or service object, but we will use the kube proxy. And we'll see the how to do that. So first we are going to do is we are going to add the state to first pod. This is the first pod. And how we are going to do? So curl -x get. So I have, first we are going to get that this pod doesn't have any state. So this is the command localhost 8001 whatever get state. It should return null because we have not set any state yet. I'm sorry. So then for the first pod with -0, the first replica of stateful set, we are going to set state to 999. Let's do that first, and then we will go to the subsequent sections. Let's see the okay. So let's start from here. So curl -x get. curl -get, and it's trying to get state, correct? So let's see. It's saying connection refused. Maybe the proxy is not enabled. Give me a second. I will enable the proxy. Yeah, so I have enabled the proxy, and this is the command to enable the proxy. Once you enable the proxy, now you can run this curl command. I think I ran it here. Yes. So for the first pod with -0, we are trying to get the state, correct, using this proxy URL. So it returns null. So now let's go back to our slides. Now what we will do is where we were. So we were We still use the get method because I've exposed the set state also as get method itself, but we'll pass this parameter data is equal to 999. And if you have seen our code, in the set state also is get, but it is expecting some data as a parameter, and it will use that value to set the state of the service object. So let's see that. So now let's go back here, and instead of get state, let's say set state, and data is equal to this. Okay, no match is found. For localhost 8000, it's default port, set 0 proxy, set state. Let's see this one more time. Curl -x, and this is set state itself. Let's just validate that once. This is set state. Okay. So apparently in the set state, we had to, put this local host, the full URL under double quotes. In the PPT I had given this under double quote, but I forgot to put while I was running this command. So I just checked that out. And so once you do that, so you got the set state of pod 1. If you try to get the state of pod 1 again, it will be 999. So now let's try to check again. So I will set it to, instead of 999, we'll set to 123. I'll try to get it now. So it's 123. So we know for pod 1, we are able to set the state. Now let's see. We are setting the state of pod 1, whether it had any impact on pod 2 also or not. We have not set the state of pod 2. When I say pod 2, the second replica instance of the stateful set, which is appearing as this pod with -1. I try to get the state. So it's null. Although I was playing around with the first instance, for first pod instance of the stateful set, it had no impact on the second pod instant. So now let me do one thing. Let me set the state of second pod also. So I'll set this state to 333 and change the pod to -1. So we had got null here first. Now set it to 333. Now let's try to get the state again. So we'll get 333. Now we have set the state of first pod instance of stateful set to 123, and of the second pod instance of the stateful set to 333. Now let's see whether while setting the state of the second pod instance, whether it has corrupted the state of the first pod instance. So let's see that. So let's try to get the state of first pod 0. So still 123. So pod 0 still has value 123, even though we played around and set the state of pod 2, which pod 2 still will have 333. Correct. So this is how you set up the stateful sets on the Kubernetes cluster. So these two instances of the pod are maintaining their state separately. So now let's moving on. So we'll move on. So we have done this testing, and this is a screenshot of the testing. When I was trying earlier, I had put the screenshot. So the outcome is same. Hence, each pod instance within one stateful set maintain its own state without interfering with the state of other pod instances. So this is the command which I had to use to enable the kubectl proxy. I had forgotten it, so I paused the recording and looked into this statement, and then realized this is a command. Now, if you delete a pod, now this kubectl proxy, once you enable, you can access the URLs without authorizations, authentications, passing those, the auth parameters into your REST client call. So once you delete a pod belonging to stateful set, the new pod will automatically come up. So let's see. Let's try to delete. And one thing, when new pod comes up, it will have the same name as the pod we deleted. It will have the same storage attached, it will have the same host name. So let's see that once. So I'll try to get the ports. So let's use this terminal, kubectl get ports, and we'll be concerning ourselves only to the stateful ports. So let's look at this first instance of the port. So let's see kubectl describe, and instead of stateful set, I will describe this port. So this is the pod. It has some local volume, this claim attached. This is the volume thing, and this is the mount. You can go into the, we can log into the pod, and I always check this, /var data. Okay. So now let's do one thing. Let's delete this pod. Let's say delete, and we will not create it. And let's see what happens. Pod got deleted. Let's see the pod. It got created again, just 2 seconds before, immediately after deleted. Now let's describe this pod again, which got automatically created by a stateful set. The 0th one, right? 0th one, yeah. So it's the same, right? So that's about the stateful sets and the pods. And when you scale down the stateful set, you're scaling down the stateful set. The pod with the highest ordinal number, which is -0, -1. So whatever is the highest, in our case, -1 is the highest, that gets deleted first. After its deletion, if needed, second pod with the next lower ordinal number is taken up for deleting. If you had 4 replicas in your stateful set and you're deleting 2, so 0, 1, 2, 3 will be the ordinal numbers. So first with 3 go, the pod with the ordinal number 3 will go. Then after that, pod with the ordinal number 2 will go. Now if you see, once you scale it down, the persistence volume claim for the deleted pod is not deleted, and it's obvious. In case you want to scale it up, then this volume will get attached to that scaled up instance of the stateful set. Excuse me. This is the last slide. So node failure handling. So when a node fails, so remember, the stateful set maintains the pod. We deleted the pod, stateful set brought it up again. But when the node fails, what happens? So let's see that scenario here. So when a node fails, pod on that node can't serve the request anymore, obviously. Now stateful set pods cannot be created unless it is known for sure that pod is not present. After the node failure, Kubernetes does not know if pod is deleted or only kubelet has stopped responding. Hence, stateful set can't start a new pod, as it cannot risk a new pod with the same name for statefuls. See, when the when the node crashes, Kubernetes control plane will only know that it is not getting the response from the kubelet deployed on that node. Now it does not know for sure whether this is a temporary issue or it will go on for some time. In generally, if the node has crashed, Kubernetes should be able to spin up the ports for the stateful set on that crash node to some other node. But Kubernetes does not know that this node has really crashed. So if you really want to create the pods yourself, because when I say you, I mean the Kubernetes admin, they need to go and create, delete the pod manually, whatever were there on that crash nodes. So they delete the pod manually, or you can delete the whole node also. So but remember, when you delete the whole node, there will be certain pods from not just from this from the stateful set which you are looking for, but from other deployments or stateful sets, etc., might also be running on that node. And if it is from deployment or stateful sets, they will get restarted on some other node. But if it is if it's just a pod without stateful set or deployment or anything, then you might lose that pod completely. So do your due diligence. Now, when port status is unknown, we have seen this, right? In this kubelet is not sending the port status. So for when it is unknown for a longer duration, for more than certain minutes, and this time, as I mentioned here, is configurable. So when it is unknown for more than certain time, then port is automatically evicted from the node by the by the Kubernetes. This we are talking about port status, sorry. So when port is not responding, status is unknown for more than certain threshold, then it will be evicted from the node. This is done by the master, the control plane, by deleting the port resource. It will delete that port resource from its metadata. You don't delete that port yourself because master control plane is doing that for you. But you can tell the control plane to delete the ports forcibly. If you want, you can do this. You can say kubectl delete port name, and give -" force and give the grace period to 0. That means immediately it will be deleted. So if you want, you can delete that as well. And then, as we saw, once you delete a port from the, once you delete a port from the stateful set, another stateful set will bring up the another port, replacing that port. So that's about the stateful sets. So I hope you understood understood whatever is explained. And if you have any questions or comment, please feel free to add that in the comment section. So with this, basically I cover almost all the Kubernetes topics which are needed to perform day-to-day things with Kubernetes. By the way, this is the link, Kubernetes. This is the link of Kubernetes documentation about stateful set. Please go and read this also. There are more. There is as with any software engineering topic, there is more to Kubernetes than just this. So if you want, you can read further on Kubernetes. One is custom resource and custom resource definition. This is about we have seen we have only dealt with the resources provided by Kubernetes, whether it is pod or service or cron job or just now stateful set or deployment. But what if you have certain requirement which cannot be fulfilled by any of these resources? Then you can create your custom resource on Kubernetes. Kubernetes does allow you to do that using custom resource and custom resource definition. Then please go and read about Argo CD and Helm charts. So these two frameworks do similar thing basically. These are mostly used for deployments. Istio is a service mesh implementation. Please go and read more about it. Kustomize is a very lightweight. It's not very difficult to learn. It's very lightweight, where you can customize your the YAMLs. Basically, you create some different sort of customized YAML and pass some sort of parameters or configure that in the customized YAML. So these are the things which you want to read yourself. More on Kubernetes if you feel interested. So that is it from my end. So with this, I finish the videos on Kubernetes. Thank you for watching. Hope my videos are very helpful to you. For any comment or for any feedback, please feel free to comment, add in the comment section or reach out to me. Thank you very much. Goodbye.